Good evening everyone. Welcome to Gate Academy Global. So everyone just confirm me audio and video everything is perfect. Okay, just confirm me audio and video everything is perfect. Okay, so today is the last session for network and we have discussed all the topic except magnetic circuit, okay, and except three-phase circuit. Today I am going to discuss resonance part as well as complex power part. Okay, so just confirm me audio and video quality is perfect or not. Okay, and this was the last problem which okay we have discussed in the class. So in this problem actually you have find it out wrong a partial fraction constant value or we did wrong. Okay, so first I will complete this part and then we will start resonance. Okay, so once confirm me just okay. So audio and video everything is going to be perfect or not. Okay, so this was the last problem which was we were discussing in the class. So this was very basic problem here. IT versus VC plot, which plot will be the actual answer. So IT versus VT value you have to find out. Already we have solved this question. Okay, again I am going to solve here. Initial value is given 0. So this is LC circuit. So IT you can also say this is capacitor current. You can say IT, and this voltage is nothing but capacitor voltage. So you can take the answer. Answer was your option B. But sir, how we can get exact value? So you can solve this network and you can find out the value of IT and VT. So already we did by using Laplace transform. So by using Laplace, this was 5 by S, which was closed. Inductor initial value was 0. So here voltage, we know very well how we can represent inductor in Laplace domain. This is Ls. So L is 1. So this you can write S only. And here this is capacitor. Here this capacitor is 1 upon Cs and 1 initial voltage source. So voltage source is here again 0. So only this is 1 by Cs. C is 1. So 1 by S. And here you can say the voltage is V of S and here this current is I of S. So easily we can find out IS. IS is nothing but 5 by S, divide by S plus 1 by S. Can I write? So IS is nothing but 5 by S. Is nothing but voltage. Voltage is your, this is 5 volts. So this is 5 by S. 5 by S divide by S plus 1 by S. Okay, voltage divide by impedance. Okay, now if you will solve this, so what you will get, this S and S will be cancel out. 5 by S square plus 1. So easily you can write here IT value. This is a Laplace transform of sine AT. So this is nothing but 5 sine and A is 1. So can I write 5 sine T? And this answer is valid for T greater than or is equal to 0. Now, sir, what is the value of Vs? So we can write the value of Vs here. Can I write Is into this 1 by S? So Is into 1 by S is nothing but this is 5 by S divided by S plus 1 by S into 1 by S. This S and S will be cancelled out. You will get here okay, another way, directly I can put this value here. Directly can I put this value? Yes, Is 5 by S square plus 1 into 1 by S. Okay, so from here you can do partial fraction. Okay, so partial fraction you will get Vs is equal to, you can write A by S plus this is Bs plus C divide by S square plus 1. Okay, so partial fraction. In last class just I have written the what will be the value of numerator. Okay, so you have tell me sir minus 5. No, here this is Bs plus C. So if you will solve here, A you will get 5. So this is nothing but 5 by S, and B you are getting minus 5S, and C you are getting 0 divided by S square plus 1. So easily partial fraction you can do. So from here if you will do inverse Laplace, so Vt you will get, this is 5 by S is nothing but only 5 ut, and already this answer is valid for T greater than 0. So directly I can write 5 minus 5. This is again cos T. So this is cos AT, A is 1. So this is cos T. And this answer is valid for T greater than 0. So IT and V2 you have find it out. So how you can solve this question? So either you can solve IT and VT in within 1-2 minutes easily we can handle. So now you can see at t is equal to 0, if you will find at t is equal to 0, this is sine 0, sine 0, sine 0 is 0, and here cos 0, cos 0 is 1. So 5 minus 5, VT is 0 and IT is 0. So at t is equal to 0, if I can write here one table, this is t, and here this is IT, and here this is VT. So at t is equal to 0, IT is 0 ampere and VT is 0 volt. Both are 0, 0. So you will get 1 point here at t is equal to 0. Can I write 1 point, 1 point and 1 point? So in all the 4 options you have this point. So now if I will put here 180 degree, suppose 180 degree, I can put here 0, t is equal to 0. Okay. In another way, I can write the value of omega t. I can write the value of omega t. Omega is 1 here. Omega is 1 here. So can I write omega t is 0. 0 degree I am going to put. Then I can put 90 degree. Then I can put 180 degree. So at least we can get some points, and so that you can put the correct answer. At 90 degree, so you will get IT 5 sine 90 is 1. So you are getting here 5 ampere. At 180 degree, so again you are getting this is sine 180, sine 180 is again 0, so again you are getting 0 ampere. Okay, so current you are getting 2 times 0 till 0 to 180 degree. Now come to the voltage. So at 90 degree, this cos 90 is 0, so you are getting 5 minus 0, so you are getting here 5 ampere. So at 90 degree, both voltage and current is 5 ampere and 5 ampere. Now at 180 degree, so at 180 degree, this is minus 1, minus minus plus 5 plus 5. This is 10 volt. This is not ampere, this is volt. This is volt. So you are getting at 0 degree and 180 degree, at 0 degree and 180 degree, current both 0, 0. So you are getting 2 times current 0, 0. So you can see this current here, this is negative value, and voltage always are positive. So definitely this cannot be answer. Okay. Now here in this diagram, if you can see, current is here 0. Here I can write this is 0 ampere, 0 volt. Yes. Here what I can write 10 volt, 0 ampere. Can I write here what I can write? This value is 5. This value is 5. So here this is 5 volt, 5 ampere. So can I write this is 0 degree, this is 90 degree, you are getting 5 ampere and 5 volt. At 180 degree 10 volt but 0 ampere. This point you will get at 270 degree, and again this point you will get 360 degree. So at 270 degree, definitely your answer will be current will be negative and voltage will be 5 volt. You can put the value 270 degree. So here sine 270, this is minus 5 ampere. So this is minus 5 ampere. This is minus 5 ampere, and voltage you are getting that is again this is 0. So you are getting 5 minus 0, this is 5 volt. At 360 degree, again this is 360 will be equal to 0, this is 0 and this is 0. So this will be 0 degree, this will be 90 degree, this time will be 180 degree, this time will be 270 degree, and this time will be 360 degree. And 270 degree, your voltage is 5 volt and current is minus 5 ampere. Okay, so like that exact value you can find out here. Okay, but in GATE exam, by concept easily you can handle within 30 seconds. Okay, so just I want to tell you, in last class you have find it out this value wrong. Okay, so now, okay, I hope everything is clear. Yeah, good evening everyone. Yeah, Mr. K sir, only one problem with GATE Academy, no one update their GATE Academy line. Yeah, live class app, that is a technical issue. Okay, so it is better you can contact with technical team. Okay, so just you can get update from the technical team. Okay, I will share your information to technical team, but at least you have to contact. Okay, now I hope this problem is clear to you. Okay, so once just confirm me this problem is clear. Okay, now I am going to start resonance. So now I am going to start a resonance. Okay, now so this is a LC circuit. You can also say, sir, this point, at this point, okay, current is 0, voltage is maximum, this is maximum voltage. Okay, in this point current is 0, voltage is 0. In this point current is 0 but voltage you are getting maximum. Okay, so maximum voltage you can also find out. This question you can also handle after completion of a resonance. So most of the LC circuit is also you can apply the resonance concepts. Okay, but this is the exact solution for this question. Okay, now next topic I am going to start, that is resonance. And again I will say, if you will see, sir, AC circuit is easier part. Sinusoidal steady state analysis, what you have to do only, you should remember phasor diagram, locus diagram. Only you have to do, remember some basic formulas and calculation. Okay, now in resonance is a conceptual topic. In whole network analysis, this is a conceptual topic, but if you are comfortable, easily you can handle any question from the resonance. So first you should know, sir, what is exactly resonance. I hope you know very well, sir. Resonance in a circuit. So one thing you should remember, resonance will be only happen in a LC circuit or RLC circuit. So I say this is only happen in RLC or LC circuit. Only in RLC circuit and LC circuit, when both the energy storing element are present in the network. Okay, now sir, at resonance, what is the behavior of circuit? So I can say this is at resonance. Okay, now at resonance, again at resonance, sir, circuit behavior is resistive. Circuit behavior is purely resistive. So what do you mean by this? Purely resistive means, if you have studied phasor diagram, in phasor diagram in RLC series circuit and parallel RLC circuit, we have studied three conditions. When VL is greater than VC, VC is greater than VL, and VL is equal to VC for series RLC, or you can say XL is equal to XC. So when impedance of inductor and impedance of capacitor is same, what do you mean by this? So the meaning of this is, both the energy storing element are delivering or storing the same amount of energy, and at any time energy across both the element is the same. So you can consider like this, a pendulum. So we have suppose one pendulum. Okay, so one time this will reach to here, this will reach to here, but total energy, and this will always penetrating. So you can say here total energy is always constant. So at across the inductor and across the capacitor, always total energy is same. Only energy is going to be transferred 1 to second, 2 to 1, first to second, second to first, like this. So this situation is exactly called, that is resonance. Now your question, sir, why we are studying the resonance? So the, if you any circuit having RLC, so what is our target? Our target should be power factor. Our target should be power factor, and power factor of any circuit should be 1. So if a power factor of any circuit is 1, so we can say that is a best circuit in terms of power consumption. Can we say yes? So now this is our duty. We have to operate circuit at resonance. So here at resonance, circuit behavior is purely resistive. So what is the power factor in this case? So this is a unity power factor. So this is the reason all the RLC circuit, we will try that circuit should be operate in resonance. Resonance means unity power factor. This was exactly our target. So what was our goal? We want to operate every circuit at unity power factor, so that in terms of power, the circuit operation is better. Okay, so now, so this is the main reason. Okay, now the next point, here at resonance, if power factor is unity power factor, so what you can say, impedance angle. So impedance angle will be 0 degree, or admittance angle will be, what you will say, admittance angle will be 0 degree. Don't say sir 1 upon 0 degree, that is 1 upon 0 degree. It means 0 degree, you can write minus 0 degree, and 0 minus 0 is same. So impedance angle, or you can say admittance, this is admittance angle, both are 0 degree. It means voltage and current are in same phase, Okay, so this is the basic things you should know about resonance. Circuit behavior is purely resistive, yes sir. Power factor is unity power factor, yes sir. And impedance angle or admittance angle is 0, and phase difference between voltage and current is 0 degree, it means voltage and current are in same phase. Voltage and current are in same phase. So now here, if a power factor unity circuit behavior is purely resistive, means Z of the circuit is equal to R. This is correct or wrong? No, this statement is wrong. Okay, circuit will be purely resistive. This is very important point. Circuit behavior is purely resistive, but you cannot say at every situation circuit impedance will be equal to the R. No, it can be more than R, it can be less than R, it can be R can be infinite, R can be 0. There are lots of conditions, but yes, this is purely resistive. So if I will write here, this is Z, so this is Z real part plus the Z imaginary part. So here at resonance, this imaginary part will be 0. So at resonance, imaginary part will be 0. So what I can say, this Z will be is equal to Z real part. Only you will get a Z real part at resonance. Then sir, what will be this Z real value? There are 5 value can be possible. This ZR can be equal to R. This ZR can be greater than R. This ZR can be less than R. This can be here very high resistance. So here R can be infinite. R can be infinite means this can be open circuit. And one more answer can be possible. R is equal to 0. And this is nothing but short circuit. So at resonance, circuit impedance, 5 answer can be possible. So Z can be equal to R, Z can be greater than R, Z can be less than R, and Z can be open circuit, Z can be short circuit, but it cannot be imaginary. This is most important point which you should know. This is most important point which you should know. Clear this point? Many times student will write at resonance circuit impedance will be is equal to R. That will depend on series RLC, parallel RLC, neither series nor parallel, mixed kind of RLC circuit. So there are so many conditions can be possible. This is the important point. Okay, yeah. And now you are saying for unity power factor, sir, XL is equal to XC. No, always you cannot say. Okay, already we have studied series RLC circuit phasor diagram and parallel RLC circuit phasor diagram. And in that for series RLC, XL is equal to XC, then unity power factor, that is correct. Okay, and VL is equal to VC, then unity power factor, that is correct. And for parallel RLC circuit, YL is equal to YC. But you can also write if YL is equal to YC means XL is equal to XC. But voltage is not equal to, but current is same, IL is equal to IC, then unity power factor. But if neither parallel nor series circuit, then you cannot write at unity power factor. You cannot write here at unity power factor, sir, XL is equal to XC. No, always you cannot write this thing. Always you cannot write, sometime this can be possible. Like this, always you cannot write here, this is equal to R. Clear my point? This is the important part. So don't write right now at unity power factor XL will be is equal to XC. This will be depend on the circuit. This will depend on the circuit. Clear this point? This will depend on the circuit. This will depend on the circuit. Okay, now. Okay, so now first I am going to start here series and parallel. Here initial we will study series RLC and parallel RLC, then I will also discuss tank circuit and some different circuit, and then examiner can ask you any circuit. So what generally we will study here, generally we studied series RLC, parallel RLC and tank circuit, and there are so many combinations in the tank circuit. Tank circuit means there RL and RC or RL and C are connected in parallel, that is called tank circuit. Now, so first I am going to start here series RLC at resonance. Series RLC at resonance. Series RLC at resonance. Okay. Now, today's session will be very important. I will discuss lots of things, and if you don't know anything in resonance, then after you can handle anything in resonance. Okay. So now, patiently you have to watch the lecture today, and if you will get any doubt you can ask me. Now, so for series RLC circuit at resonance, so suppose this is R, this is L and this is C. Already phasor diagram we have studied. This is R, I can write this is J omega L, and this is you can write 1 by J omega C. Can I write? Yes. Here voltage I can write this is plus minus VR. Here I can write this is plus minus VL, and here I can write this is plus minus VC. Okay, and current is same, so I can write this is current I and this supply is voltage V. Can I write in this way? Yes. And this is plus minus, and here omega is frequency is omega. Frequency is omega. This is series RLC circuit. This is series RLC circuit. So at resonance, first right now this is basic circuit. Now at resonance what will happen? So first I can write here two equations. In series RLC you can write voltage equation or impedance equation. So voltage equation will be directly can I add, already we have studied VR plus J VL minus of J VC. You know very well for series RLC circuit, voltage across inductor you can write JVL and voltage across capacitor minus JVC. So this is nothing but VR plus J VL minus of VC. Can I write in this way? Yes. Now similarly Z, impedance of this circuit, what you can write? R plus J, can I write omega L minus 1 by omega C. Can I write? Now at resonance what will happen? So at resonance, okay, frequency I can write omega is equal to omega 0. We can write frequency omega is equal to omega 0. At resonance, imaginary part of V, I can write here imaginary part of V is equal to 0. And we can also write imaginary part of Z is equal to 0. Or you can write imaginary part of Y is equal to 0. Anything you can apply. Anything you can apply, or you can write, sir, imaginary part of current is equal to 0. So you have four choice. At resonance you have four choice. Then you have to think for series, for parallel, or for any kind of circuit which will be easier for you. So you have four choice. Either you can find out current, total circuit current, and that you can equate imaginary part of that current equate with 0, impedance equate with 0, admittance equate with 0, or voltage equate with 0. So for series RLC, easily we can write two equation, voltage and impedance. So either voltage you can do 0 or impedance you can do 0. So here if you will do voltage 0, so at resonance at omega is equal to omega 0, VL minus VC is equal to 0. It means inductor voltage is equal to capacitor voltage. So if inductor voltage and capacitor voltage is same, so you can say circuit is in resonance. Yes, sir. And now if omega L, so I can write this frequency is omega 0. So omega 0 L minus 1 upon omega C is equal to 0. Then if you will solve this, so from here what you will get, sir, omega 0 L is equal to 1 upon omega 0 C. Omega 0 square is equal to 1 upon LC. So from here can I write omega 0 is nothing but 1 upon root over LC. Everybody know this answer. So what is the resonance frequency of series RLC circuit? 1 upon root over LC. Now the important thing, every time don't write this formula. This will depend on the circuit. So for series RLC circuit, what is omega 0? 1 upon root over LC. So if you know L and C, so directly you can write resonant frequency. One important thing, omega 0 not depend on, omega 0 not depends on value of R. This is the important thing. So value of R will not decide what will be the omega 0. Omega 0 will be the function of L and C. This is the important thing. So in this question omega 0 is a function of L and C. Okay, for series RLC. Okay, later we will discuss. So sir, what will be the impedance of this circuit at resonance? So I can write here, sir, Z at omega 0. So impedance at omega 0, what you will get? This part will be 0. This is equal to R. Sir, what is the voltage at resonance? So V at resonance is nothing but VR. So this voltage and VR, both voltage will be same at resonance. Remember, this voltage and this voltage will be same. Circuit impedance will be is equal to this R. Sir, what will be the current at resonance? So sir, current at resonance is nothing but, what is total circuit current? V by Z. So V by Z at omega 0, and Z at omega 0 is R. So this is nothing but V by R. So all this value at least you can write at omega 0 at resonance. Clear this point? So everything will depend on, sir, this formula is valid for series RLC or for any circuit, or for only series RLC, or for a specific circuit. So you remember this thing, sir, this Z omega 0 is equal to R. This is for a specific circuit. This is specific for, so this every answer, this is also for a specific circuit. So general answer you cannot write. Here I have written this is general thing. This is general thing, but this is a specific answer. This answer is we have find it out for series RLC, and then later circuit we will also discuss for which circuit this answer can be valid. Okay, so this thing you should know, this thing you should know. If you want to write here, sir, frequency in hertz, so here frequency in radian per second, so this is in radian per second. If you want to write in f0, so f0 will be 1 upon 2 pi root over LC. This answer is in hertz. This answer is in hertz. Okay, now here the important thing is I am going to plot, I am going to represent this graphically. I am going to represent something here graphically. Okay, now this point is very important. This 4 point is very important for resonance. So if I will plot here, so you can see here, if I will plot this resistor value is constant, and if I will write here mod of z, if I will write here mod of z, so mod of z is nothing but root over r square plus this is the omega L minus of 1 upon omega c whole square. Can I write? Yes. Now suppose if I want to draw draw r omega L and 1 upon omega c with respect to omega, separate first r, then omega L, then 1 upon omega c. So r is constant, r is independent of omega. So can I write? Yes sir, this is r, this value is r. Okay sir, when omega is 0, this value is omega L. You can write this is xl, you can write this is xl, and this you can write xc. You can also write this mod z is equal to root over r square plus xl minus of xc whole square. Can I write? Yes. Sir, what will be the xl means omega L? If omega is 0, so xl is 0, if omega is infinite. So this is a linear relation, and this L is the slope. So this is a linear relation. You will get like this, So this is the omega L. So this is the omega L. Sir, what will be 1 by omega c or xc? What will be? So when omega is 0, this will be infinite. When omega is infinite, this value is 0. So you will get this kind of waveform. So this waveform you are getting 1 by omega c. This waveform you are getting 1 by omega c. And at point where this 1 by omega L and this is 1 by omega c and omega L both is same. So both is same at this point. In this point, what is the circuit impedance? Circuit impedance is equal to R. So just I am going to draw one plot here. Now you can see this is omega, and now here this is 1 by omega c, and this is omega L. Can I write? In this point, omega L and 1 by omega is same. So this point when xl is equal to xc, so from here can I write omega L is equal to 1 by omega c. When omega L is equal to 1 by omega c, that frequency, so at omega is equal to omega 0, can I say omega L is equal to 1 by omega c? Or you can write from here, we can also write this value, sir, this is xl and this is xc. So at resonance, xl is equal to xc. So this frequency will be omega 0. Now at this frequency, what will be the circuit impedance? So here 1 by omega c and this is omega L. When this both will be subtract from here, if both is same, so z will be is equal to root over r square means r. So can I write here this value is nothing but r? So now at omega is equal to omega 0, omega L and 1 by omega is same and circuit impedance is r. So can I write this is nothing but mod z? Okay, so later I will write this mod z. Right now just you can write in this way. Now the important thing is, sir, here omega L, this value xl minus xc, I can write this is xl and we can write this is xc. So xl minus xc after omega 0 is positive. So here xl minus xc is equal to positive. Can I write? Positive. And here in this position, sir, xl minus xc is equal to negative. Can I write? So for less than omega 0, xl minus xc is negative, and for greater than omega 0, xl minus xc is positive. Yes sir. So if you can write here, if this is xl, this is xc, xl minus xc is positive, so impedance angle will be positive. So here I am going to write, you can see xl minus xc is greater than 0, means positive. Yes sir. So impedance angle phi z will be positive. Yes sir. Here what I can write, sir, xl minus xc is less than 0. Yes sir. Then what is a phi z? Impedance angle will be negative. Can I write? If this minus this is negative, this is minus z, and if this is minus z, angle will be negative. Angle will be negative. Yes. So if impedance angle is negative and if impedance angle is positive, then what is the circuit behavior? So if impedance angle is positive, circuit behavior is inductive. So in this case, circuit behavior is inductive. And you can also say, sir, XL is more than XC, and this is for series RLC circuit. In phasor diagram, already we have studied, if XL is more than XC, then circuit behavior is inductive. Then circuit behavior is inductive. So you remember, for greater than omega 0, circuit behavior is inductive. So if circuit behavior is inductive, then what is the power factor? So here power factor is equal to lagging, is lagging power factor. Now in this case, here circuit behavior is capacitive, and if circuit behavior is capacitive, power factor is leading. So you remember this diagram for series RLC circuit. Okay, for greater than omega 0, circuit behavior is inductive. For less than omega 0, circuit behavior is capacitive. You remember only this thing, then you can discuss what can be the impedance angle, what can be the power factor. We know very well. If circuit behavior is inductive, then we can say impedance angle is positive, power factor is lagging. If circuit behavior is capacitive, then angle will be negative and power factor will be leading. Okay, so only you should remember, for greater than omega 0, circuit behavior is inductive, and circuit for less than 0, circuit behavior is capacitive. This is for series RLC. This is for series RLC. So can I say, for greater than omega 0, here circuit behavior is inductive and here circuit behavior is capacitive. So you should know this thing. Okay, now if I will plot here mod of z. So now I want to plot this mod z with respect to omega. Then what plot you will get? I hope this thing is completed to you. Now the next important point, sir, what will be the plot? So in resonance, if you remember this graph, so at least you can handle 99% question. 99% question easily you can handle in GATE exam. Okay, now the second plot, suppose if I am going to plot mod of z versus omega, what you will get? So here this is omega 0. At omega 0, sir, what is the impedance? Impedance is nothing but R. So when this XL minus XC, here XL minus XC increasing, here XL minus XC increasing, here XL minus XC negative, but here negative scar will be again positive. So if this difference will be more, so this Z is going to be increases. So when this difference increasing, Z is going to be increases. It means you will get this kind of plot. So at omega is equal to omega 0, your mod of Z is minimum, and that is R. So can I say this is nothing but Z minimum? So at omega is equal to omega 0, you are getting minimum impedance, and that minimum impedance is equal to R. Now the important thing, at omega is equal to omega 0, circuit impedance is minimum. So you can say, sir, Z at omega 0 is nothing but this is Z minimum. This is minimum impedance of the, and this minimum impedance is nothing but R. This is R. So if impedance is minimum, so definitely circuit current will be maximum. So circuit current I at omega 0 will be nothing but I max. This thing you should remember for series RLC circuit. So for series RLC circuit, impedance you will get minimum, and that minimum value is equal to R. And if impedance is minimum, then current will be maximum. Now here some more point I want to discuss. I hope this thing is clear to all of you. Now one more plot. So one more thing you should remember, sir, what is power factor at omega 0? So this is unity power factor. So at omega 0, circuit behavior is unity power factor. Now sir, here we have one more frequency that is called omega h. Here we have one more frequency that is called omega l. Omega h is called upper cutoff frequency, 3 dB frequency, and omega l is lower cutoff 3 dB frequency. So this is nothing but upper cutoff 3 dB frequency. Definitely you should know this thing. And this omega l is lower cutoff 3 dB frequency. Lower cutoff 3 dB frequency. Okay, now then in this point, sir, what will be the value of this impedance? Both will be same, both will be same, but what will be this value? Now this value will be more than R or less than R? Yes sir, this will be more than R. Then what will be this value? This is very important thing. And now the second important point, sir, what will be the power factor in this point? So at omega 0, power factor, you know, that is 1. Okay, this is unity power factor. At omega h for series RLC circuit behavior, you know, that is a leading power factor. So here power factor is this, sorry, inductive circuit, this is a lagging power factor, but what will be the value? And here the power factor is leading, but what will be the value? So now what is my target? What will be the power factor and what will be this value? Now the important thing, in last class already we have studied power factor for series RLC circuit, this is cos phi, is nothing but R by Z. Already we have studied R by Z. So at resonance, what is the value of Z is here, that is nothing but R. But at this point, what will be the value of R? So remember this point, sir, here this value is root 2 times of R, root 2 times of R. Okay, this will be root 2 times of R. This is very important point. So at omega h, what is the value of Z? Mod of Z is nothing but root 2 times of R. So this is more than R. So if here Z is root 2 times of R, so if Z is root 2 times of R, so cos phi means power factor R by root 2 R, 1 by root 2, 0.707. You should remember this point. So in this point, power factor value is 0.707. Sometime examiner will directly ask this thing. This is 0.707 and here power factor is 0.707. So you remember this thing, at omega 0 power factor 1 unity power factor, omega h lagging power factor value is 0.707. Here this is leading power factor value is 0.707, and at omega h and omega l, what is the value of impedance of the circuit? Root 2 times of R. If you remember this thing, you can write this. If you remember this thing, you can write this thing. This thing is very important. This thing is very important. Okay, this thing is very important. Okay, yeah, good evening. Okay, so this thing is very important. Now one more thing I want to discuss here. So this plot, I hope this thing is clear to you. Now I am going to draw here one more plot. Okay, I hope this thing is clear too. Just I am going to remove this. Okay, now what will be the current? Here? So current, can I write here? Sir, I is nothing but V. Generally we are going to assume 0 degree. So generally we assume this V at angle 0 degree. You can assume this is Vm at angle 0 degree. Okay, so now I is nothing but Vm at angle 0 degree divide by Z and divide by Z. And what is Z? Z, if I am going to find out magnitude of current, so this is nothing but root over R square plus omega L minus of 1 upon omega C whole square. Okay, so I at omega 0. What will be I at omega 0? This you can write. This 0 you don't write because it is magnitude. So this is nothing but magnitude of V divided by magnitude of Z. So at omega 0, what is the current? Z is nothing but R, so V by R. So magnitude of V is nothing but Vm. So at I at omega 0, this is Vm by R. Okay, now, but this I, if I want to plot this I, so what will be the plot for this I? So this I versus omega, just I want to plot this I here. Just I am going to write. Okay, only one sided I am going to plot like this. Okay, so this is the magnitude of current of the circuit and this is omega. Okay, this is most important plot. So here we have one frequency. This frequency is omega 0. So what will be the current? So if you can see here, when omega is increases, this difference is going to be increases. So after omega 0, this difference is going to be increases, or you can say this Z is going to be increases. This voltage is constant. If Z is increases, then current will be decreases. So here you will get this kind of plot. And this point is nothing but omega 0. So at omega 0, you know very well current is maximum. So I can write this is maximum current. And what is maximum current value? I can write this is I max. And what is I max? Vm by r. Can I write Vm by r? Can I write Vm by r? So now what is the 3 dB frequency? What do you mean by 3 dB frequency? Where the current, this current value is 0.707 times of maximum value, that frequency is called 3 dB frequency. So remember when, at which point this current is I max by root 2, I max by root 2, and in this situation this frequency is called 3 dB frequency. So we can write this is omega h and this is called omega L, and this omega h minus omega L is the 3 dB bandwidth, 3 dB bandwidth. So at 3 dB bandwidth, what is the value of current? I max by root 2, I max by root 2. What is the value of impedance? Root 2 into R. This is very important point. So in this point, what is the value of current? I max by root 2. But what is the value of impedance? So you can write mod Z is nothing but root 2 into R. Remember at omega 0, mod of Z value is R. This thing is remember here at this point, mod of Z is nothing but root 2 times of R. Root 2 times of. So in one diagram, I will explain you each and everything. I will explain you each and everything. Okay, so at omega is equal to omega H. Okay, what is the value of current? I max by root 2. Why current is going to be root 2 times less? Because impedance is going to be increases root 2 times. Voltage is constant. So if impedance is going to be increases from here root 2 times, then definitely current will be decreases root 2 times. Now here, what is power factor? So in this point, power factor is equal to 1. Power factor is equal to 1. Phi is equal to 0 degree. Phi is equal to 0 degree. Here power factor is equal to 0.707. Leading or lagging? This is lagging. And circuit behavior is inductive. You know this thing. Circuit behavior is inductive for greater than omega 0. Here power factor is 0.707. So phi you can easily find out. Yes, cos phi is equal to 0.707 means 1 upon root 2. So here your lagging or leading, sir, this is leading power factor, and this behavior is capacitive. Now one more important thing you remember, this is also called omega h and omega L, half power frequency. Okay, we have written here upper cut of 3 dB frequency. The another name of this is another name of half power frequency. Why half power frequency? Power will be half. Now this thing is very important. If here power is P, so here power will be P by 2. Here power will be P by 2. Why power will be P by 2? Power will be I square into R. I square into R. So if current is going to be root 2 times less than I square, so that will be divided by 2. So if here power is P, here power will be half, just half of maximum value. That's why this is also called half power cutoff or 3 dB frequency. Okay, so this two name of omega h and omega L should be remembered to you. So lots of things I have discussed here. What will be the power factor here? What will be the power here? What will be the value of current here? What will be the value of impedance here? So everything we have discussed. Circuit behavior is, and what will be the phi will be, cos phi is 1 by root 2. So phi easily we can find out. Okay, now yes Sagun, we will from tomorrow, today network will be finished, and next 6 day I have scheduled 2 day for signal, 2 day for communication, 2 day for digital. Okay, so for next 6 day I will complete this 3 subjects into 2 sessions, signal, communication and digital. Okay, now so just you should remember this thing. Okay, if you are comfortable in this, so most of the question easily you can handle. Okay, so everybody, if you want you can draw this. Okay, now if you want you can draw this. Okay, now one important thing I want to discuss here. I hope this thing is clear to all of you now. What is the bandwidth? I am going to remove this. What is a bandwidth? What is the bandwidth of series RLC circuit? Okay, what is a bandwidth of series RLC circuit? Okay, so first two things you should remember for series RLC circuit. First thing you remember, sir, what is omega 0 resonant frequency? 1 upon root over LC. Sir, what is a mod Z at resonance? Z at resonance, Z at omega 0. You remember this value is R. Okay. Now, sir, for series RLC circuit, if you have write this current equation, I is nothing but Vm upon root over R square plus omega L minus 1 upon omega C whole square. Okay. Now if I will ask you, if I will write one equation, you can see here this equation I can write I is equal to sir Vm upon, this is magnitude of I. Okay, this is Vm upon root over R square plus this is omega L minus 1 upon omega C whole square. Can I write? Now if I will write this equation at omega 0, so now my target is you have to write this equation at omega 0, at omega h, and at omega l. Are you getting my point? This is very important term I am going to discuss. So at omega 0, what will be this equation? So at omega 0, what will be the value of this I? What will be the value of this I? This I is nothing but Vm by R. This I is nothing but Vm by R. So this is nothing but Vm by R is equal to, this is Vm upon root over, and here you can write, sir, this is omega 0 I can write, and this value will be 0 because this minus this will be 0 at omega 0. So this is Vm upon root over R square. You can write. So here you are getting Vm by root over R square and Vm by R. It means from here, if you will see this equation, you are getting one relation. So at omega is equal to omega 0, can I write, sir, omega 0 L minus 1 upon omega 0 C is equal to 0. This is first equation. So one equation you have find it out. In another way, if you will write here, you can write in this way, sir, this is root over R square plus omega 0 L minus 1 upon omega 0 square. Sir, when both the equation will be equal, then this value will satisfy. So this is first equation, and from this equation we can find it out omega 0 is equal to 1 upon root over LC. Okay, this was first equation. Okay, now the second equation. So if I want to write here, sir, at omega is equal to omega h. At omega is equal to omega h, what will happen? Yes, at omega is equal to omega h. So this current will be, here current will be I max by root 2, and I max is nothing but Vm by R. So Vm by root 2 R. So can I write this value? Sir, Vm by root 2 R. Can I write is equal to sir Vm upon root over, this is nothing but R square plus, you can write this is omega h L minus of 1 upon omega h C whole square. You can write in this way. Okay, this diagram I am going to remove. Okay, can you write in this way? Now if you will solve this equation, okay, I am not going to the derivation, but this equation you should remember. Here this omega m will be cancelled out. If you will square, you can write from here, sir, R square plus omega h L minus 1 upon omega h C whole square. Can I write? Yes, sir. And this root you can write here, and you can write here root 2 square is 2. This is nothing but this is 2R square. So 2R square minus R square. So this is omega h L minus 1 upon omega h C. Okay, this square should be is equal to, this is 2R square minus R square. Sir, this is R square. But this Vm upon root 2R, in two value you will get. At omega is equal to omega h and omega is equal to omega L. And in both the value, this is Vm upon root 2R. In both the value, this is Vm upon root 2R. Yes, sir. So this can be omega h or omega L. So right now I am writing this is omega, only omega. So right now I am writing only this is omega. Okay, so omega h minus 1 upon omega C should be is equal to R square. So here omega L minus 1 upon omega C is equal to plus minus R. Can I write this equation? Yes, you can write this equation. Here two condition is possible. So at one condition this will be omega h, and in second condition this is omega L. So two more equation we will get from here. One equation, sir, omega h L minus 1 upon omega h C should be is equal to R. Second equation, omega L into L minus 1 upon, this is lower cutoff frequency into C is equal to minus R. This is second equation, and this is third equation. So three equation we can find out from here. Okay, now you will ask me, sir, for plus r, why you are considering omega h, and for minus r, why you are considering omega l? So here you can see omega h minus omega l. If this is plus r, it means omega h l minus 1 upon omega h c. So if you will write z equation, mod of z is nothing but r plus j omega l minus 1 upon omega c. Okay, so what is the value of z at omega h? So at z at omega h, you know very well this is inductive. Circuit behavior is inductive. Circuit behavior is inductive means this difference is positive. So at omega h, this difference is positive. And sir, what is at omega l? So z at omega l, this omega l minus 1 upon omega c difference is negative because circuit behavior is capacitive. That's why we have assumed here for omega s this is plus r, for omega l this is minus r. So now for series RLC circuit, three things you should remember. For series RLC circuit, sir, omega 0 L minus 1 upon omega 0 C is equal to 0. And second equation, sir, this is omega HL minus 1 upon omega HC. This is equal to plus R. And third, sir, omega L into L minus, this is omega L into C is equal to minus R. These three equations should be remembered to you. Okay, these three equations should be remembered to you. Then, sir, what is a bandwidth? Sir, what is the bandwidth here? So bandwidth is nothing but this is called bandwidth. So bandwidth is equal to here, this is omega h minus of omega l. This is the bandwidth, and this is called 3 dB bandwidth, or sometimes we can also call half power bandwidth. So two name we can write, 3 dB bandwidth or half power bandwidth. This is very important thing. So right now you don't remember this expression, directly remember this formula. Okay, so this graph, and if you remember this formula, most of the question you can handle in resonance. Okay, most of the question you can handle in resonance. So just confirm me, this formula is clear to all of you or not? So this derivation is clear to all of you or not? Okay, can you remember this? Okay, now, so now you have finded out two equations, and if you will solve this equation, you can write the value of, from here three value we can write. So from here you can write the value omega 0. Sir, omega 0 is nothing but 1 by root over LC, first formula. From here you can find, sir, value of omega h, and here value of omega l. So in derivation I am not going directly, omega h and omega l I am going to write here. I hope this thing is clear to all of you. Okay, so now here, sir, what will be the omega h and what will be the omega l formula? So all these three value formula directly you should remember. Okay, by using this easily we can solve, but I am not going with the derivation. So first formula, sir, omega 0, this is resonant frequency, 1 upon root over LC. Sir, what is omega h and what is omega l? So omega h and omega l, anybody can tell me, do you remember this formula or not? Do you remember this formula or not? First tell me, do you remember this formula or not? Just I am going to write, this value is nothing but r by l. For omega this is plus, and here this is r by l. For omega l this is minus, root over, here this is root over r by l whole square, here r by l whole square. Okay, r by l whole square, plus, anybody can tell me? Sorry, I think okay, just tell me, anybody remember this formula or not? So this is minus r by 2l plus r by 2l. Okay, not just I am going to correct this. This is minus r by 2l. This is minus r by 2l. This is r by 2l whole square. Just I am going to correct this. Okay, I am going to write again. Okay, one formula I am going to write for omega h and omega l. What is omega h and omega L? This is nothing but a minus r by 2L. This is plus minus root over, plus minus root over. This is r by 2L square plus omega 0 square. This is same value r by 2L square plus 1 upon root over LC square. Okay, this is the formula for omega h and omega L. You should remember. You should remember this formula. Okay, now, so for omega h this is positive and for omega L this is negative. So what will be the formula for omega h? This is minus r by 2L plus root over r by 2L whole square, and this whole square I can write plus 1 upon LC. Can I write? Yes. And sir, what will be the omega L? So omega L I can write here. Omega L I can write here. Omega L is nothing but minus r by 2L. This is minus root over r by 2L whole square and this is plus 1 upon LC. Plus 1 upon LC, and omega 0 you remember. So this three value you should remember. This you should also remember. This you should also remember. Okay, if you remember this value, suppose for example, an L and C is given and R is given. RLC, you know RLC. So directly you can also put here. Directly you can also put here. And from here you will get one quadratic equation and you will get answer. You will get answer. So if suppose you don't remember this direct formula and if you remember this and RLC value you know, so omega h you can find out and omega L you can find out. So omega h and omega L easily you can find out. Easily you can find out. Okay, easily you can find out. Easily you can find out. Okay, now I will ask you, sir, what is the bandwidth? What is the bandwidth? Bandwidth is omega h minus of omega L. Can I write? Yes. Bandwidth is nothing but what is the bandwidth of series RLC circuit? So bandwidth, this is 3 dB bandwidth, 3 dB bandwidth or half power. So this is upper cutoff frequency minus lower cutoff frequency. So omega h minus omega L. So this value omega h minus of omega L. So this value minus of this. Okay, so omega h minus of omega L. Omega h. Okay, sorry. Okay, we have to correct something. Here I did some mistakes. Okay, this is always plus. This is always plus. This value is plus minus. Okay, just correct this. So this is always plus. This is plus. This is minus. This is always plus. Okay, that's why I am getting here wrong answer. Okay, so this is always plus. This is plus r by 2L and this is minus r by 2L for omega. Just you have to correct this. How you will get this value? Just you can solve this equation. So from here you will get omega h and from here you will get omega L. Okay, quadratic equation you will get. So now, so omega h minus omega L, this minus this. So this and this plus, this will be cancelled out. So what you will get here? R by 2L plus R by 2L. So this is R by 2L and this is minus of minus R by 2L. So from here we will get R by L. R by L. So this is a bandwidth of series RLC circuit. This is a bandwidth of series RLC circuit. This is a bandwidth of series RLC circuit. Now we can modify the formula. You have to correct this. Now we can modify the formula. Sir, what is omega h? So this formula, how you can remember? So this formula now you can remember in this way. So sir, what is omega h? So omega h will be nothing but this is plus R by 2L means bandwidth by 2. This value is bandwidth by 2 plus root over what is sir this value? Bandwidth by 2. Bandwidth by 2 whole square plus this value is omega 0 whole square. You can write in this way. Sir, what is this formula? So this is again bandwidth by 2 but this is minus and this is plus root over bandwidth by 2 whole square plus omega 0 square. Then sir, what is the bandwidth? So bandwidth of series RLC circuit you can write this is bandwidth of series RLC is nothing but R by L. You can also write sir this is 1 by tau. If for series RL circuit this is a tau is L by R. So one important thing here, this is not depend on C. This is not depends on C. This is a very important term. So bandwidth is not going to depend on C. Bandwidth is only going to depend on RLN. And second value is omega 0. Sir, omega 0 is nothing but 1 by root over LC. Okay. So this formula you should remember. So if you don't want to remember in this way, you can remember in this way. bandwidth by 2 plus root over bandwidth by 2 whole square plus omega 0 square. This formula will be valid for series RLC as well as parallel RLC, but this formula will not be valid for series RLC, parallel RLC. If you will remember in terms of this bandwidth by 2, this same formula you will get in parallel RLC. So one important thing you remember, bandwidth of series RLC circuit is R by L. Clear this point? So this much formula you have to remember for series RLC network. Okay, so for this formula you have to remember for series RLC network. Sometime what a student will think, if you want to calculate, suppose this was your current, this value is omega 0, here this is omega h, here this is omega l. So what is the bandwidth? Sir, this is the bandwidth. Sometime what a student will write, sir, this is bandwidth. So sir, what is this value? Bandwidth by 2. So can I write omega 0 plus bandwidth by 2? So what is omega h? So sometime what a student will write, sir, omega h is nothing but omega 0 plus bandwidth by 2. And what is omega l? Is equal to omega 0 minus of bandwidth by 2. Sometime a student will write this. So if you will see here, what is omega? Bandwidth by 2, yes, plus this complete value is, means you are neglecting this value. If you will neglect this value, so root over omega 0 square is omega 0 plus bandwidth by 2 you will get, and here this is omega 0. If again you will neglect this value, then you can write omega l, but this answer is practically wrong. This answer you cannot use every time. Generally in GATE exam or in any exam, generally a student can use this formula, but this is not always equal, this is near about equal. So my recommendation, don't use this formula to calculate omega h and omega l. Clear this point? So don't use this formula to calculate omega h and omega l. Clear this point? So if you want to calculate this, first you can calculate the bandwidth and you can calculate the omega 0 square, means everything is depend on RLC. So here this is LC, RL, only depending on RLN. So omega h, so can I write here omega 0 is a function of L and C. Omega 0 is a function of L and C. Sir, omega h is a function of R, and here this is L and here this is C. Omega h is a function of RLC, and similarly omega L. Omega L and omega C is a function of RLC. Omega 0 is a function of L and C. And sir, bandwidth. Bandwidth is a only function of R and L. Okay, this thing you should remember. So this formula you should remember. Don't apply this formula. Generally, what a student will do, this is bandwidth by 2, this is omega 0, and you will get wrong answer. This is the most important. Point where generally students are getting wrong answer. Okay, so I hope this series RLC circuit at resonance is clear to all of you. Okay, I hope this thing should be definitely clear to all of you. Okay, so now I am going to draw one table. And that table you should remember. I hope this thing is clear to you. Okay, now. Okay, now just I am going to draw a table. Okay, suppose first column I am going to take omega. First column I am going to take omega. Then I have to draw omega L minus 1 by omega C value. Omega L minus 1 by omega C value. Then what will be the mod Z? Impedance. Impedance is nothing but root over R square plus omega L minus 1 upon omega C whole square. Okay, now, and in next table, what will be the angle of Z? Okay, angle of Z. What will be the angle of Z? So now first value I am going to consider. Here three cases I am going to consider. First, omega is equal to omega 0. So at omega is equal to omega 0, what is the value of omega L minus 1 upon omega c? You will write here omega 0 L minus 1 upon c, and that value will be is equal to 0. That value will be is equal to 0. And similarly, at omega is equal to omega h, at omega is equal to omega, this value is plus r, this value is plus r, and at omega is equal to omega L, this value is minus r. This thing you should remember. Okay, now this thing you should remember. So now what will be the impedance at omega 0? You know very well, sir, mod z is nothing but is equal to r. Here mod z is nothing but root 2 times of r. Here mod z is nothing but root 2 times of r, root 2 times of r. And now, sir, what is the angle? What is the angle? So here what is the impedance angle? Here impedance angle I can write phi z, or you can say angle of z. So what is the impedance angle? Unity power factor. So here this is the unity power factor means 0 degree. So I can also write here power factor. Power factor here unity power factor means cos phi is equal to 1. Cos phi is equal to 1. So now, sir, what will be the here phi z and what is angle z? What is here phi z, or you can write angle z, angle z. Here you know what is power factor. Cos phi is equal to 0.707, and that is leading or lagging. At omega circuit behavior is inductive, so this is lagging, this is lagging, and here cos phi is equal to 0.707, and sir, this is leading. Now important thing, cos phi is 1 upon root 2, so phi is 45 degree, phi is 45 degree. So here angle will be 45, yes, here angle will be 45, but which one will be positive, which one will be negative? So if power factor is leading, means circuit behavior, can I write here capacitive, and can I write here capacitive, can I write here circuit behavior is capacitive, and here inductive. If circuit behavior is inductive, then impedance angle is a positive, yes sir, and if circuit behavior is capacitive, impedance angle is negative. So this thing you can also write. Everything is going to be a recall, everything is going to be a recall. Then what will be the current, sir? Then what will be the current? What will be the magnitude of current, sir? Magnitude of current is nothing but you can write Vm by mod z. Can I write? Yes, already mod z you have calculated. So what will be the here current? Vm upon mod z is r. So can I write Vm upon r? Or you can also write this is nothing but I max. This is nothing but I max. And what will be the current at omega h? So here I can write, sir, Vm upon z is root 2 times of r. So you can write this is nothing but, sir, I max by root 2. And here again this is Vm upon root 2 into r. Sir, this is I max by root 2. So this table will be very important for series RLC circuit. This table will be very important for series RLC circuit. Okay, series RLC circuit. So this everything you should know. This everything you should know. Okay. So this is for series RLC. Same. So for parallel RLC circuit, just I will write down the formulas. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Just confirm me. If anybody have any doubt here, just tell me. Okay, if anybody have any doubt, just tell me. Okay, so if I will plot Z, if you will plot Z, suppose phasor of Z, so here you will get Z minimum. Z minimum means you will get I max, and here this is Z minimum is r, angle is 0. Here you will get 1Z, here you will get, this is for omega is equal to omega 0. Can I draw? Here this is for omega is equal to omega h. At omega h you can say angle is plus 45. So can I write this is 45 degree? Omega is equal to omega h, and here Z. Here this mod of Z is nothing but how much? Root 2 times of r, root 2 times of r. Can I write? And here this is at omega is equal to omega L, and again here angle is 45 degree, but this will be minus 45 degree. And can I write here what is a mod of Z? Mod of Z is nothing but root 2 into r, but angle is minus 45 degree. So this I have written a phasor of impedance with respect to frequency, with respect to frequency. Clear this point? Okay, now now we are going to start parallel RLC circuit at a resonance. Clear this point? So now for parallel RLC, this table we will write for the parallel RLC. Okay, so this thing if you want you can note it down. So same thing just I have written here, same thing this and this I have written here. Okay, I hope this thing is clear to all of you. Now we are going to start parallel RLC circuit. Now parallel RLC circuit, So now if I will revise in series RLC circuit, what you should remember, first omega 0 1 upon root over LC. This relation already here written, so again I am not going to write here, which I have not written here. Now the bandwidth, sir, bandwidth is nothing but how you can remember 1 upon tau, like this you can remember, and tau is L by R. So here this is nothing but R by L. Okay, this is R by L, bandwidth is R by L. And one more thing, so what is a mod Z at resonance? This is nothing but at omega 0, this is nothing but R. Okay, this basic thing you should remember. Okay, now come to the parallel RLC. Now come to the parallel RLC circuit. If I am going to draw the circuit, this is R, here this is L, and here this is C. So what I will consider here, I will consider current as a constant. So here current I am going to assume this is Im at angle 0 degree. This is nothing but I. Can I write? And here voltage is, this is plus minus V. So voltage is here, this is R, this is J omega L, and this is 1 upon J omega C. Clear? So here you can write this current is IR, here this current is IL, and here this current is IC. Okay, so again you can write here two equations, one impedance equation will be tougher, admittance equation and current equation. So here two equation you can write. Sir, current equation I is equal to, you can write IR, and you can write here this is minus of JIL, because inductor current is lagging, and here voltage angle you will assume that is a 0 degree. Here voltage angle you will assume that is 0 degree. Okay, so now minus JIL, and second can I write plus JIC? Can I write in this way? Yes. So we can write is nothing but IR minus of J. Can I write here IC minus of IL? Okay, so here imaginary part will be 0 at resonance. And second equation, Y you can write, this is 1 by R plus 1 upon J omega L, and this is plus J omega C. Can I write in this way? So now you can also write from here on Y 1 by R, this is plus J omega C minus 1 upon omega L. So here the thing is different, omega C minus 1 upon omega L, but remember this is not Z, this is Y. So at omega is equal to omega 0, you have two choices. Either you can 0 this part imaginary, so IC minus IL is equal to 0. So can I write IC is equal to IL? Can I write? So at resonance, this current and this current magnitude is same and direction will be opposite. Already we have studied in phasor. And from here what you can write? From here what you can write, at omega is equal to omega 0. So this I am going to remove. So now at omega is equal to omega 0, this value will be 0. So can I write omega 0 C minus 1 upon omega 0 L is equal to 0. This is first equation. So this is first equation at omega 0 L. Here this is omega 0 L minus 1 upon omega 0 C. But here omega 0 C minus 1 upon omega 0 L. If you will solve this, so what you will get? Omega 0 is equal to 1 upon root over LC. Same answer you are getting. So resonant frequency is same in series RLC and parallel RLC, and the answer is 1 upon root over LC. Now if this value is 0, so at resonance Y at omega 0 is nothing but 1 upon R. So sir, what will be the impedance at omega 0? So Z at omega 0 is equal to R. So again this answer will be same, impedance at omega 0. So here Z at omega 0 is equal to R. So at omega is equal to omega 0 means at resonance what will be the circuit impedance? Circuit impedance is nothing but R. Clear this point? Circuit impedance is nothing but R. Okay, now my question, if in parallel RLC circuit impedance is R, then what will be the Z? Z will be minimum or maximum? This is my question. Now if this is 0 at resonance, so Y you will get maximum or minimum? You can write what will be the mod of Y? So mod of y will be here root over 1 by r square plus, can I write here, root over 1 by r square plus, this is omega c minus 1 upon omega l whole square. Can I write omega c minus 1 upon omega l whole square. So at resonance, this value is 0. So you are getting y 1 upon r square. Now if this part will be increases, so y will be increases. So what I can write, at resonance this value is minimum. So at resonance here z is r and y is 1 by r, but y is a minimum value, so z is a maximum. So here this z is nothing but z max. This is the important point. So you remember at resonance in parallel RLC circuit, you will get maximum impedance, and if impedance is maximum, so current will be minimum. In this case, I minimum you will get. So two important thing you should remember. At resonance in series RLC circuit, current will be maximum, but in parallel RLC circuit current will be minimum. This is the important point. Current will be minimum. Clear this point? Current will be minimum. Okay, so this important thing you should remember. Okay, now come to the point. I hope this thing is clear to you now. So just I am going to remove this part. Okay, now I am going to remove this part. So if you will plot here admittance diagram, then what you will get? If you will plot here admittance diagram, remember admittance diagram. Okay, so if you will plot here mod of y, what you will get exactly? So mod of y same. So this mod of y you will get in this way. And this is omega 0, and here this is omega 0. So for greater than omega 0, what is circuit behavior? So for greater than omega 0, this is your mod of y. This is nothing but your root over, already you have written here 1 by r square plus omega c minus 1 upon omega l square. So here if I am going to draw, sir, what is omega c? So this is omega c, and sir this is 1 by omega l, just opposite from previous one. And in this point, this frequency is omega 0. So for greater than omega 0, this XL is more, sorry, this is 1 by, this is omega c. So omega c minus 1 upon omega l is positive value. This is a positive value. So omega c minus 1 upon omega l is positive value. So here I can write, sir, y is equal to 1 by r plus j. This is omega c minus 1 upon omega l. So if this is a positive value, so here omega c minus 1 upon omega l is positive here. So I can write here omega c minus 1 upon omega l is positive. And here I can write, sir, omega c minus 1 upon omega l is negative. Can I write? Yes, sir. So if this is a positive value, so angle of y is positive. So here angle of admittance is positive. So if angle of admittance is positive, so angle of impedance is negative. This is the important thing. So if angle of impedance is negative, circuit behavior is capacitive. So here you should remember, here circuit behavior is capacitive and here circuit behavior is inductive. So just opposite to series RLC circuit. Clear this point? So if I will write here omega h, L, so at omega h circuit behavior is capacitive, at omega L circuit behavior is inductive. Remember this thing. So for greater than omega 0, circuit behavior is capacitive. So power factor is here leading power factor, and here power factor is lagging power factor. You remember this thing. Okay, so you should remember this thing. Okay, and you remember this not as that, this is a y, so y is minimum here, this is the y minimum. So y minimum, what will be this value? Sir, this value will be 1 by r. Y minimum will be 1 by r. So z maximum will be r. Now I am going to plot here voltage. Okay, now I am going to plot here a voltage. So in series RLC and parallel RLC, just by difference you should remember. So resonant frequency is same. Okay, at resonance circuit impedance is same, Z is equal to R, here Z is equal to R. But the important thing is in series RLC that was Z minimum, here that was Z maximum. But value is same, Z is equal to R at resonance frequency. Clear this point? Now if I will plot here, this voltage. So what is the voltage here? What is the voltage? What is the voltage magnitude of V? What is the magnitude of V in the circuit? So V is equal to, you can write I by Z. Sorry, V is equal to, you can write mod of V, you can write mod of I into mod of Z. Can I write? And Z you can write 1 upon Y. So mod of I divide by mod of Y. Can I write? Because here Y you have calculated and mod of I is nothing but Im. So this is Im divided by root over 1 by R square plus this is omega C minus of 1 upon omega L whole square. Can I write? This is mod of V. So at omega is equal to omega 0, at omega is equal to omega 0, this value will be 0. So here this is nothing but Im upon root over 1 by R square, means Im into R. So what will be the this value? This value will be maximum. You will get this kind of plot. You will get this kind of plot, and at omega is equal to omega 0, what will be the voltage? What will be the voltage at omega is equal to omega 0? Sir, this voltage will be maximum. So this value is nothing but V max. And what will be the V max value? Im into R. This is nothing but Im into R. So can I write here, sir, what is a mod Z? This mod Z is nothing but R. Mod Z is nothing but R. But this is a minimum Z or maximum Z. This is maximum Z. So if impedance are maximum, then definitely voltage will be maximum. If you are considering current constant, and if impedance maximum I into Z, so definitely voltage will be maximum. So now in this point at omega is equal to omega 0, sorry, omega is equal to omega 8 and omega is equal to omega L. So here this voltage will be, here this voltage will be maximum by root 2. So here this voltage will be V maximum by root 2. It means in this position what will be the, sir, impedance? So impedance is going to be, voltage is going to be reduced. Remember, voltage is going to be reduced, then impedance will be more or impedance will be less. This is my question. So if voltage is going to be reduced, so V is equal to I into Z. V is equal to I into Z. So here if voltage is reducing, means Z is reducing. This is the important point. So here mod Z is nothing but R by root 2. This is the basic difference in series RLC and parallel RLC. So in parallel RLC, at omega H and omega L, what is a mod Z? Mod Z is R by root 2. But in series RLC, mod Z is root 2 times of R. Root 2 times of. This is the important thing. If here, sir, power is P, so here definitely power will be P by 2. This is half power bandwidth. And here power is P by 2. Here power is P by 2. Remember this thing. So here this is unity power factor. Unity power factor. Here power factor again 0.707. Here power factor 0.707. Here cos phi is 1. Here phi is 45 degree. And the circuit behavior is capacitive or inductive. So here circuit behavior is capacitive. Here circuit behavior is inductive. So power factor will be for capacitive leading, for inductive lagging. You remember this thing. Clear this point? Clear this point? You have to remember this thing. Now I am going to remove this part. Now I am going to remove this part. Okay, so this basic you should know. This diagram is very, very important. This diagram is very, very important. Many things I have written here. Circuit behavior, power factor, what is angle? Here angle you can write phi is 45 degree. Here phi is 0. Here phi is 45 degree. Okay, so now which phi you are asking? Phi Z, or you are asking angle between voltage and current, or you are asking impedance angle. Okay, so but that is 45 degree, and you know the circuit behavior is capacitive. So here impedance angle will be negative. Here impedance angle will be positive. So can I write, sir, here phi Z will be negative, and here impedance angle phi Z will be positive. Phi Z will be positive. Many things you can write in this graph. Okay, but at least some value you should remember, so that direct you can predict the answer. So that you can predict the answer. So just confirm me. Now everything is clear. Now here everything is clear or not? So now here the important thing, I am writing here the same equation. So here what you have to remember, sir, first equation, here you don't write omega L minus 1 upon omega C. For parallel RLC, you remember omega C minus 1 upon omega L. So first equation, if this is resonant frequency. So in resonant frequency, this value is 0. Clear this point? Now, sir, if this is omega H C minus 1 upon omega H, this is L is equal to, now sir, this is omega LC, this is lower cutoff C, here this is minus 1 upon, sir, omega L into L. Okay, so in this case, here this was R, but here this will be 1 by R. So here this will be 1 by R, because you have found it out this from admittance function. So one you should remember, sir, this will be 1 by R, which will be plus 1 by R, which will be minus 1 by R. Here this value is nothing but, this is, sir, omega L minus 1 upon omega C, and this value is nothing but omega L minus 1 upon omega C. This omega is omega H, this is omega, this is omega L, this is omega L. And here this omega C minus 1 upon omega L is equal to 1 by R. So now, sir, for this difference, this will be plus 1 by R or minus 1 by R. For this is plus 1 by R or minus 1 by R. So how you can find out? You know very well, sir, what is Y? Y is nothing but 1 by R plus J. This is omega C minus of 1 upon omega L. Okay. Now, if this difference is 0, if this difference is positive, for example, positive. So if omega C minus 1 upon omega L, if this difference is positive, suppose for example, if this difference is positive, so when you are getting positive, if this difference is positive, so if this is positive, in this case, angle of Y is positive. So if angle of Y is positive, means angle of Z is negative. So if angle of Z is negative, it means circuit behavior is capacitive. So for capacitive behavior, omega C minus 1 upon omega L should be positive. And where you are getting capacitive behavior? At omega H. It means for omega H, this is a positive. So for omega H, this is positive. For omega L, this is negative. In both the case. So here for omega H, this is positive. Omega L, this is negative. Here you remember, here omega L minus 1 upon omega C, or you can write XL minus. Here you can also remember like this. This is XL minus 1 upon XC. But here this is nothing but XC, 1 upon XC minus 1 upon XL. Like this you can also remember. Okay, and here this value is equal to 1 by R. Okay, I hope this thing is clear to you. Now, sir, what will be the bandwidth? And here again, if you will calculate, omega 0 is here. What is omega 0? Sir, first answer, omega 0 is 1 upon root over LC. Okay, what will be, sir, omega H? And what will be, sir, omega L? So already I have tell you same formula, but here bandwidth is different. So here omega H, what you will write? In previous case we have written bandwidth by 2, and bandwidth R by L, means R by 2L. So here same formula you can write, sir, this is bandwidth by 2, here this is bandwidth by 2, this is plus, this is minus, here this is plus, root over, we can write here root over bandwidth by 2 whole square plus omega 0 whole square, and here again root over bandwidth by 2 whole square plus omega 0 whole square. Same formula for series RLC and parallel RLC for omega H and omega L, but the difference is, sir, what is the bandwidth in parallel RLC? Sir, what is the bandwidth in parallel RLC? Anybody can tell me if you remember. What is the bandwidth in parallel RLC? What is the bandwidth in parallel RLC? Series RLC, that is R by L. What is the bandwidth here? So remember, bandwidth of parallel RLC, so bandwidth of parallel RLC, I can write here P is equal to omega H minus omega L, and this value is nothing but R into C. You should also remember like 1 upon tau. here bandwidth is a 1 by RC, that is 1 by tau. So this is 1 by RC, 1 by RC. So now you can put the value here. So this value is bandwidth by 2, so 1 upon this is 2 RC, and this is plus root over this is again 1 upon 2 RC whole square plus 1 upon root over LC whole square. You can write in this way. Similarly, what is omega L? Minus 1 upon 2 RC, and this is plus root over 1 upon 2 RC whole square plus 1 upon root over LC whole square. So my recommendation, don't remember this formula, you remember this and remember the bandwidth. So bandwidth for series RLC is R by L. Bandwidth for series RLC R by L. Clear? Omega 0 for series RLC 1 upon root over LC. And mod of Z, and this is a minimum or maximum, this is a minimum at resonance, and this is nothing but R. This is nothing but R. So this thing you should remember for series RLC. Now come for the parallel RLC. So now here omega H minus omega L, if you will subtract this plus this, so you will get 1 by RC. You will get 1 by RC. So I hope now you can remember this. Now again I am going to write the table for parallel RLC circuit. Okay. Now I am going to write this table for parallel RLC circuit. One thing again remember, don't write omega H, omega 0 plus bandwidth by 2. No, don't use this formula to calculate omega H and omega L. Don't use this formula. Always you have to use this formula. You have to use this formula. If you know the bandwidth and if you know the omega 0, so you have to use this formula to calculate omega H and omega L. Clear this point? Clear this point? Okay. Now clear this point. So just I am going to remove this, and same table I am going to draw for parallel RLC circuit. Same table I am going to write for parallel RLC circuit. Okay, so for parallel RLC circuit, some important thing you should remember. Okay, now I am going to write for this is for series RLC. Now for parallel RLC. So for parallel RLC, same thing we have to write. Same thing we have to write. So for parallel RLC, at omega is equal to omega 0, at omega is equal to omega H, and at omega is equal to omega L. So at omega is equal to omega 0. Now this value you have to write here. Sir, this is omega C minus 1 upon omega. You have to write in this way, and this is nothing but 1 upon XC minus 1 upon XL. Clear this point? And this is at omega is equal to omega 0. This is omega. Okay, can you write in this way? Yes, sir. Okay, so what will be this value? So at omega is equal to omega 0, this difference is 0. At omega is equal to omega H, this difference is plus 1 by R, and this difference is minus 1 by R. Okay, this value is nothing but omega 0 C minus 1 upon omega 0 L. This value is nothing but this is omega C minus 1 upon omega L. You can do here H and H, and here this is omega C minus 1 upon omega L, and you can write here L and L. Clear this point? Now here we have calculated Z. Here I am going to write mod of Y. So mod of Y is nothing but root over 1 by R square plus this is omega C minus 1 upon omega L whole square. Can you write? So what will be here mod of Y? So here mod of Y is nothing but 1 by R. Here mod of Y. So if here mod of Y is 1 by R, so mod of Z is nothing but R. This is the important point. And this is minimum or maximum. So this is nothing but maximum. This is maximum. If you remember this maximum, so what will be here mod of Z? So here, sir, mod of Z will be, if this is maximum, so definitely this will be less. So this will be R by root 2. So if mod of Z is R by root 2, so mod of Y will be root 2, mod of Y will be root 2 divided by R. Root 2 divided by R. Can I write? So here mod of Y will be root 2 divided by R. But here mod of Z is R by root 2. R by root 2. This is the important point. This is the important point. Then sir, what will be the angle? Here mod of Z. So here mod of Z and angle of Z and angle of Y. Angle of Z and angle of Y. So what will be the angle of Z here? So here angle of Y is, what is angle of Y? So angle of Y is here first case 0 degree. So here angle of Y is 0 degree. So angle of Y is 0 degree. So angle of Z, I can write phi. Okay. Angle of y is 0 degree, so angle of z is also 0 degree. Yes sir. Now in this case, what is angle of y? 45 degree, but this is plus or minus, this is the important thing. So you know very well, at omega is equal to omega h, circuit behavior is capacitive. Circuit behavior is capacitive. For capacitive behavior, impedance angle is negative, then admittance angle is positive. So this is positive. So what is angle of z? Angle of z is minus 45 degree. Can I write minus 45 degree? And here angle of y is minus 45 degree. So angle of z is plus 45 degree. You can write in this way. So now come to the point power factor. So what is the power factor? So here this is the unity power factor. Unity power factor means cos phi is equal to 1. Now in this case, what is the power factor? So cos phi is equal to 0.707. And here again cos phi is equal to 0.707. Power factor is 0.707. Here circuit behavior is capacitive. So this is leading power factor. Circuit behavior is capacitive. Here this is a lagging power factor and circuit behavior is inductive. Can I write? Yes. Now what will be the sir here? Mod of voltage. What will be the voltage? Voltage I can write mod of I into mod of Z, and mod of I is nothing but Im. I can write Im into Z. Can I write? Or you can write Im by Y. But generally I prefer impedance. So always admittance I have to write in terms of impedance. So what will be the here mod of V? Voltage. What will the voltage you are getting? Voltage you can write, this is nothing but Im. And what is the Z? Z is nothing but R. So you can write Im into R. Now here what is the magnitude of voltage? This is again Im, and here Z is R by root 2. So Im into R by root 2. So voltage will be reduced. And again here mod of V is nothing but Im into R by root 2. You can also write this is nothing but V max by root 2. And you can also write this is nothing but V max by root 2. And this value is nothing but V max. V max. Clear this thing? And this is nothing but Z max. Here this is nothing but this is Z minimum. This is Z minimum. Okay. Now next important thing, sir, what is a omega 0 for parallel RLC circuit? Omega 0 is nothing but 1 upon root over LC. Now sir, what is a impedance? Already impedance at resonance is R, but that is a minimum or maximum? That is a maximum. Now the next point is, sir, what is the bandwidth? The bandwidth is here 1 by RC. 1 by RC. This is the important point. Now sir, Z minimum, here this is Z maximum. So at resonance you are getting Z max, and Z max is nothing but R. Z max is nothing but R. Only this thing you should remember. Only this thing you should remember, and all the class should be remembered to you. So in GATE exam, need not to remember all the things. If you have studied once, definitely you can handle the question. Okay, just you have to recall this thing. Just you have to recall this thing. Just you have to recall this thing. Okay, just you have to recall this thing. Okay, just you have to recall this thing. Clear this point? This is very, very important for this one, for series RLC at resonance or series RLC circuit. Okay, and this is for parallel RLC circuit. Okay, so if you want, everyone note down. Sir, what is your doubt? Akhil gets, sir, for maximum MVTT, always RL must be equal to RTH. Huh? For maximum power transfer theorem, always, but if circuit load is resistive and source is resistive, then RL should be is equal to RTH. And if load is variable, okay, if load is variable and if source is resistive and if load is resistive, then load RL is equal to RTH. But the important point is if RL is variable, Clear this point? Okay, so everyone just confirm me. And if anybody have any doubt, just ask me. If anybody have any doubt here, then ask me. Okay, now I will discuss quality factor, and then we will start to solve many number of problems from here. Okay, so can we take one break? And after break we will continue. Okay, Mr. Sahil Soni sir, GATE Academy Plus network continue? Yeah, we will try to continue. Okay, but already I am taking mostly classes for gate, but I will try to complete that part. Okay. Okay, so you can also attend your classes in Gate Academy here global, but here the classes is conducting in English. Okay, but here you can attend the classes. I will try to finish my classes in a plus also. Okay. So I hope this thing is clear to all of you. Okay, so now can we take one break, and after break we will continue. Okay, so at least this thing should be fixed in your mind. Only this thing you should remember. And here the most important point is this part, and this part also, okay, and I hope remaining thing is definitely remembered to you. Okay, so if you are comfortable in this, so definitely you will get marks in gate exam. Okay, so right now our time is 6:42. 6:42. Okay, so after 30 minutes. Okay, so 7:10, at 7:10 we will meet again. Okay, so at 7:10 we will meet again. Okay, then after 7:10 till 8:30 or till 9 we will complete the resonance part, and after resonance part we will take a dinner break, and then after dinner we will finish complex power. So today we will finish the network. Okay, so today we will finish the network. Clear? So we will meet after approximate 25 minutes. Okay, so 30 minutes. Okay, so at 7:15 we will meet. So we will meet at 7:15. Okay, so we will meet at 7:15. If anybody have any doubt, you can post. If anybody have any doubt, you can post. Okay, welcome back. Good evening, everyone. Just confirm me, audio and video, everything is perfect. And I hope this thing is clear to all of you. Okay, now. So, once just confirm me, audio is clear or not. Okay, so right now we have studied each and everything about a series RLC circuit at resonance. Okay, and parallel RLC circuit at a resonance. Okay, now. Now the important thing here, what is a quality factor? So now I am going to discuss quality factor, and after quality factor we will discuss so many number of problem from the resonance. Okay, so now I am going to start quality factor. Now I am going to start quality factor. Okay, for series resonance and for parallel resonance. Okay, so for series resonance and for parallel resonance, what is a quality factor? Okay, so quality factor formula, here I am not going with a derivation, directly formula I am going to tell you. Okay, and how you can remember. Okay, my recommendation for series RLC circuit, generally you can go with voltage, and for parallel RLC circuit, generally you can go with current. Then most of the thing will be remembered to you. Okay, for series RLC circuit, you can go with voltage. For parallel RLC circuit, you can go with current. Okay, so now, sir, what is a quality factor? 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 And this is represented by Q. This is represented by Q. We can say this is a one kind of amplification factor. If you want, you can also say, sir, this is amplification factor. Amplification factor. Amplification factor. Now you will say, sir, how we can say this is amplification factor? Yes, we can say. We can say this is amplification factor. How we can say? Sir, for series RLC circuit, and if you will operate this circuit at resonance, so this is R, this is L, and this is C. Okay, here this impedance I can write XL, and here impedance I can write XC. So what can be happened here? Here I can write VR. At resonance, this VR is equal to V. Okay, here this voltage is VL, and here this voltage is VC. Here this voltage is VC. So what is exactly going to be happen in series RLC circuit? Voltage across inductor and voltage across capacitor can be more than supply voltage. If supply voltage is V here, then at resonance voltage across resistor will be V, but voltage across inductor VL will be Q times of V. This is magnitude I am talking here, magnitude, and voltage across capacitor can be Q times of V, and Q can be much greater than 1. So if this voltage is, for example, 10 volt, this voltage can be 100 volt. This voltage can be 100 volt. This can be possible. So in series RLC circuit, voltage amplification or voltage magnification can be possible because of this quality factor. We can say this is amplification factor, or you can also say quality factor. Okay, amplification factor is the name just I have mentioned here, but everywhere we use quality factor. Okay, so this thing you should remember. So series RLC is called series RLC circuit. Can I say this is voltage magnification or amplification? So this is one kind of voltage amplifier. This is a one kind of voltage amplifier circuit, and somebody will call voltage amplification circuit. Voltage amplification circuit. Okay, now if I will come with a parallel RLC circuit, in parallel RLC circuit, this is R, this is L, and this is C. Okay, this is R, L, and C. Now you can write here current is IR, here current is IL, and here current is IC. And suppose if this circuit total current is I, and here total voltage is V. Okay, total voltage is V. So what I can write, sir, this IR at omega is equal to omega 0 at resonance, this IR is equal to I. Sir, this IL will be Q times of I, and this IC will be Q times of I. So here this current can be Q times, if this I is suppose 10 ampere, so this can be 100 ampere, this can be 100 ampere. So here what can I say, IL will or IC will be greater than I. Supply current is 10 ampere, but sir, here current can be more than this. Yes, this can be possible. because of this quality factor. So this quality is nothing but amplification factor. So here parallel RLC circuit, okay, we can say this is voltage amplification. Here I can say this is a current amplification circuit. This is a current amplifier. Can I say current amplifier circuit? You can write like this. Okay, now what is a definition of quality factor? So quality factor for inductor, and this is nothing but 2 pi. Okay, so what is the formula for quality factor for inductor? So 2 pi into energy stored by inductor. So this is nothing but energy is stored by inductor, divide by energy absorbed or energy dissipated by resistor, energy dissipated by resistor. Now resistor for how much time? Energy will be stored for very small time. Suppose if you have water tank of 100-liter capacity, and if 100-liter water you can fill, then the stored value will be 100 liter, but resistor will be always dissipate. So this is energy dissipated by resistor in one cycle, in a one time period. Okay, this is a formula for quality factor. Similarly, for quality factor, if you are calculating for capacitor, so this is 2 pi into only here, this is energy stored by capacitor divided by energy dissipated by resistor, okay, in one time period, T. Same formula, one you can find out from inductor, and one you can also find out from capacitor. And this formula is for series RLC and for parallel RLC. Both quality factor is different. So for series RLC, first I am writing for series RLC. For series RLC circuit, okay, now I am not going with derivation, directly value, everybody remember, just I am going to write, sir, quality factor for series RLC. So just I am writing quality factor for S. S means series RLC circuit. So what is the quality factor of series RLC circuit and how you can remember? So in series RLC circuit, here you can write in series RLC circuit, I can write, sir, here voltage across inductor is VL, and here this is VR. So we can write here, sir, VL voltage across inductor divide by voltage across resistor. This is direct how you can remember. Voltage across inductor divide by voltage across resistor, like this you can remember. So now voltage across inductor is nothing but I can write current is same, so same current will flow, and now here same current will flow. So can I write I into what is this impedance XL? This is amplitude. So can I write I into XL, and here can I write I into R? So here I and I will be cancel out. This is XL by R. And XL what we can write? So quality factor for series RLC, XL I can write omega L by R, and this here to calculate at resonance. This is important thing. So this is omega 0 L by R. And omega 0 what I can write? Sir, 1 upon root over LC into L by R. Then what you can write? 1 upon R root over L by C. So what you can write here? Sir, 1 upon R root over L by C. This is a quality factor for series RLC circuit. So remember, quality factor for series RLC circuit is nothing but either you can remember XL by R, or you can remember omega 0 L by R, or you can remember voltage across inductor divided by voltage across resistor, or you can remember 1 by R root over L by C. So if I will ask you, quality factor depends on RLC. So remember, quality factor of series RLC circuit is a function of R, L and C. Quality factor of series RLC circuit is a function of RLC. This formula you remember. Okay, there are so many ways to remember this formula. Okay, so just I am removing this part. Okay, so there are so many ways to remember this formula. Okay, from this you can also calculate, but it will take time. So I am not going with the derivation here. Okay, because this is a revision class. So just I hope everybody remember this is very basic formula. This is a very basic formula. Sir, is this last session of network? Yeah, this is last session. Only two topic is remaining. Resonance we are conducting, and then complex power. Then complex power. Okay, now, sir, can we find out second formula? Can I write QS is nothing but, sir, can I write VC by VR? Can I write VC by VR? Can you write? This is my question. So you can see here, sir, VC is nothing but mod of I into XC divided by mod of I into, and this is nothing but R. You can also write VR is nothing but V. You can also write this is V. Okay, now here I and I will be cancelled out. So XC by R. So this is nothing but XC by R, and XC is nothing but, what is XC? 1 upon omega 0 RC. So somebody student this formula omega 0 L by R, and some student remember 1 upon omega 0 RC. Both will be same because voltage across capacitor and voltage across inductor is same at resonance. So at resonance for series RLC circuit, magnitude of VL is equal to magnitude of VC. We know this thing. So just remember, with respect to resistor voltage, how much voltage is you are getting across inductor or capacitor. Any one formula you can use, either VL by VR or VC by VR. Here you can, if write omega 0 1 upon root over LC. So here root over LC divided by RC. If you will solve this, so quality factor for series RLC circuit 1 by R. Here you will get root over L by root over C. Root over L by, this is L by root over C. Same formula you are getting. So now I am going to write the final formula for series RLC circuit. Remember, so quality factor for series RLC circuit, one important point, always you are calculating this formula at resonance. At resonance only quality factor is defined. Quality factor is defined at a resonance. So quality factor for series RLC circuit, how you can remember? First, sir, VL by VR. You remember this is magnitude. Sir, second we can also write VC by VR. Yes, you can also write, from here you will get omega 0 L by R. Yes, from here you will get 1 upon omega 0 RC. And this is nothing but 1 by R root over L by C. You will get 1 by R root over C. So this formula you can remember. This formula you can remember. And one last, quality factor is a function of R, L and C. Quality factor is a function of R, L and C. Quality factor is a function of R, L and C. Now if I will ask you one more formula, L by R, already you have calculated, sir, L by R. R by L is the bandwidth. So what is a bandwidth of series RLC circuit? Bandwidth of series RLC circuit is R by L. So this R by L, can I write bandwidth? So quality factor for series RLC circuit is nothing but omega 0 by bandwidth. And sometime student will remember this is bandwidth of series. If this is series, this is series. Omega 0 is same for series RLC. So bandwidth, can I write omega 0 by Q? Bandwidth is nothing but omega 0 by Q. Okay. So quality factor you can also remember omega 0, resonant frequency divided by bandwidth. This formula will be same. This formula will be same for series and parallel. That's why this S can be removed. So first we will study parallel RLC, then we will discuss this. So I hope this all the formula for series RLC quality factor should be clear to you. Now I am going with parallel RLC circuit. Clear this thing? So definitely something new, definitely you are going to learn here. Okay. Generally student remember omega 0 L by R. If you will remember this formula, so never you will get wrong. Never you will get wrong. Okay, never you will get wrong. Okay, so meaning should be very much clear. What is a quality factor? Okay, so with respect to resistor, how much extra voltage you are getting across the capacitor or inductor, because this is voltage amplification circuit. Now for parallel RLC circuit, parallel RLC circuit. So direct formula can I write what is a quality factor for parallel RLC circuit? You can write QP. What will be the formula? Here this is a current amplification circuit. So can I write current across inductor magnitude of IL divided by magnitude of IR, or I can write magnitude of IC divided by magnitude of IR. Can I write? Yes sir, we can write. Okay, then what will be this value? What will be the I? I is nothing but V by Z. So if you will solve from here, so current across inductor is nothing but voltage. Voltage is same, so magnitude of voltage divided by voltage across inductor, sorry, impedance across inductor is XL. Can I write? And here this current across resistor is nothing but V by R. Can I write? I is nothing but V by R. So here you will get V and V will be cancelled out. R by XL, and R by XL is nothing but R by omega 0 L. R by omega 0 L, and R by L is nothing but bandwidth. So bandwidth by omega 0. You can write bandwidth by omega 0. So quality factor of P is here. Okay, I will discuss this thing. Okay, now so this is R by omega 0 L. Now from here what you will get? IC is nothing but magnitude of V divided by this is XC, and this is magnitude of V divided by R. V and V will be cancelled out. V and V will be cancelled out. From here what you will get? This is magnitude of V by R. So this and this will be cancelled out. You will get R by from here you will get R by XC, and XC will be nothing but 1 upon omega 0 C. So you will get R omega 0 C. So same here you can also write omega 0 RC. Okay, so can I complete this? So this value here omega 0 L by R, just opposite of this. So this is R by omega 0 L, R by omega 0 L, and here you will get here omega 0 L by R, here R by omega 0 L, 1 upon omega 0 RC, here omega 0 RC. And now if you will solve this, so omega 0 is nothing but 1 upon root over LC into RC. So from here R root over C by L. Can you write? And from here you can also write omega 0 1 upon root over LC into R by L. If you will solve this, so this is nothing but R root over C by L. So from both you will get same answer. This is R root over C by L. Okay, this thing you should remember. So again can I write here, what is the quality factor of a parallel RLC circuit? Is a again function of RLC. Can I write? And now the important thing is here, quality factor of series RLC circuit is 1 upon quality factor of parallel RLC circuit. This is important formula. Quality factor of series RLC circuit is the quality factor of parallel RLC circuit. Quality factor of series RLC circuit is equal to quality factor of 1 upon quality factor of parallel RLC circuit. You remember this thing. So if you remember this formula, directly you can write quality factor of series RLC is nothing but 1 upon quality factor of parallel RLC circuit. Now if you can see, sir, what is the bandwidth? 1 upon RC is the bandwidth. So this is, can I write what is quality factor? So from here what can I write? This is quality factor of parallel. This is parallel RLC circuit. So we will use here bandwidth of parallel RLC circuit. So sir, can I write 1 upon RC is bandwidth of parallel RLC circuit? So quality of factor of parallel RLC circuit is nothing but omega 0 by bandwidth of parallel RLC circuit. So this formula is same. So everywhere you can use quality factor is nothing but omega 0 by bandwidth. Okay, this is standard formula, or you can also use bandwidth is nothing but omega 0 by Q. So from here you can say quality factor is inversely proportional to bandwidth. So if bandwidth is more, quality factor is less. If quality factor is less, bandwidth is more. But one important thing, if you are using this formula for series RLC circuit, so don't use sir bandwidth formula for parallel RLC and quality factor for series RLC. Okay, this is the important thing. This bandwidth for parallel, then this is for parallel. If this is for series, this will be for series. You cannot use sir here. Here you cannot write sir R by L is the bandwidth. R by L is the bandwidth of series RLC circuit, not parallel RLC circuit. Clear this point? So you don't use for parallel RLC circuit. Bandwidth formula is R by L. So this thing you should remember. This formula you should remember. Quality factor of series RLC circuit is inversely proportional to or 1 upon quality factor of parallel RLC circuit, and this quality factor is nothing but omega 0 by bandwidth. This formula you should remember. I hope this thing is clear to all of you. Okay, and what is your directive proportionality constant? That is omega 0. So if you will remove this, so this will be omega. Clear this point? So this is a quality factor. 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 Okay, this is a quality factor. Now never you will forget the formula of quality factor. Okay, now come to the point. Now come to the point. Now come to the point. Okay, now. So now I hope I have dealt all the theory part from the resonance. And now one more last point. Sometime this quality factor will be relate with control system. Will be relate with control system. So here this is RLC circuit. So definitely you will get second order system. So just I am going to write here. Just I am going to write here general equation or characteristic equation of a second order circuit. So if I am considering series RLC circuit, so you will get here one equation in terms of s square plus 2 zeta omega ns plus omega n square is equal to 0. This is a characteristic equation, and for series RLC circuit you will get this kind of equation. You will get this kind of equation. You will get this kind of equation. Okay, this is standard equation. In control system you study, but for series RLC circuit, if I will find out Z, so what is the Z for series RLC circuit? Can I write R plus SL plus 1 upon SC? Can I write? And if you will solve this, so what you will get? Z is nothing but here, this is RCS plus S square LC plus 1 divide by SC. Can I write? Now from here, you can also write this S square plus if you will divide by LC, so you will get divide by LC, so R by L into S, so S square plus R by L into S plus 1 upon LC, sorry, plus 1 upon LC. You will get this equation, plus 1 upon LC, divide by you can write anything. So this is my characteristic equation. This is equal to 0. So for series RLC circuit, if possible, you can also remember this characteristic equation. If you forgot, just find out the Z or Y anything. Just find out Z or Y anything. You will get this kind of equation. You will get S square plus R by L S plus 1 upon LC. So you can compare this S square plus R by L S plus 1 upon LC should be is equal to 0. So if you will compare with this equation, S square plus 2 zeta omega n S plus omega n square is equal to 0. So one thing you can see, omega n is nothing but, in control system you will say this is natural frequency, and here we will say resonant frequency. Both are same, and this value is nothing but 1 upon root over LC. Can I write? Yes, 1 upon root over LC. This is S square. So from here 2 zeta omega n is equal to R by L. Can I write? Now what is omega n? 1 upon root over LC. So this is 2 zeta 1 upon root over LC is equal to R by L. Can you write? Yes. And you can also say, sir, this value is nothing but here R by L is nothing but bandwidth of series RLC, and you are targeting here series RLC. Yes, sir. So this is for series. Can I say this is zeta for series? This is zeta for series. So from here you can write, sir, from here I can write 2 zeta for series is equal to bandwidth by this omega n. You can also write omega 0, and omega 0 by bandwidth. Omega 0 by bandwidth is nothing but quality factor. So from here can I write this is nothing but 1 upon quality factor for series RLC. So next formula you remember, quality factor for series RLC is nothing but 1 upon 2 zeta for series RLC. And what is zeta? Zeta is a damping ratio. Zeta is a damping ratio. This is a damping ratio. This is damping ratio. Sometime directly by quality factor, you can say the behavior of circuit. You know very well, when zeta is equal to less than 1, when zeta is equal to 1, when zeta is greater than 1, when zeta is 0. So you should know when the circuit function is critical damp, undamp, underdamp, and overdamp. Okay, so in control system generally you study, but if you can relate that control system with this second order circuit, so at least you should remember one relation with quality factor and zeta. Clear this thing? So quality factor is nothing but 1 upon 2 zeta and 2 zeta s, and quality factor you know very well for series RLC circuit. This is nothing but 1 by R root over L by C. Clear? 1 by R root over L by C, and quality factor you can also remember this is nothing but omega 0 by bandwidth, and this quality factor you can also write this is nothing but omega 0 by bandwidth of series RLC circuit, and series RLC circuit bandwidth is L by R. This value is nothing but L by R. So this only this thing you remember, quality factor of series RLC circuit is 1 upon 2 zeta of series RLC. Clear this thing? Now if we will solve this for parallel RLC circuit, we will calculate y, we will calculate here y, and again you will get same kind of expression. So directly I am going to write for quality factor of parallel, again you will get 2 zeta of parallel RLC. So same answer you are getting. So directly you can write what is your relation between quality factor and zeta. Q is equal to 1 upon 2 zeta, or zeta is equal to 1 upon 2 q. You remember this formula, you remember this formula. Okay, so only this much theory should be remembered to you for resonance. I hope clear this point. So now I am moving towards some question from this topic. Okay, so now yeah, one more important thing I want to discuss here, last important point. Clear this point? Now last important point. So now if you have studied quality factor, then at resonance, sir, what will be the voltage of series for series RLC? What is the voltage across a resistor, inductor and capacitor? So just you should remember, for series RLC, okay, at resonance, at omega is equal to omega 0. Okay, so voltage across resistor, sorry, complete voltage I am going to write. Voltage across resistor is nothing but voltage, supply voltage, and supply voltage, suppose if I am going to assume V is equal to Vm at angle 0 degree, anything we can assume. Okay, so this is equal to supply voltage. Now sir, what is voltage across inductor? So this is Q times of V. And sir, what is voltage across capacitor? Sir, this is Q times of V. But sir, what is a direction? What is a direction? So in series RLC, suppose I am going to assume current flowing across VR, VL and VC, same current. And suppose if you are going to take reference current as a reference, suppose here if I am going to plot this is V and this is current at resonance at omega is equal to omega 0. So at omega 0, total circuit voltage and total circuit current will be in same phase. Yes. VR will be same phase. Yes. Then sir, what will be VL, and what will be this VR value is equal to V. You know very well. Now sir, what will be the inductor voltage? Inductor is lagging, so inductor voltage will be here. This is VL. Now sir, what is the value of VL? Q times of V. And sir, what is the VC? VC will be Q times of V. Q times of V. Remember this thing. So what you can write, sir, VL is nothing but Q times of V, and V angle is 0. Then here this is a 90 degree. So can I write this is JQV and this is minus JQV. And you can also write this is Q. This is V at angle 90 degree. And this is nothing but QV at angle minus 90 degree. So this thing you should remember. What is the voltage across resistor at resonance? What is a voltage across inductor, and what is a voltage across capacitor for series RLC circuit? Just Q times of total voltage. Supply voltage is V, then Q times of this, Q times of this. Then direction, what will be the direction? So this will be 90 degree, this will be 90 degree, which will be positive, which will be negative. So voltage across inductor is leading with respect to current, so this will be plus 90 degree, and voltage across capacitor is lagging, so you can write this is minus 90 degree. So this formula you should remember. Similarly for parallel RLC circuit. Okay, similarly for parallel RLC circuit, similarly for parallel here for parallel RLC circuit. So for parallel RLC circuit means at omega is equal to omega 0. Again I can write here current will be divided. So just I am going to assume here, suppose current is nothing but I am at angle 0 degree. Now so what will be here? Current across resistor is I, current across inductor is Q times of I, current across capacitor is q times of I. Okay, then what will be the direction? So just I can write, sir, this is current and again this is voltage. So what will be IR? This is IR and IR value will be I. Sir, what will be the IC? Always capacitor is leading. So here this is current is IC and here this current is IL. And IC is nothing but q times of I, and IL, this is IC, this is IL, is nothing but q times of I. So this is minus 90 degree, this is plus 90 degree. So here QC is nothing but a Z times of QI. This is minus JQI. You can write this is QI at angle minus 90 degree, and I can write this is nothing but Q times of I at angle plus 90 degree. So these two things directly you should remember with direction in terms of polar form and in terms of rectangular form. Okay, so this formula is remember only. This is the last formula for resonance. Okay, so in resonance you have to relate each and every formula. You have to relate each and every formula. Okay, now I am going to take some question. Now I am going to take some problem from here. Now I am going to take some problem from here. Okay, so one very basic problem first I am going to take so that you will get comfortable. Okay, now a series RLC circuit. So here first problem, here given is a series RLC circuit, 1R, 1L and 1C. Okay, series RLC circuit is given and here R is 10 ohm, this is 10 ohm. Here mod of XL is given, that is 20 ohm, and mod of XC 20 ohm, both are same. So this is 20 ohm and here this is mod of XC 20 ohm, this is 20 ohm, so this is 20, this is 20. So directly you can say XL is equal to XC, means circuit is in resonance. So in GATE exam, when you will get a supply is AC, when you will get supply is AC and circuit is RLC, so either examiner will be interested in to calculate steady state response or examiner will interested in resonance. So 90+% times examiner will give you question from resonance. So how you can say the circuit is in resonance? First you can check XL is equal to XC, then you can check voltage across inductor and voltage across capacitor, magnitude is same or different. Okay, so more than 90% chances circuit will operate in resonance. Okay, now here supply voltage is 200 volt RMS. So here this is 200 volt and this is RMS. So here this supply VRMS is given, supply voltage is RMS, this is 200, this is 200 volt. Okay, so what you can assume, the voltage angle is 0. Then they are asking voltage across capacitor. So voltage across capacitor in RMS. So one thing you should remember, if this is given in RMS, all the answer you will get in RMS. So what will be the voltage across capacitor? So first you can see, sir, circuit is in resonance or not? Yes, sir. So here XL is equal to XC and this is for series RLC. So circuit is in resonance. Circuit is in resonance. And if circuit is in resonance, then what will be the voltage across capacitor? Is equal to voltage across inductor. Both magnitude is same. And this is nothing but Q times of V. And this is nothing but Q times of V. Okay, so what is Q? This is for series RLC circuit. You can write Q of series RLC circuit into V. So what is Q of series RLC circuit? Here there are R is given. So directly I can write this QS is nothing but omega 0 L by R, or you can say XL by R. And remember, this is magnitude. All this is magnitude. So magnitude of XL by R, so 20 by 10. So QS you are getting 20 by 10 is equal to 2. So what will be the answer? This 2 into this V is nothing but 200 and this is RMS. So 400, this is volt and this is RMS value. This is RMS value. So if I will ask you, what is the direction of this? So can you write? Yes, we can write. You can assume this angle. If not given, you can assume this as a reference. This is 0 degree. You can write voltage. So if I want to write, sir, VL. So VL is a QS into V and VC is equal to, sir, QS into V. But what is VL? So voltage across inductor, this is Z times of, this is minus Z times of. So if you want to write with direction, so this is this is Z 400 and this is minus Z 400. In another way, you can also write, sir, this is 400 at angle 90 degree. This is a 400 at angle minus 90 degree. Remember, all the values are RMS here. All the values are RMS here. So examiner can ask you anything. Examiner can ask you anything. Okay. So easily you can find out. Easily you can find out here. First, quality factor. You can also use formula 1 upon omega 0 RC. You can also use. Okay, 1 upon omega 0 RC means XC. You can also write this formula. You can also write this XL by R. In another way, XC by R, because at resonance XL and XC is the same. XL and XC is the same. Clear? This is very basic. So here all the questions you will get formula based. Okay, now the second question. Now the next question. Now the next question. Okay, if anybody have any doubt, ask me. Okay, if anybody have any doubt, just ask me. Just ask me. Okay, can we take second question? Okay, now the second question. This is very, one circuit is given, note down, but this is not a standard. So I hope now any standard circuit, series RLC and parallel RLC you can handle, because you know each and every formula. Okay, now I am going to take one question that is not a standard series or parallel RLC. So here one inductor is given here, then one capacitor and one resistor, here one capacitor and here one resistor are connected like this. Okay, this is the previous year gate problem, and value is given. This is 1 farad, this is 1 ohm, and this is 0.1 Henry. This is 0.1 Henry. This is neither series RLC nor parallel RLC. And now resonant frequency you have to find out. Sir, what is here? This is AC supply you have provided. So this omega 0. So omega 0 is equal to question mark. So already I have tell you. Okay, already I have tell you at resonance. At resonance, if suppose for example, this total circuit voltage you are assuming V, and if total circuit current you are assuming I, and this total circuit impedance you are assuming Z, and this total circuit admittance you are assuming Y. So you have four choices. Either imaginary part of total circuit voltage you have to equate with 0, imaginary part of total circuit current you have to equate with 0, imaginary part of Z you have to equate with 0, and imaginary part of Y you have to equate with 0. But generally you have to use this, because here sometime what is imaginary part of voltage is 0, it means you are assuming voltage angle is 0. So if current angle is 30 degree and voltage angle is 30 degree, then you can say circuit is in same phase. So that's why generally we don't use this. This you can use for series and parallel. So this you can use for standard series and parallel. Okay, where if you are going to calculate voltage, if current angle is 0, then if you will do here voltage imaginary part 0 means voltage angle is also 0. So if you are going with voltage and if you know the current angle is 0, and you can go with current if you know the voltage angle is 0, then only you can use this. Okay, but in generally you can go with here if that is not standard RLC series or parallel. So either you can calculate impedance or you can calculate admittance. Okay, so this you can use. Are you getting my point? So if voltage is given and if voltage angle is 0, then you can calculate current, and imaginary part of current you can equate with 0. Okay, because current angle you know 0 degree, and if voltage angle is 0 degree, it means circuit behavior is purely resistive and impedance angle is 0. Are you getting my point? But if you don't know voltage, don't go with here. If you don't know the current, don't go with voltage. Clear this point? But you can go either with Z or you can go with Y. Then you can think which will be easier to you, series impedance or admittance. So first what you can do, don't write this J omega L, don't write, always you can proceed with S, because calculation of S is easier. So you can write this 1 by CS, so this is 1 by S, you can write this LS, so this is 0.1 S. So now in terms of S you can calculate. So here can I calculate Z, so Z of this circuit, this parallel this, so can I write 1 by S into 1, this 1 by S into 1 plus 1 by S. Okay, this part only we are going to calculate, and this value is nothing but here this is 1 by S and this is S plus 1 by S. Can I write? So this S and S will be cancelled out. 1 upon S plus 1. So this part impedance is 1 upon S plus 1. Can I write? So what will be the complete Z? So complete Z of the circuit is, this is 0.1 S, 0.1 S plus 1 upon S plus 1 upon S plus 1. So now you can write here J. So this is nothing but 0.1, this is J omega. Okay, or you can write this is nothing but J 0.1 omega, and here you can write plus 1 upon 1 plus J omega. Can you write? Now here calculation part is very important. How you can do the calculation? Now here calculation part is very important. Suppose if you don't want to write in this way, suppose for example, and if you want to multiply here, and if you write, don't do like this because it will take more time. So just you have to write here, if some part is already separate, then don't mix. What some student will do, this will multiply here numerator by denominator. No, because you have to separate real part and imaginary part. So if any part is already separated, so don't mix this part with here. Are you getting my point? Yes, don't mix this part with here. Just this is separate, this is separate. Just you have to write. Now what you can do here, from here can I write, sir, this is Z is equal to, this is nothing but J 0.1 omega. Yes, and this you can write plus here numerator 1 minus J omega you can multiply, and denominator 1 minus J omega you can multiply. So this is nothing but 1 plus omega square. So here imaginary part is separate. What you can write, this is real part, sir, 1 plus omega square, and here this is plus J. This value is 0.1 omega minus of omega upon 1 plus omega square. So this is real part and this is imaginary part. This is real part and this is imaginary part. So now at resonance, so at omega is equal to omega 0. Okay, imaginary part of Z you have to equate with 0. So this you have to equate with 0. So what you will get? 0.1 omega is equal to omega upon 1 plus omega square. So here this omega and omega will be cancelled out. So what you will get, 1 plus omega square is equal to 10. Can I write? From omega square, this is equal to 9. Is equal to 9. So omega is equal to plus minus 3 radian per second. Now frequency cannot be negative. Remember, frequency cannot be negative. So omega is equal to 3 radian per second. This is the answer. This is the answer. So in resonance, your calculation process is very important. So here two important things. First, IO started with S. IO started with S. First important point. Second, this part and this part I have not mixed. Okay, just both part I have written here separate. Now how real part and imaginary part? In this point, just you can multiply here 1 minus the omega numerator and denominator. Then denominator part will be real part. So here omega is 3 radian per second. Now if I will ask you what is the impedance at resonance, so here what is the value of Z? Z at omega 0. What is the impedance at omega 0? So this imaginary part will be 0. You will get 1 upon 1 plus omega square, and omega square is 9. It means 1 upon 1 plus 9. So this is nothing but 1 upon 10. This is nothing but 0.1 ohm. So what is the impedance at omega 0? 0.1 ohm for this question. So like this you can handle any question. 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 Okay, so can you solve this question? Okay, now the next question I am going to take. Okay, now the next question. Okay, now the next question. Okay, just note down. Next question. Okay, again this is a previous year gate question. Okay, and again this is a previous year gate question. So in resonance, calculation part is very important. In resonance, how you are doing calculation, that is very important. Just confirm me this problem is clear to you. Now the next problem. A series RLC circuit is operated at a frequency different from at resonance. So now here examiner are saying we have one series RLC circuit. Okay, but they are saying circuit is not operating at omega 0. No, circuit is not operating at omega 0. Okay, It means here this is RLC. You cannot apply here direct resonant concept. Now they are saying the operating frequency is such that the current leads the supply voltage. Now they are saying if supply voltage is V and supply current is I, so they are saying I leads the V. Okay, they are saying I leads the V. So if current is leading means circuit behavior is capacitive. So what I can say, then circuit behavior is not resistive because circuit is not operating at resonant frequency. So here circuit behavior is the capacitive. Can I say capacitive? So if in any circuit either it can be series or it can be parallel, if current is leading means circuit behavior is capacitive. If current is leading means circuit behavior is capacitive. Now they are asking the magnitude of current is the half the value at resonance. So magnitude of current in this circuit, the magnitude of this current, okay, is half the value at resonance. So at resonance what is the current? So I can write this I at omega 0, okay, divided by 2. So what is the actual current of this circuit? Magnitude of this magnitude of current at resonant frequency divided by 2. So this is series RLC circuit. And what is the current at resonance in the circuit? And what is a current? So at resonance, if I want to write for this circuit I omega 0, sir, I omega 0 is nothing but at resonance circuit voltage. Here this is a circuit voltage by circuit impedance. Can I write? And impedance of Z is nothing but, so this is V by R. Can I write? So what is I, and can I write this is nothing but at series RLC, this is I max. This is I max. So now here this current is nothing but I max by 2. I max by 2. Already we have calculated for I max by root 2, that is omega h and omega l. But here they are not asking omega h and omega l. They are asking I max by 2. They are asking I max by 2. And now RLC value is 111. So this is nothing but 1 ohm. This is 1 Henry and this is 1 farad. This is 1 farad. Okay. So now you have to calculate operating frequency. Operating frequency, okay, that is omega is equal to. So you have to calculate here omega. Now my question here, this operating frequency will be more than omega h, less than omega h, less than omega 0, less than omega l. So just I am asking first to you where this will exist. So if I will draw for series RLC circuit, if suppose this is a magnitude of current, you know very well, you will get this kind of current. This maximum current you will get at omega 0. This is I max. This is I max. Okay. Here you will get some frequency. This is omega h and this is omega l. And for series circuit, you know this thing. What is omega h and what is omega l? And this is I max by root 2. I max by root 2. And now one more thing you remember for series RLC circuit. For more than omega 0, circuit behavior is inductive. And for less than omega 0, circuit behavior is capacitive. You know this thing? Yes, sir, we know this thing. Now, what examiner are asking here? So, if you will study this thing in GATE exam, they will ask you next level of question. So, now what they are asking in this point, your current will be, sir, I max by 2. So, they are asking this frequency. Suppose I am saying this frequency is omega 2 and this frequency is omega 1. So, at the point where current is a half. So this is omega 2 and this is omega. Now they have said the circuit behavior is capacitive because current leads the voltage. So where circuit behavior is capacitive, so now they are asking omega 1. So what you have to calculate here? This omega 1 you have to calculate. This is the level of GATE exam. So everything they have mentioned in the question. Generally this kind of question in whole India nobody will handle in GATE exam. So if first time this kind of question examiner will ask you, in first time nobody will handle. But if you will study your basic, definitely in GATE exam, if you want first rank, if you want very high rank, at least you have to handle because this is very basic thing. So now easily you can handle. So you can write. So directly you cannot write. So now the question is this omega 1 will be less than omega l. This omega 1 will be less than omega l. Then how you can handle this question? Now how you can handle this question? So if I will ask you one important thing, this is series RLC circuit. Okay, sir. In this position, what is a Z? Z is nothing but R. Okay. In this position, sir, what is Z? Z is current is decreasing. In series RLC, current is decreasing, and you know this Z. In this position, Z is minimum. Here Z will be root 2 times of R. Can I write? Root 2 times of R. So if impedance is increasing root 2 times of R, then current is decreasing root 2 times. Now, if you will apply this concept, your question will be easier. So in this position, if current is I max by root 2, then you are getting this is root 2 times of R. So if I will write the derivation for this omega 0 and for this omega h, we know this thing. Yes, we know this thing. So for omega 0, this is omega L minus 1 upon omega C, you know, and this is omega 0, this is omega 0, and this value is equal to 0. This is first derivation, already we have studied. Now the second derivation, sir, this is omega L minus 1 upon omega C, and if this is omega h and if this is omega h, so this value will be is equal to plus R. Okay, now this is number third. Sir, this is omega L minus 1 upon omega C. Now this is omega L. In this is nothing but minus R. You know this thing. Now, in this position, if I will ask you, sir, what is the magnitude of Z? So if current is going to be half, it means here resistance is 2 times of R. Can I write 2 times of R? Then current will be 2 times of divided by maximum by 2, because resistance or impedance is increasing by 2 times. So can you write here equation? So here one equation, sir, omega L minus 1 upon omega C. This is 2 and this is 2. And one more equation, sir, this is omega L minus 1 upon omega C. This is 1 and 1. Sir, what will be this value? Yes, from your general equation you can find out. And now this is new derivation and you should remember for GATE exam. Okay, so what can I write here? What you have to calculate here? We have to calculate here omega 1. So now our standard equation for the magnitude of current. So magnitude of current is nothing but your magnitude of voltage divided by root over R square plus omega L minus 1 upon omega C whole square. You know this thing? Yes, sir. Now what will be the current at omega 1 and omega 2 frequency? This is I max by 2. So this is I max by 2. Is equal to, what is the voltage? Or you can write, what is I max? What is I max? So I max is nothing but V by Z, means mod of V by R. So can I write this value? I max is nothing but mod of V by R. Mod of V divided by, can I write this is 2R, is equal to, this is mod of V divided by root over R square plus this is omega L minus 1 upon omega C whole square. Can I write this? So this is nothing but your current is I max by 2 and I is nothing but V by R. So here this V and this V will be cancelled out. So what you can write from here? Sir, R square plus omega L minus 1 upon omega C whole square is equal to, this square I am doing, this is 4R square. So this is 4R square minus R square. So this is omega L minus 1 upon omega C square is equal to 4 minus R square, this is 3R square. So if you will remove this, so here two equation you will get. So this is omega L minus 1 upon omega C is equal to root over 3R. This is root over 3 into R. And one more equation, A1 plus, sir, this is omega L minus 1 upon omega C is equal to minus of root 3 into R. Can I write? So now again you should remember this relation. So here at one position you will get plus root 3R and at one place minus root 3R. So plus root 3R for the higher frequency. So this is omega 2 and this is omega 1. Don't remember blindly for higher frequency positive. No. If omega L minus omega C is positive, then impedance angle will be positive. Then circuit behavior will be inductive. If circuit behavior will be inductive, then inductive part of frequency you will get here omega 2. Don't say, sir, higher frequency will give positive, lower frequency will give negative. No. So this is omega 2, this is omega 1. So here you find it out the relation. Omega 2 L minus 1 upon omega 2 C is nothing but root over 3 into R, and this is nothing but minus of root over 3 into R. But what you have to calculate here? we have to calculate here omega 1. So just you can put the value L and C. L and C is given 1 and 1. And now you can solve this equation. Now derivation I have did here. I hope this thing is clear. So already derivation we have did here. So now how you can handle in GATE exam? So you have to remember this relation. So you have to remember this relation, this. Now one extra relation. If possible, you can remember. So now you have to calculate here omega 1. So I am considering this equation omega 1 L minus 1 upon omega 1 C is equal to minus of root 3 into R. So you can put the value of RLC. So this is omega 1 minus 1 upon omega 1 is equal to minus of root 3. So from here you will, if you will solve, so this is omega 1 square minus 1 is equal to minus of root 3 omega 1. So if you will do right side, sir, omega 1 square plus root over 3 into omega 1 minus 1 is equal to 0. Now you can solve this equation. Okay, now this is your homework, and omega cannot be negative. So only positive answer can be possible. Only positive answer can be possible. Only positive answer can be possible here. Only positive answer can be possible here. So omega 1 we are getting here 0.456. If you will calculate 0.456 radian per second, this is the answer. You can also calculate omega 2. When you are going to calculate omega 2, this will be plus and this will be minus. You can also calculate here omega 2. You can also calculate here omega 2. This is very, very good question. Which year? GATE Electronics 2014, and that was the best year. That was the best year. 14, 15, 16, 17, 18, 19, 20, 21, and today is 22. So GATE 2014 by which IIT? This is GATE 2014 question. This is GATE 2014 question. And in that year, in GATE 2014, especially electronics branch, this is electronics branch question, and that was the toughest year for the network analysis, for the network theory. Which IIT is conducted GATE 2014? IIT Kharagpur. So this is IIT Kharagpur, IIT KGP, and now 2022 again IIT KGP. So this concept is very, very important, because they have asked already this question. Clear this point? Clear this point? So please confirm me. Please confirm me. Okay. Please comment here. Okay. Please comment. Okay. This thing is clear or not? Now you can remember directly. At this point for series RLC, this is equal to 0. At this point, this is equal to plus minus R. And this point, this is plus minus root 3R. Otherwise, just you can write the equation and you can put the value. Clear? This is very, very important concepts. This is very, very important concept. Okay, clear? Okay, so this is your homework. Omega 2 you have to calculate here. Omega 2 you have to calculate here. Okay, omega 2 you have to calculate here. So according to me, only calculation is required here. Only calculation is required here. So now one good question I am going to take from GATE 2016. One very good problem and very good concept again I am going to take. Okay, one very good problem and very good concepts. Now, okay, in next 15-20 minutes we will finish this part, and after break, dinner break, then we will continue your last topic, that is complex power. Okay, but I will take right now 2-3 and one important derivation also. First you can note down the next problem. First you can note down the next problem, and this is my favorite question. If you will ask me, sir, which one is your favorite question in whole network theory? So this question is my favorite question. Okay, so this is GATE 2016 question. Here this is ground and one supply is given, and here this supply is 2 voltage, V1 plus V2. 2 voltage is given and one LC block is given. Here one L and this is C. Okay, and one more LC block is given. This is L and this is C. So 2 LC block is given. How many? 2 LC block is given and one series resistance is given. And again this is ground. Again this is ground. Okay, now I am providing the value this is R, this resistor is R, and here this current is I. Okay, this current is I, and the value is given 100 microhenry. This is 100 microhenry. Again, this is 100 microhenry. So inductor value is same, 100 microhenry, 100 microhenry. Capacitor value is, this is 2.53 microfarad, and this capacitor value is unknown. This is C. This is C. And here supply is given, V1 plus V2 is given. V1 plus V2 supply is given. So V1 plus V2 is given 1 sine 2 pi, 1 sine 2 pi into 10,000 T. 1 sine 2 pi into 10,000 T plus 1 sine 2 pi into 30,000 T plus 1 sine 2 pi into 30,000 T. 30,000 T. So one is V1, one is V2. You can consider any one V1. So you can consider, sir, this is V1 and you can consider this is V2. Okay, just note down this. Now what examiner are asking? The RMS value of current through the resistor will be minimum. So now examiner are saying RMS value of current across R is minimum. R is minimum. Okay, at minimum means it can be 0 or it can be minimum. Then what will be the value of C? Then C in microfarad. C in microfarad is equal to question mark. This is C in microfarad. So this capacitor value you have to calculate. So capacitor value you have to calculate. Capacitor value you have to calculate. Now just I am going to redraw the network. You can see here. So here the first voltage is V1. This second voltage is V2. Okay, now here and one LC block is given. This is L, this is C, this is L, and this is C. Two LC block is given like this. Okay, you can say this is the ground. This circuit is given, one resistor is also given. So you can connect here resistor in series. And what you have to calculate? This current, and current should be minimum. Current should be minimum. And V1 and V2 is given. Okay, now V1 I am considering here the frequency F1 10,000 Hertz. So this is 2 pi. So that's why this is frequency in Hertz. And here frequency F2, this is 30,000 Hertz. 30,000 Hertz. This is 10,000 Hertz. Can I write? Yes. Now you can see here. So this value is C and this value is 100 microhenry. This value is 100 microhenry and this is a 2.53 microfarad. So now here two supplies given. It means you have to apply superposition theorem first. Only superposition theorem can be applicable in the network. No any another method you can apply. So when you are considering V1, you can consider this circuit. When you are considering V2, you can consider this circuit. And what should be your target? Both the sum of current should be as minimum as possible. As minimum as possible. Clear this point? So here I am going to draw the network. I hope what you have to calculate, C you have to calculate. Just I am going to draw the network for superposition theorem. If I am considering V1, V1 means this is 1 sine 2 pi into 10,000 T. Okay, now, and here your circuit is, this is L, this is C, and here this is L, and here this is C. Can I write? You can write in this way. You can write in this way. And here one resistor, here one resistor. This is the first circuit. And I can write this is R. Here current is I1. Here current is I1. So this is C. This is 100 microfarad. This is 100 microfarad. And here this is 2.53. 2.53 microfarad. Okay, so when I1, what you want? Minimum I1. You want I1 should be minimum. So when this will be minimum? When this will be minimum? So minimum value of current you will get when this circuit is open circuited. When this circuit is open circuited. When this circuit is open circuited. So for this frequency, if I will find out for this, suppose I will find out for this block. Okay, first both the diagram I am going to draw. Can I remove this? Yes, we can remove this part. So now the second diagram is for V2. Then second diagram is for V2. So now I am considering V2. Now I am considering V2. This is resistor R and here this current is I2. Again here one inductor, one capacitor, again here one inductor and capacitor, one inductor and capacitor. Okay, like this. Now this inductor is 100 micro why farad, this is Henry, this is Henry. Okay, now this is Henry, 100 micro Henry. Okay, 100 micro Henry, this is 100 micro Henry, this is C, and this is 2.53 microfarad. Okay, now and this value is I2. Now voltage V2 is 1 sine 30,000, sorry, 1 sine 2 pi into 30,000 t, 1 sine into here 1 sine 2 pi into 30,000 t, 30,000 t. So here again I2 should be minimum. So what will be the I2 minimum? Now the question is, when you will get minimum current? When you will get minimum current, can I assume this is parallel RLC? Can I assume this is parallel RLC? Here this is R and this R is equal to infinite. Yes, we can assume R is equal to infinite. Can I also assume here one R, this R is equal to infinite? So if in LC circuit, parallel LC circuit, R is subsand, means R is infinite, R is infinite. Now if this block will work in resonance, if this block will work in resonance, any one block, if this block or this block, any one block work in resonance, then what will be the impedance of that block? R, and R is infinite, means open circuit. So if any one block will work in resonance, then current will be 0 ampere. So what will be your target? Here two block is given and two frequencies given. So for one frequency, either this block or this block at least should be operate in resonance, and for this frequency either this block or this block should operate in resonance, then definitely current will be 0 ampere. And already one block value is given, one block value is given. So if you will calculate from this block, if you will calculate from this block, here I am going to write, sir, this is your inductor and this is your capacitor, this is your capacitor. Okay, this value is 100 micro farad, this is micro Henry, 100 micro Henry, and sir, this is 2.53 microfarad. So what is this resonant frequency? Sir, 1 upon root over LC. And if I will calculate F0 for this, F0, 1 upon 2 pi root over LC. And if I will calculate here F0, so for this block, if I will calculate resonant frequency, so from here we are getting, so from this block, we are getting resonant frequency, okay, for either calculation, I don't have calculation. Okay, calculation you can do, calculation you can do. So from here, if we will calculate, we are getting 10,000. So F0 we are getting 10,000 hertz. We are getting 10,000. It means sir, for this frequency, this block in resonance. Are you getting my point? So for this frequency, sir, this block in resonance. So if this block in resonance, so this impedance will be R, and if R is infinite, so this block is open circuited. So what will be I1? I1 is 0 ampere. I1 is 0 ampere. I1 is 0 ampere. Now your target, sir, I2 should be 0 ampere. I2 should be 0 ampere. So what you can do? So this block resonant frequency, I can write F0 is a 10,000 hertz. 10,000 hertz. So this block resonant frequency cannot be 10,000. Cannot be 10,000. And here C is unknown, but frequency is given. So what you can do here for second block? Can I remove this? Yes. For this block, this should be resonant frequency. So what you can write here? This F0 should be equal to 1 upon root over LC into 2 pi. Can I do? And F0 is given. This is 30,000. 30,000 1 by 2 pi root over LC. And just you have to equate and you can calculate the value of C. So now for this value of C, this circuit will work in resonance. And if this block will work in resonance, so here current will be 0 ampere. So here I2 will be 0 ampere. I2 will be 0 ampere. This concept you have to apply, and answer just find out 0.281 microfarad. If you will calculate this, you will get 0.281 microfarad. This is the answer. This is the answer. Okay. So now here some theory I want to discuss. Now here some theory I want to discuss for this concept. Okay, so here what examiner can ask you, what examiner can ask you here. So suppose for example, if this is a one LC block, this is one LC block, this is one LC block, here I am considering 3 LC block, 3 LC block. Okay, I am considering 3 LC block, and this is parallel, this is parallel, this is parallel LC, this is parallel LC, this is parallel LC. So 3 parallel LC block is given. If then if you want to operate complete circuit in resonance, so 3 frequency, 3 voltage is required. So here 3 voltage is required, 3 voltage is required. 3 voltage means 3 frequency is required. You can say 3 frequency is required, because one resonant frequency you will get from here. So you will get here omega 01, you will get for this frequency omega 02, and here you will get omega 03. Then if you want a circuit should always operate in resonance, then this should be operate in resonance for one frequency, this should be operate in second frequency, and this should operate in resonance for third frequency. So here 3 frequency is required. So this question is from this same concept. So here 2 block of LC and LC is given, and 2 frequency they have provided. So what you have to do, for one frequency one block should operate in resonance, for second frequency second block should operate in resonance. But here frequency was given, and for one block L and C was given, and this L and C you can calculate which frequency, for which frequency this is going to be operating in resonance, and here C is unknown and frequency is given. So you can calculate from here what will be the value of C if this is a resonant frequency for this block. You can handle. So this concept you should remember in your mind. If in gate exam LC block, LC block, LC block, many number of LC block if connected in series, and if you want to operate complete circuit in resonance, then 3 frequency will be required. So here in this source, here V1 plus V2 plus V3, 3 voltage will be required. This frequency should be omega 01, this frequency should be omega 02, this frequency should be omega 03. I hope now this concept is clear to you. I hope now this concept is clear to all of you. This is very best example, best question from resonance. Okay, many student will ask many where, sir, how we can handle this question, how we can handle this question. So just confirm me this problem is clear or not. So just confirm me this problem is clear to everyone or not. Okay, now one last derivation, just I am telling you, derivation I will not do, okay, but just I will provide you. Okay, but just I will provide you, okay, the concepts. I will provide you the concept. Okay, now just note down. First confirm me this is clear or not. First clear me this problem is clear to everyone or not. This concept is clear to everyone or not. This concept is clear to everyone or not. Just confirm me this concept is clear to everyone or not. Best example I am considering, best example. Okay, generally everyone generally target is there is a question. Best last question was very best question. This is also a very best question. So just confirm me this thing is clear or not, so that I can continue the next problem. Okay, so right now we have studied, okay, series RLC and parallel RLC resonant frequency. In another circuit you can calculate impedance or admittance and you can equate imaginary term with 0. But one more circuit you can remember. So 3 circuit you should remember. So third important circuit, if one resistor and inductor are connected in series and one resistor and capacitor are connected in series. Suppose this is RL, suppose this is RC, this is L and this is C. Okay, now so here this voltage is V and this current is I. Okay, so here what will be the resonant frequency for this circuit? Don't write omega 0 1 upon root over LC, no. So for this circuit, omega 0 will be equal to, sir, 1 upon root over LC. No, this is wrong answer. Here this is the wrong answer. Here this is the wrong answer. So derivation you can find out this y, you can calculate y whole circuit, y you can calculate, then imaginary term you can equate with 0 and get exam. But if possible, you can remember directly omega 0 for this. So what will be the omega 0 for this? Omega 0 resonant frequency for this circuit 1 upon root over LC. Okay, this term will multiply with root over numerator is the inductor. So this is nothing but RL square minus L by C divided by RC square minus L by C. RL square minus L by C, RC square minus L by C. So this is the omega 0. This is the omega 0. Okay, so omega 0 resonant frequency for this circuit. Okay, now if I will give you next example. Suppose, sir, if both the R is same, if this is R, this is L, this is L. Sir, if this is R and if this is C, like this. If this is R, both the R is same. If this is R and this is R, this is L and this is C. Sir, what will be the omega 0 resonant frequency for this? So from here, RL is equal to RC. So here, sir, RL is equal to RC. So if RL is equal to RC, so this and this will be cancelled out. So for this circuit, resonant frequency 1 upon root over LC. So many circuit you will get this answer. So sometimes student will put always resonant frequency. No, resonant frequency 1 upon root over LC is for some specific circuit. Okay, next example. Next example, if I will consider, sir, this is AC supply. If here this is R, if here this is L. Okay, now, and if here only capacitor. This is most important circuit. This is called tank circuit. This is R, this is L, and this is C. This is tank circuit. This is tank circuit, and this is most important. Sometimes L and C are the tank circuit, but inductor cannot be pure inductor. So this is the internal resistor of inductor in real life. Sir, what will be the omega 0? So omega 0 1 upon root over LC. Can I write? Yes. From this you can write, sir, RL is nothing but here R. Okay. So RL is R minus L by C. This is R square minus L by C divided by, sir, RC is 0. So this is minus L by C. So this is minus L by C. Can I write? So now from here, omega 0 is equal to 1 upon root over L by C. Sir, minus L by C divided by minus L by C. You can write 1 minus. This will be minus R square divided by L by C. R square divided by L by C. Can you write in this way? And here this is root. Here this is root. Then from here, omega 0 is nothing but 1 upon root over LC. And you can write, sir, this is root over 1 minus, this is R square C by L. Okay, this is again very important relation. 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 Okay, you should remember this. You should remember this. You should remember this omega 0 for this circuit. Okay, you should remember this. Now one important concept I want to also discuss here. So okay, so just remember resonant frequency for this. Just you should remember resonant frequency for this. But if you don't remember, do not worry. In GATE exam, you can find out this y, and you have to equate imaginary part of y is equal to 0. Okay, but if possible, you can remember only this. By using this, you can also remember this. You can also remember this. If R here, if RL is 0, RC is given, but this kind of circuit generally you will not get. But suppose if this kind of circuit is given, if RL is 0, RC is given, so you can also find out. So any circuit in combination of this, anyone can be 0. If this is 0, this is 0, this is 0, this is 0, this RL is equal to RC, any value, only value is going to be changed, or any elements are absent, then you can write here omega 0. Now one important point I want to discuss here. One important point I want to discuss here. I hope this thing is clear. Just this part I am going to remove, and this part, okay, I am going to remove. Now come to this circuit. This is very important circuit. Very important circuit. You can see here. In numerator, sir, R square minus L by C. If in this circuit you will get one relation. So just I am writing. If we have one tank circuit means RL parallel with capacitor. Suppose for example, if this is R, this is L and this is C. Now here if the condition, if R square should be is equal to L by C. Suppose if this condition is true, R square is equal to L by C, then what will be the resonant frequency? If R square minus L by C, this you are getting 0. If this is 0, so omega 0 will be 0. It means if you are getting this condition, then circuit will be, in this case, circuit will be always in resonance. Always in resonance. Always in resonance means, sir, for which frequency? For all the frequency. For any frequency. For any frequency. This is very, very important circuit. So, sir, can we design a circuit? That circuit will always operate in resonance for any frequency. Yes, this circuit. But the condition you should remember, when RL and this C is given, if R square is equal to L by C, if this condition is satisfied, then for any frequency, this circuit will operate in resonance. Then this circuit will operate in resonance. This is very, very important thing. This is very, very important thing. So, circuit will always operate in resonance. Always operate in resonance. Okay, so remember this condition. Remember, sometime examiner can directly ask you question. Suppose if I will provide you, suppose one question, sir, this is R, this is L, suppose this is 4 and here this is capacitor. So R square is 16 and suppose this is 16 farad, 16 Henry and this is 1 farad. Okay, so what you are getting here, sir, R square is nothing but 16 and L by C is nothing but 16 by 1 is equal to 16. It means here R square is equal to L by C. Then sir, this circuit will operate in resonance for which frequency? For any frequency, this circuit is in resonance. So this circuit is in resonance. So what will the answer? This circuit is in resonance. This circuit is in resonance for any frequency. For any frequency. So always circuit behavior is resistive. Always circuit behavior is resistive. Then what will be the value of impedance? Impedance will depend on the omega, which omega you are applying. But always imaginary part you will get 0 for this circuit. For this circuit, you can try. Okay, just I am going to write this circuit. Okay, now suppose this question is given. Again, I am going to draw this. This is R, this is L. Okay, now and this is C. Now here R is 4 ohm. This L is J omega L. So can I write J omega is omega and J omega 16, and now this is 1 upon this is J omega C. So this is J omega and C is 1. Can I write? Yes, we can write. So can I find out here Y? So Y of this circuit is nothing but 1 upon 4 plus J 16 omega. Can I write? Yes, sir. And this value is, this admittance is plus J omega. Can I write? From here what you will get Y? Sir, this is 4 minus J 16 omega divide by, you can write, sir, this is 4 square and this is plus 16 omega square. You can write, and this is plus J omega. Okay. So what will be the Y here? Y will be here. This is 4 upon 4 square plus 16 omega and this is whole square and this is plus J. You can write here omega minus of 16 omega divide by 4 square means 16 plus 16 omega whole square. This is the imaginary part. So either from Y or from Z, from anywhere you can calculate. So imaginary part of Y equate with 0. Imaginary part of Y you have to equate with 0. So if you will equate with 0, so what you will get from here? Sir, omega is equal to 16 omega upon 4 square plus 16 omega whole square. This omega and this omega will be cancelled out. So what you will get from here? So 16 plus 16 square omega square is equal to 16. Will you get like this? Yes, sir. 116. This 16 you can cancel out. 1 minus 1 you will get 0. So from here you are getting 16 omega square is equal to 0. So omega, what omega you are getting? What omega you are getting? So omega you are getting here 0. So practically omega we are not getting here 0. So omega you are getting here 0. So for omega, you are getting here 0. Okay. Omega, you are getting here 0. Omega, you are getting here 0. Okay. So omega, you are getting here 0. So when you are getting omega is equal to 0, it means when you are getting omega is equal to 0, it means okay, no, please, one thing you have to correct. Please correct. This is wrong. This circuit is not always in resonance. Please correct this statement. This statement was wrong. Okay, this statement was wrong. So if R square is equal to L by C, circuit will be always in resonance. Sorry, this statement is wrong. This is not for this circuit. Okay, this statement is wrong. So please correct. Please correct here. If you are getting a tank circuit, and if R square is equal to L by C, in this case resonant frequency is 0. So in this case directly you can write, sir, what is resonant frequency? 0. You are getting here resonant frequency 0. Okay, so just you have to correct this. You have to correct this statement. Okay, you have to correct this statement. So if you will get this tank circuit, and if R square is equal to L by C, then from our formula also we are getting omega is equal to 0. So in this case resonant frequency is 0. Now I will ask you, so here resonant frequency you are getting 0. Now if I will ask you, what is impedance, what is admittance at this resonant frequency? So this value will be 0. 4 upon 4 square. So 4 upon 4 square is 1 by 4. So Z you are getting 4 ohm. So here Z you are getting 4. So for this, what is Z at omega 0? So Z at omega 0 we are getting 4 ohm. Okay, we are getting 4 ohm. Clear this thing? Just you have to remember. What is this resonant frequency for this circuit? Omega 0 is 1 upon root over LC, and this is root over here R square minus L by C divided by minus L by C. And if R square minus L by C is 0, means resonant frequency will be 0. Not always. Just you have to correct this statement. Okay, sir, do you have any circuit and that circuit will always operate in resonance? Yes, we have one circuit. First, this statement you have to correct. This circuit will not operate always in resonance. If R square is equal to LC, then here you are getting resonant frequency is 0. Now one more circuit I am going to consider. Okay, so just remember this. Just I want to tell you, sometime you don't remember direct formula, calculate impedance or calculate admittance, and just you have to equate imaginary part or real part 0. Now one more circuit I am going to consider here. Sir, here one more circuit. This is R, this is L, this circuit, and this is R and this is C. Okay, this is R, this is L, this is R, this is C. Okay, now in this question, if R square is equal to L by C, in this circuit here R should be also present. In previous circuit here R was absent. Clear this point? In this circuit, if R square is equal to L by C, then circuit always in resonance. Then circuit always in resonance. Remember this thing. Okay, how you can see? Already we have calculated omega 0 for this. Sir, this is 1 upon root over LC, and here this formula was root over R square minus L by C, and this is R square minus L by C. Will you get like this? Yes, sir, will you get like this? And if R square is equal to L by C, so here this is 0 by 0, and 0 by 0 is not defined value. So if you will see here R square is equal to LC, if both are different, so this will cancel out and you will get 1. But if R square is equal to LC, so here 0. If R square is equal to LC, here 0. So in this situation, okay, I am not going with derivation. Okay, but at least you can judge from here. If R square is equal to L by C, then definitely here mathematically you are getting 0 by 0. And 0 by 0 practically not defined. If you are considering this negative, this 0, this will be infinite. If you are considering this 0, this will be 0. Here 1 upon root over LC for any value of this, if this condition is true, for any value of L and C, circuit will always operate in resonance. Circuit will always operate in resonance. So just remember this two circuit. Just remember this two circuit. Okay, and one more circuit. If this is RL, this is RC. So here this is RL, this is RC. This is RC. So this formula you should remember. So in this circuit, if R square is equal to L by C, your resonant frequency will be 0. And in this circuit, if R square is equal to L by C, so circuit will always operate in resonance for any frequency. Circuit will always operate in resonance for any frequency. For any frequency. So circuit always operate in resonance for any frequency. Clear this point? So this 3-4 standard circuit you can remember. If you don't want to remember, no worry. No worry if you don't want to remember. In GATE exam, they will provide you the value, but sometime they will provide you the value and you just calculate impedance or admittance and just you have to equate imaginary part 0. But this condition is very, very important. Sometime they can ask direct questions from this condition. R square is equal to L by C. So this two circuit you can remember. If you don't want to remember this circuit, you can leave this. You can remember at least this circuit. If here R square is equal to L by C, so this RL and RC circuit and both R should be same. This is important point. Both R should be same. Then in this case, a circuit will always operate in resonance. Okay, so if omega is 1 radian per second, 10 radian per second, 100 radian per second, 1000 radian per second, 0.1 radian per second, for any value of omega, the circuit will always operate in resonance. The circuit will always operate in resonance. The circuit will always operate in resonance. Okay. So I hope each and every concept in resonance I have discussed. Each and every concept I have discussed in the resonance. Okay. So you can expect at least more than 90% concepts I have discussed in the resonance. And if you are comfortable in this part, so 100% in GATE 22. You can solve all the question from resonance. Now you have to solve some questions. Okay, all the question will be formula based. Okay, already good question I have discussed here. Okay, all the good question I have discussed here. Okay, so now can we take one break? Now can we take one break? Now can we take one break? If anybody have any doubt, ask me. If anybody have any doubt, just ask me. If anybody have any doubt, just ask me. So for this circuit, you can also remember what is the impedance of this circuit? Z. So Z, okay, you can calculate. Okay. So, but in this situation, what is Z? Z is equal to, already you calculate, Z is equal to R. In which condition? When R is equal to L by C. In this condition, what is the Z of this circuit? Equal to R. But don't remember this. Okay. In GATE exam, you have 2-3 minutes at least time. Okay. So you can solve. But this condition at least you should remember. Okay. So two things you should remember. Series RLC, parallel RLC now, and then this circuit you remember, and one more, this circuit you remember. If this is RL and if this resistance is RC and this is capacitor, this is C, this is R, this is L. In this case, what is omega 0? So omega 0 is 1 upon root over LC and then root over, okay, root over, this is RL square minus L by C divided by RC square minus L by C. This formula you should remember for this omega 0, for this circuit omega 0, for this circuit omega 0. Okay, and for this circuit, if both the R is same, in this case you remember this condition. If this R square means this multiply this should be is equal to this divided by this. So R into R, this R square should be is equal to this L by C. Then circuit will always operate in resonance. Means for any frequency, circuit will operate in resonance. Clear this point? So after break we will continue. Okay, I hope this thing is clear. Sir, is the last circuit is tank circuit. Okay, yes, you can say tank circuit, but no, this we cannot say this is exactly tank circuit. Tank circuit is practically inductor parallel with capacitor. This is actual tank circuit, but pure inductor cannot be designed. So here generally we can consider one resistor. So this is either tank circuit or this is LC or the tank circuit. So if in GATE exam, examiner will tell you tank circuit, so you can consider LC, and if they will provide resistor, so you can just write here R. This is the actual tank circuit. Okay, because capacitor generally pure we can design, this R is not necessary. This R is not necessary. That's why in real world this circuit and this circuit is not much importance, but in gate exam they can ask you the question from here. In real life this circuit is very important. So this formula is very important. Okay, so three formulae you have to remember: one for series RLC, one for parallel RLC, and one for this circuit, one for this circuit. And in this circuit both resistor can be same, this resistor can be absent. So these 3-4 questions you can create from here. Clear this point? Okay, so now, so after break we will continue the session and we will start complex power, so now you can take the dinner, you can take some relax, and last topic is very important, that is very interesting topic, complex power. Okay, so after break we will continue. Okay, so after break we will continue. Okay, after break we will continue. So now the time is your 8:50. Okay, so we will meet after 1 hour. Okay, so at 9:50 we will meet, okay, so 9:50 is okay. Yes sir, complex power, yeah, complex power is very interesting topic. Okay, and each and everything I will tell you. So if you don't know anything in complex power, we can handle after completion 1.5 hour of classes, 1.5 hour of classes we will conduct. Okay, so after 1 hour we will meet. If anybody have any doubt, ask me. Okay, so can we pause the session? Okay, so we will meet at 9:50 or 10. Okay, we will meet exact at 10 p.m. Okay, thank you, take care, and we will meet after exactly 1 hour and 9 minutes. Okay, thank you. Yeah, good evening everyone. Welcome back. Okay, welcome to Gate Academy. So just confirm me audio is clear to you or not. So everybody just confirm me audio is perfect. So now the last topic of this our marathon session, that is complex power. So now we are going to discuss complex power. Okay, complex power. Complex power. Okay, so complex power we are going to start. Okay, everyone, just confirm me audio is perfect. Okay, and now everybody join now. And this is your last topic. I hope you are comfortable in if a circuit is resistive. If a circuit is purely resistive, then we will not say that is a complex power. In that case, always we have to calculate P. Always you have to calculate power P. Suppose if you have a load and load is purely resistive. So here two cases can be only possible. Only two cases can be possible. If this is a DC, voltage is DC, then 100% current will be DC, because for resistive circuit, voltage and current will be in same phase. So what is exactly difference here? If load is resistor, then the phase difference between voltage and current is same. So this circuit will always operate in, you can say, unity power factor, but generally will not talk about here unity power factor like this, because this is a DC supply. Because here this is a DC supply. So if per supply DC, current is DC. So in very basic, V is equal to IR. You can find out I is equal to V by R. You can write R is equal to V by I. So any value you can calculate. So power, here directly power you will calculate either I square R or V square by R or V into I. And this unit is what? You know very well. Now suppose if across the resistor, suppose if you have a resistor in the load, and if time varying voltage is given, so it can be sinusoidal, it can be anything, it can be just I am going to assume this is V of t, voltage, time dependent function. So definitely current will be also time dependent function, and phase will be, both the phase will be same if this is a sinusoidal. So if this is a Vt, 100% current will be It, the function of time, because R is a constant. So here what is Vt? Vt is nothing but directly I can write It into R. Sir, what is It? Directly can I write Vt divided by R, because R is constant. And what is R is nothing but Vt by It, can I write? Yes, you can divide. Okay, and Vt by It will be cancelled out here. That's why you will get a constant R. So in this situation, sir, what is practically power? So in this situation, you will calculate Pt. So Pt is nothing but Vt into It. So here time dependent power you will get. Now the important thing, here you can also write, sir, I square into R. Here this is nothing but V square T by R. This is called instantaneous power. So this is a function of time. So what we can say, sir, this is a instantaneous, can I say power, instantaneous power. So this is a function of time, and all the unit is here P in, this is what. Okay, so now here generally what examiner are interested in, average power. So here you have to calculate average value over one time period. If here Vt or It is periodic, so can you calculate average power? Yes. So here average value you can calculate of Pt like this, and this is nothing but what. So when examiner are interested in calculate power across resistor, so only two cases can be possible. If voltage is DC, current will be DC. So basic formula you can apply. But if time dependent voltage, then time dependent current. In that situation, you will get a time dependent power. Power is a function of function of time. In that time, you have to calculate P average. And what is the formula of this P average? So direct this P average formula we can write. If here Vt is sinusoidal, It will be sinusoidal. One important thing, if this is resistor, so phase of both sinusoidal will be same, cannot be different. Phase cannot be different. So in this situation, directly P average we can write I RMS square into R, or we can also write V RMS square divided by R. You can also write V RMS into I RMS. So this value is exactly equal to the average power of this is the average power. Clear this point? So that's why directly we apply this formula. We apply this one. So one thing you remember, where you can apply this I RMS square into R, or V RMS square divided by R, or V RMS into I RMS. when your load is resistor, or if you want to find out power across pure resistive circuit. Clear this point? So at least this basic you should know about the power. Now here now our topic is a complex power. So complex power generally we will use okay for AC circuit. So complex power we will use for AC circuit. So this topic mainly we will use in AC circuit. Not here voltage is a square wave or any kind of this function. Okay, so generally we will use here square wave. We can use, you will get some kind of harmonics, but generally all the this supply voltage and current should be in terms of sine and cos. Generally where we will use complex power. Why we are studying this topic? So in generally two kind of supply generally we will use, one DC and one is AC. So for DC supply you should know, but sometime examiner are interested in VT and IT. So in that time examiner can be ask you instantaneous power. So instantaneous power is a function of time, and this average value is nothing but P average. If you are not comfortable in I RMS square into R, you can go with this. I hope this thing is clear to you. Now here complex power, generally our load is here, our load is complex. So here for AC circuit, and here our load is a complex, and our load is here complex load, and here our load is complex. So in this situation, sir, how we can calculate the power? So how many power can be possible, which power can be possible, and how we can handle this kind of question? So first this basic should be very clear, where we are calculating the power. So okay, across the resistor we are calculating, means load is purely resistive or load is a complex load. Clear this point? Okay, now so in two way you can say, if suppose we don't know about this load, suppose for example if I will ask you one question, suppose here sir this is VT, here this is VT, and here we are getting this IT, here we are getting this IT, and we don't know about this load, we don't know about this load. If there are phase difference between VT and IT, so if a phase difference between VT and IT is equal to 30 degree. This is a first question. And now the second, if a phase difference between VT and IT is equal to 0 degree. So if 30 degree, then what is a load? So here load is, if phase difference between VT and IT is positive 30 degree, so voltage angle is more, current angle is less, it means 5Z. So here impedance angle is 30 degree. Impedance angle is 30 degree means positive, it means your load is inductive load. Load is a complex, can I write? Load is a complex, you can say this is inductive load. And in this situation, if this is 0, it means 5Z is equal to 0 degree, it means load is resistive. Load is resistive. So sometimes load is not given, but current or voltage is given, and if there some phase difference between current and voltage, it means load is a complex load. Are you getting my point? So either examiner will provide you loads or examiner will provide you VT and IT. Okay, so if phase difference, load is resistive, sorry, load is complex. If no phase difference is 0, load is resistive. So how you can handle this resistive load? Okay, so this thing I hope we have studied in the basic class, and you know this very well. Okay, now in this class we are going to discuss a complex power. Okay, so what will be the formula for complex power, and how you can handle any question, and how you can handle any question, and how you can handle any question. Okay, so how we can handle any question, how we can handle any question here. Okay, so I hope this thing is clear to you. So complex power is represented by S. This is a complex power, this is a complex power. So complex power is represented by S. S is called complex power. S is called complex power. And sir, is there any name? Yes sir, this is also called apparent power. This is also called apparent power. This is also called apparent power. Okay, this is also called total power. So in this three name we can call, this is also called total power. Okay, so S is called complex power, apparent power, or total power. Sir, what will be the formula for this complex power? Everybody know this formula. So just I am going to write, this is nothing but VI RMS into, this is I RMS, and this is conjugate. Why we are writing conjugate? Because here angle is also important. Angle is also important. So VRMS into IRMS conjugate. This is very, very important. So now, sir, my question, this S you will get in polar form or rectangular? Yes, sir. So here just here to find out this answer in terms of polar form. Polar form with angle. So here angle and magnitude, both value is very important. Generally student are concentrating on the magnitude in power. No, here angle is also very important. Angle will exactly provide you some information. Okay, so angle is very, very important here. Angle is very, very important here. Here angle is very, very important. Okay, angle is very, very important. So sir, what will be the VRMS? VRMS, how we can represent? VRMS can I write? VRMS can I write? This is a maximum value divided by root 2. Okay, and what will be the angle? This is a voltage angle. So can I write theta V? Can I write theta V? And similarly, IRMS. IRMS can I write? This is a IM, maximum value of current, divide by root 2, and angle I can write, this is theta I. Can I write theta I? So this is VRMS into IRMS. Then sir, what will be the IRMS conjugate? Then IRMS conjugate we can write IRMS conjugate. If you are writing conjugate, angle will be negative. Remember this thing. So this is nothing but Im by root 2, and this is angle of minus of theta I. Angle of minus of theta I. So if you will calculate here S is nothing but, if you are going to put the value, sir, Vm by root 2 into Im by root 2 into what is angle? So angle is, this is theta V minus of theta I. This is very, very important. And now you can also write this complex power is nothing but Vm Im by 2. This is angle of, you can also write this is phi. Can I write this is phi? And now this phi is, what is phi? Phi is angle of V minus angle of phi. Difference between voltage angle and current angle. Difference between voltage angle and current angle. This is very, very important. We can also write this is phi, angle of voltage minus of angle of current. So angle of voltage minus angle of current. What is Z? Z is nothing but V by I. What is angle of Z? So this is phi is nothing but angle of Z. This is nothing but, you can also write phi Z. So this phi is nothing but here phi Z. Okay, and can I write this is phi S? This is for complex power. So can I write this is phi S? Just I am going to write this is phi S. So phi S is nothing but, so complex power angle is nothing but angle of impedance, impedance angle. This is very, very important thing. So first important point you should remember, sir, angle of S, and I am going to write phi S is nothing but angle of Z, and angle of Z you can also write phi Z. This point is very, very important. So first important point you should remember. First important point you should remember. First important point you should remember. Okay, now come to the point. Now come to the point. So here some basic electrical circuits concept is required only. This topic is very, very easier topic. This is not a tough topic. This is very, very easier topic. Okay, so now if I want to write this in, this is a polar form. Can I write, sir, this is a polar form. This is a polar form. This is a polar form. Sir, can I write this in exponential form? Yes, sir. So in exponential form, can I write S is nothing but Vm Im by 2, Vm Im by 2. Okay, e raised to power z phi s. Can I write? Can I write? Yes, this is exponential form. And now we can also write this Vm Im by 2. And this you can write, this is cos phi s plus z sin phi s. Can I write? This is rectangular form. This is rectangular form. So there are so many forms here. This is a rectangular form. This is rectangular form. So we can write S in different way. This is a first form, polar form. This is a polar form. This is exponential form. Exponential form generally we will not use, and this is a rectangular form. Here S we can write Vm Im by 2, and this is nothing but cos phi s and plus z Vm Im by 2. Vm Im by 2. This is sin phi s. Now the important point is, sir, this Vm Im is magnitude. Yes, this is only magnitude. So sometime you can also write, sir, this is magnitude. You can also write, sir, this is magnitude. You can also write this is magnitude. Now what will be the, sir, unit of complex power? So remember, unit of complex power is volt ampere. Don't write watt. Unit of complex power is volt ampere. Unit of complex power is volt ampere. Okay, unit of complex power is volt ampere. Okay, so this thing is clear to you or not? Okay, so now we can write, can I write this value P and can I write this value S? So Q, this is nothing but P plus JQ. This is very, very important thing. So as we can write P plus JQ, unit is volt ampere, and here unit is volt ampere. Unit is volt ampere, volt ampere. Okay, so what is the P and what is the Q here? So P we can write, sir, this P is a real power. P is a real power, and what is Q? Q is a reactive power. Q is a reactive power. Okay, now we can also say this is a real power. You can also call this is active 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 power. Now what will be the unit? So unit of P is nothing but watt. Unit of P is nothing but watt, and unit of Q is nothing but VAR, volt ampere reactive. This is nothing but volt. This is ampere. This is reactive. Reactive. You should remember this thing. So you should remember this thing. Now, sir, what is the value of P and what is the value of Q? So again, I am going to write P. So P, if you want to calculate a real power or active power, and if you want to calculate reactive power, so P, how we can calculate? P is nothing but, sir, Vm by 2 and Vm into Im by 2 cos phi. This is the first formula, and you can write this is a phi s. Phi s is the angle between voltage and current. This is the important thing. You can say this is a complex power angle, or you can say this is the impedance angle. And we can also write, sir, Vm by root 2, Im by root 2. So can I write, sir, this is Vrms, and this is magnitude, and this is Irms. This is magnitude. This is important thing. Vrms, Irms into cos phi s. Can I write? Yes, we can also write, because Vm by root 2 is Vrms, Im by root 2 is Irms. And what is the unit here? Unit is the watt. So generally we will remember this formula. What is the formula for P? Vrms, Irms cos phi. Okay. Now, sir, what is the Q here? Q is nothing but, can I write, this is Vm, this is Im by 2, this is sin phi s. And the important thing is here, sir, this is the amplitude, this is amplitude, this is amplitude, this is amplitude. So what you can also write here, this is nothing but Vrms, this is amplitude, into Irms, and this is amplitude into sin phi s. And the unit is here volt ampere reactive. Volt ampere reactive. Clear this thing? So you remember this formula. What is power? You don't remember this. Remember only this. P Vrms Irms cos phi, and the Q is Vrms Irms sin phi. What is phi? Phi is either impedance angle or angle between voltage and current, or you can say complex power angle. Clear this point? Now come to the here. Then, sir, what generally we will write as? So what you will write as? S is nothing but P plus JQ. So S is nothing but P plus JQ. So this S formula you should remember. S is P is nothing but Vrms, this is amplitude, into Irms, this is amplitude cos phi. This is P, and this phi is phi S, and this is plus J, Vrms, and this is amplitude. This is Irms, this is amplitude, and this is sin phi, and this is sin phi s, and unit is here volt ampere. Unit is here volt ampere. So these three formula you should remember, P, Q, and S. Clear this point? And what is the S? What is the angle of S? That is a phi s. That should be clear to you. Okay, that should be clear to you. Okay, now, and next formula you should remember, this is a S is equal to, this is nothing but Vrms into Irms conjugate. Okay, so this is rectangular form and this is polar form. This is polar form, and this formula you can also remember in this way. Sir, this is Vrms, this is amplitude, and this is Irms, this is amplitude, and what is angle? This is magnitude, And what is angle? This is a phi s. You can also remember in this way, and unit is here volt ampere. So if I will draw here power triangle, what is the power triangle? So can I draw here power triangle? Power triangle. Sir, can we draw here power triangle as with respect to P and Q? Yes, we can draw. We can draw if suppose this is P and if suppose this is Q. Okay, if suppose this is P and this is, so what is the P plus JQ resultant? Resultant, this is S. So this is Q. You can write, sir, this is P. This is P, this is Q, and this resultant is nothing but S. So what is the S here? So magnitude of S is nothing but, can I write root over P square plus Q square? From here you can also write magnitude of S is root over P square plus Q square. And what is angle of S? Angle of S, either you can write sir tan inverse Q by P. You can also write in this way, but you know very well what is angle of S is nothing but phi S, and phi is nothing but phi Z. Phi Z is angle of Z. So this is your choice. So here this angle is your okay. What is the angle of S? What is the angle of S? If I will ask you what is the angle of S, so that is nothing but tan inverse Q by P. Okay, so tan inverse Q by P. Okay, yes, so this is P and this is Q. This is P and this value is Q. This value is Q, this is S. You can write this is phi S. You can write this is phi. This is a power triangle. This is a power triangle. This is power triangle. So now here, if you want to calculate power factor, suppose if you know P, if you know Q, and now if you want to calculate power factor, so what is it? Do you mean P? P means VRMS, IRMS cos phi. Q means VRMS, IRMS sin phi. If you will divide this two value, so VIRMS, IRMS will cancel out. You will get cos phi s by sin phi s, means tan phi s you will get. But if you know this thing, from here you can find out any value. So if directly can I find out, sir, here cos phi s, and this is nothing but power factor. So what is the power factor? This is nothing but cos phi s. And what is a cos? What is a cos? What is a cos? This is a base. Base is P. And what is hypotenuse? This is P by S. P by S. So from here, you can write P is nothing but S. S cos phi S. Can I write? And this is amplitude. This is amplitude. This is amplitude. This is very, very important. Don't write here angle. When you are going to use any formula in terms of cosine, don't use angle. So from here, can I write what is the power? P. So sir, P is nothing but magnitude of S into cos phi S. Yes, magnitude of S into cos phi S. And already you can also write, sir, this magnitude of VRMS into IRMS is nothing but magnitude of S. This is nothing but magnitude of VRMS into IRMS. So same value, same value. So what is the P? Magnitude of S into cos phi S, into cos phi S. Now can we write here sin phi S? Yes sir. What is sin phi S? What is sin phi S? Sin phi S is nothing but perpendicular, that is Q. So Q by this is mod of S. So from here you can also write, sir, magnitude of Q is nothing but magnitude of S into sin phi S. Sin phi S, and P unit you know very well. This is watt and this is volt ampere reactive. This is watt and this is volt ampere reactive. So this everything you have to relate here. Everything you have to relate here. Okay, yeah, I will discuss good problem. Wait for that. But at least you should know. Otherwise, you will trap in the problem. So first you should know each and every basics. Okay. So all the basics I will apply in the problem. So at least 15 minutes you have to study this basics part. So I hope this thing is clear. So don't be wrong in the formula. Okay. So don't be wrong in the formula. So this complex power, okay, this basic thing should be clear. Now I am going to take one example. Clear this thing? So now I am going to take one example. Now I am going to take first example. Okay, now. So just note down first example here. Suppose for example, we have one load. Okay, suppose this load is X, and here voltage Vt is given, and here current IT is given, and current IT is given. Okay, now VT and IT is given. So this is the first category of question. Examiner will provide you voltage and current, and in voltage and current only here one frequency component are present. This was the first question. Suppose this is 10 sine 3140. 3140 is 2 pi f value 340, and now IT is suppose 2 sine 3140 plus we are getting some angle is suppose 60 degree, and this is ampere and this is volt. So if across a load voltage and current is given, you have to calculate all the value P, you have to calculate Q, you have to calculate S. So now examiner can ask you calculate total power, calculate active power, calculate reactive power. Okay, so this is the first category of question. How we can handle? Okay, sir, I want to take GATE Academy English course, so we wanted to contact you. Okay, so already you can go to website. Okay, otherwise in Telegram you can message me. Okay, otherwise in GATE Academy website you can go, and already you can select the English course. And tomorrow definitely 26 I think there are some more discounts, so at least we have to visit our site. So this is a first category of question. So here first you can find out, sir, VRMS. So directly magnitude of VRMS. So sir, what is magnitude of VRMS? This is a 10 by root 2. Yes sir, this is a maximum value. Sir, what is a magnitude of IRMS? So magnitude of IRMS is 2 by root 2. Okay, now sir, what is the angle? What is the angle of V? Or I can write theta V. So what is angle of V? This is sine, and here angle is 0 degree. And what is, sir, angle of here? Current. And I can write, sir, this is theta. This is 60 degree. This is the important. Sir, angle of I is 60 degree. Angle of I is 60 degree. Okay, now. Okay, now. Yeah, Avilas, 5, 6, 7 are watching. Okay, no issue. Okay, so here angle of V and angle of I. So here the important thing is what is the angle of phi s? Anybody can tell me what is the angle of phi s here? Anybody can tell me what is angle of phi s? Either you can say, or angle of s you can say, or you can say angle of z, or you can say angle of z. Anybody can tell me what will be this value? Many time most of the students are wrong here. Many time wrong here. What is the angle here? So generally what student will do here? Sir, this is 0 degree, this is 60 degree, difference is 60. No, you will be wrong. That's why I have written here. So what you will write here? So this value is nothing but theta V minus theta I. So always first you have to find out how you can calculate. You have to calculate minus of theta I. Minus of theta I is minus 60 degree. Then you have to add this and this you have to add. So always first you have to calculate angle of current, then minus of theta I, then you have to add both angles. So here this is nothing but 0 minus 60 degree. This is minus 60 degree. Here you can put this important point. This is important point. Many times students are wrong here. So in complex power, this angle is most important part. So here phi s is nothing but minus 60 degree. Okay, one answer I got good. Minus 60 degree. This is most important thing. So if you have calculated angle, every value easily you can calculate. So then what is the power P? So power P is nothing but this habit you should know. Okay, mod of VRMS, then mod of IRMS into cos phi, and this is cos phi s. So cos phi s you have calculated, mod of VRMS already you have calculated. So what is P? And P you are getting magnitude. P is magnitude. P, never you will write P with angle. P is always, this is fixed, P is only magnitude. So either you can write magnitude or P. So this is a definition of P. P, never you will get P with angle. This is the important point. S you will get with angle. This is the important point. S you will get as magnitude of S with angle phi S. Okay, like this. But P always you will get P. Okay, you can write only magnitude of P, and Q always you have to write magnitude of Q. Never you have to write P with angle and Q with angle. This is most important point. So now what is the P? Sir, 10 by root 2 into what is IRMS? 2 by root 2, and this is cos minus 60 degree. So what is the P here? 20 by 2. So this 2 and 2 cancel out. 10 cos 60 degree. Okay, so 10 cos 60 degree. So power P you are getting cos 60 is 1 by 2. 1 by 2. So this answer is 5 watt. Now the Q. So here this is 10 by 2. This is 5 watt. 5 watt. Okay, now the second, what is the Q? Q is nothing but VRMS into IRMS into sine of phi s into sine of phi s. Then what will be the Q? So again this value is 10 sine minus 60 degree. This is the important, because cos minus 60 is plus cos 60, no issue. But here this Q 10 sine minus 60 degree, 10 sine minus 60 degree and minus 60 degree. Minus 60 degree negative answer? Yes, negative answer. That is root 3 by 2. That is root 3 by 2. So just you will get the answer 10 into root 3 by 2, and this is negative. So 10 root 3 by 2, this is negative. Unit is volt ampere reactive. Okay, value you can calculate. Value you can calculate. Now, so P you have calculated, Q you have calculated. So mod of S is nothing but root over P square plus Q square you will get. Okay, answer you can find out. This answer is 10 volt ampere. So here if I am going to put value of P is 5, so this is 5 square, and plus this is 10 root 3 by 2 means 5 root 3. So this answer is minus 5, this answer is minus 5 root 3. Minus 5 root 3 square, so this is nothing but 5 square into 3. 3 into 5 square plus 1 into 5 4 into 5 square. So from here mod of S you are getting root over 2 square into 5 square. So you are getting 2 into 5 is equal to 10 volt ampere. Calculation you can do. Okay, just I am going with very basic way. So mod of S you have calculated. So what is complex power? Sir, S is nothing but, can I write 10 at angle? What is the angle? Angle is your, what is phi S? That is minus 60 degree. So 10 minus 60 degree, this is the S. This is a complex power S. This is a volt ampere unit. Sir, what is P? P is 5 watt. Sir, what is Q? Q is minus 5 root over 3. And the unit is this volt ampere reactive. Volt ampere reactive. Now my question, if I will ask you, if reactive power is negative, one important thing, active power cannot be negative. Here one important thing you can note down. Note down, P can't be negative. P cannot be negative. So here this power is always positive. Sir, Q can be negative? Yes. So here Q can be negative and Q can be positive. Q can be positive. Q can be negative and Q can be positive. So if I will tell you, sir, Q is negative. Q is negative. What is the meaning of Q positive and Q negative? Sir, when you will get Q negative? When you will get Q negative? When angle will be negative. You can see here cos phi will be always positive if between 0 to 90 degree. And in general you will get 0 to 90 degree. Sir, if this angle is minus, then Q is negative. This angle negative means impedance angle negative. When impedance angle negative? For capacitive circuit. So for capacitive circuit Q is negative. Can I say for capacitive circuit? And Q is positive for inductive circuit. This is again very important thing. Again this is very important thing. So for capacitive circuit your reactive power is negative, and for inductive circuit reactive power is positive. You remember this thing. Okay, so this kind of question they can ask you. This is the first category of question. This is a first category of a question. This is a first category of question. Now the second question. This is the first category of question. When examiner can provide you voltage and current. When examiner can provide you voltage and current. Okay. So if you will write here S in complex way. So what will be the S? Here I am going to write, sir, S. So S is nothing but P plus JQ. What is S is nothing but P plus JQ. So what I can write? P is nothing but 5 minus J 5 root 3. Can I write? And you can also write, sir, this is 5 1 minus J root 3. This is volt ampere. This is volt ampere. This is S. So in complex way you can also write. You can also write. So if I will write here, sir, voltage and current. If I will draw voltage and current, so here, sir, voltage will be lead or current will be lead. Here current angle is negative, voltage angle is 0 degree. So you can say, sir, if this is Vt, voltage angle is 0, so current angle was behind this. So this is It and this angle is 60 degree. This angle was 60 degree. Here voltage was, here current is lagging. Here current is lagging. So if current angle is negative degree, if here voltage angle is 0 degree, then current angle is, can I write, minus 60 degree? Can I write minus 60 degree? Can I write this is correct or wrong? This is correct or wrong? This is correct or wrong? No, this is wrong. This is correct or wrong? This is wrong. So many times student can write in this way, but this is wrong. But this is wrong. This is wrong. So many times we will get confusion here. Many times we will get confusion here, because you don't have to draw here current angle. You have to write I conjugate angle. This is the important thing. You have to write. So if you have calculated Q, and if Q is negative, and Q negative indicates circuit is capacitive, and if circuit is capacitive, then current will be lead. Current will be lead. This is the important point. So if you have calculated, sir, phi S is minus 60 degree, it means impedance angle. Impedance angle is also minus 60 degree. So what do you mean by impedance angle minus 60 degree? Impedance angle is not 60 degree, impedance angle is minus 60 degree. It means circuit is capacitive. So if circuit is capacitive, and if you are writing, sir, this is Vt, so definitely current will be lead by 60 degree. Current will be lead by 60. This will be the actual representation here. So this is very, very important thing, angle of this complex power. So many times student will be wrong here. So you have to concentrate in this point. Okay. So in this point you have to concentrate. Okay. So now if I will draw here power triangle, suppose for example, sir, this is P. P is equal to 5. Sir, what is Q? Q is here negative 5. So can I write here, sir, this is Q, and this is minus 5 root over 3. Can I write? And this will be, sir, S. This will be S. Magnitude of S from here, and this is your angle. This is your angle. Can I write this is phi S? So if Q is behind this, so QS you will get negative here. So QS will be negative here. So this is a power triangle. This is a power triangle. This is a power triangle. Okay. Now second question I am going to take. I hope this thing is clear to all of you. Now the second question. Second problem. And now very basic problem I am going to consider. I hope this thing is clear. Okay. Now, so all the phasor diagram concepts should be clear to you. Then complex power will be definitely easier for you. Okay. So this statement also remember, power will be generally not negative. Q negative means capacitive. Q positive means inductive. This will help you in GATE exam. Okay. So I am going to remove this part. And second problem, just you can note it down. Okay, just I am going to remove this second problem. Okay, after some problem I will take very good level of question. Okay, so you have to attend complete session today. Okay, after 2-3 problem I will take good, very good level of problem. Okay, so you have to completely watch, okay, this session. Okay, in 1 hour we will finish, so don't worry. Now here one more question. And now suppose if only we have resistor, okay, no issue. And if, sir, this is Vt and if this is It, and now Vt and It is given, suppose Vt and It. So one important thing should be clear, Vt and It phase should be same. Suppose Vt is a 10 sine 3140 and this is 5 sine 3140. So both will be sine or both will be cos and angle will be same. Angle will be same. So in this case always if this is resistive, So directly you can write, sir, phi s will be 0 degree. It means angle of s is equal to 0, or you can also write, sir, this is impedance angle, and or you can write, sir, this is angle of z. Can I write? Yes. So what you will get, sir, here P is equal to Vrms Irms cos phi. Can I write? Cos phi s. So Vrms is 10 by root 2 and Irms is, sir, 5 by root 2 and cos phi cos 0 is 1. So here 10 into 5, 50 by 2. This is nothing but 25 watt. What will be the Q? Directly you can write, sir, Q is 0. So this is Vrms Irms into sin phi. Sin phi s, sir, this is 0 volt ampere reactive. So for resistive load, you will not get Q. You will not get Q. So if Q is 0, resistive network, Q is positive. Q is positive, inductive network, Q is negative, capacitive network. Capacitive network. Clear this thing? So in this category of question, generally examiners are interested in average power. Okay, so what is this P? This P is average power or not? This is my question. Yes, sir, this is average power. So you can also write, sir, this is average power. Now, sir, is there any another method to calculate average power? Yes, sir. So this average power you can also calculate like this. This average power is nothing but this is 1 by T integration over one time period. Sir, this is Vt into It dt. This will help you many times. This will help you many times. If you are getting confusion, so how you can calculate across the resistor, calculate Vt and It. Then Vt and It is nothing but Pt. Okay, instantaneous power, and this average value will be average power. And if you will solve from here, you will again get same answer. Just you can try, because in many question I will use this formula. So now here this is 1 by T integration over one time period. First you can put Vt into It. So 10 into 5, 50, and can I write sin square 314 into T dt. Can I write sin square theta is 1 minus cos 2 theta by 2. So can I write what is P average? P average is nothing but in first term this is nothing but 1 upon 2 integration over one period. This is 5 by 2 dt. Can I write? In second term, sir, this is 1 upon T integration over T sin square theta is 1 minus cos 2 theta divided by 2. So this is minus, and this is cos 2 theta. Cos 2 into 3140 divided by 2 dt. So area of one period for cos, always this value will be 0, because you know very well sin and cos. This is sin. So area under the one time period or two time period or three time period, that will be 0. Similarly for cos, area under the one time period or two time period or three time period will be 0. So this value you will get 0. So from P average you are getting, if you will do this integration, this is 25 and this value you are getting 1. So this is 25 watt. This is the answer. This is the answer. So if you are getting some confusion in GATE exam, so always you have to go with a basic method. You have to go with basic method. Clear this point? Okay, now. Okay, now, now suppose for example, if you will get DC voltage and DC current. One more problem if I am going to take. Suppose for example, if I am going to take DC voltage and this is resistance, this is DC resistance. So if suppose this is 10 volt and this is 5 ohm resistance, then current will be 10 by 5, directly you can write 2 ampere. So in this case, sir, what is average power or P? So in this case, P and P average will be same. And generally you will write, sir, I square R or V square R. Always you have to use this formula. Sir, Vrms into Irms cos phi. Sir, can I use this formula? Yes, you can use this formula in any circuit. Any circuit you can use this formula. Sir, here DC voltage RMS is same. So here Vrms is 10. Vrms is 10. Not 10 by root 2. This is not sinusoidal. This is constant. Sir, what is Irms? Sir, Irms is 2. And sir, what is phi? Phi is 0 degree. So now you can put here answer. Sir, this is 10 into 2. This is 20 watt. You can also, if you will apply I square into R, again you will get 20. If you will apply V square divided by R, again you will get 20. So just I want to tell you, in any circuit you can apply this formula, Vrms Irms into cos phi. Cos phi. Either this is voltage Vt and It, time dependent AC supply or if this is DC supply. Clear this thing? Now come to the point. Now come to the point. Here you can also apply this formula. Vrms, IRMS. IRMS you can also write, sir, Vrms by R, or Vrms you can also write IRMS into R. Okay, now come to the next point. Now come to the next one. So this was the basic. Okay, this was the basic. Now I am going to start some good level up problem. Now I am going to start some very good level up problem. But before going to start that problem, just I want to tell you one table. Just I want to tell you one table. Okay, now, so just I want to tell you one table. Okay, suppose first case I am going to take, this is theta v and theta I. Theta v and theta in first case. So three cases can be possible: theta v greater than theta I, theta v less than theta I, theta v is equal to theta I. So here I am writing phi s. So what is phi s? Phi s is theta v minus theta I. Okay, now next table I am going to consider, sir, what is the power factor? Sir, can you write power factor? Yes, sir. Okay, next table I am going to assume P, Q and S. So in next table P is nothing but, sir, Vrms, this is IRMS, this is cos phi. Can I write? Yes. Okay, next two more table just I am going to write, okay, for Q and for S. For Q and S, this table will be very important and this will help you in GATE exam. Okay, now next I am writing here S, next I am writing here Q. What is Q? This is Vrms, this is IRMS and this is sin phi. And you can write this is phi s. You can write this is phi s. And now what is the next S? S is nothing but what I can write, this is Vrms into IRMS. This is magnitude and angle of phi s. This is your S. Can I write? Yes. So here three cases can be possible. Here three cases can be possible. First case, when theta v is greater than theta I. Second case, theta v is less than theta I. And third case, theta v is equal to theta I. So when voltage angle is more than current angle, theta v is greater than theta I. In this situation, what will be the phi? So theta v minus theta I. This is less, this is more. So theta, okay, first case theta v minus theta I. So in this case phi s is positive. Can I write? Yes. In this case, sir, phi s will be negative, and in this case phi s will be 0. Can I write? So here complex power angle, it will be positive, negative or 0. Can I write this? Now what will be the power factor? So if this angle is positive, means impedance angle is positive. If impedance angle is positive, then circuit behavior is inductive. If circuit behavior is inductive, then power factor is lagging. So here this is lagging power factor. If theta is negative, means impedance angle is negative. Impedance angle is negative, it means circuit behavior is capacitive. Circuit behavior is capacitive, then power factor is leading. This is very important. And here unity power factor, and here unity power factor, here unity power factor, and here unity power factor. Now the important thing, sir, what will be the P here? Vrms, IRMS will be always positive. If this phi s is positive, so P you are getting here positive. So P will be positive. Yes, sir. Now here in this case, sir, again cos minus theta, P will be again positive. And here unity power factor, so you will get P or not? Yes, P you will get. So just I am going to write, yes, P you will get, and P will be always positive. You will get and P will be positive. Now in second case, Q will be Vrms, IRMS. So here this sin phi, if this is positive, so here you are getting this is positive, you are getting here positive, and if the angle is negative, this Q is negative, So now you can relate here. If impedance angle is negative, you can also write, sir, this is impedance angle. You can also write, sir, this is impedance angle, So if impedance angle is here positive, circuit behavior is lagging. Lagging means inductive. If circuit is inductive, so quality factor is, then your Q means not quality factor. Okay, Q is a reactive power. Reactive power will be positive. And if circuit is capacitive, reactive power will be negative. And in this case, will you get Q or not? No. Here Q is equal to 0. So here Q you will not get because phi is a 0. This is the important thing. It means circuit is resistive. It means circuit is resistive. So here can I say unity power factor means circuit is resistive. Here circuit is resistive. Here circuit is leading means capacitive. Here circuit is lagging means inductive. This table will be very, very important. Very, very important. Here you can also say, here just I can write S V RMS I RMS you don't know. If I will write angle up S, so from here you can write this circuit is inductive, this is capacitive, and here circuit is resistive. Circuit is resistive, okay, and inductive means your angle up S. Can I write phi S is here positive, and here capacitive means this phi S is negative, and here resistive means phi S is 0. Clear? So this table should be, I hope this is definitely remembered to you. Now one more important thing I want to discuss here. Okay, this is the last theory point here. So now if I am going to assume this is for if you know angle supply. So two category of question can be framed if examiner will provide you this angle. Now the second category of question, if examiner will provide you load. So two category of question can be framed. In first category, examiner will provide you current and voltage. In second category of question, examiner will provide you impedance. So load, examiner will provide you load. So if examiner will provide you load, so one more table just I am going to write. If this is a load, and here, sir, what is the phi S? Phi S you can also say this impedance angle. Both the things are same. Then sir, what is P? What is Q? And what is here power factor? What is here power factor? Then what can be the load? Sir, load can be purely resistive. Sir, load can be purely imaginary. I am writing it can be inductive or it can be capacitive. Sir, pure load can be resistive plus reactive. So resistive plus inductance or resistive plus capacitance. Anything can be possible. Only these three cases can, 3 means 5 cases can be possible. Purely resistive, purely inductive, purely capacitive, resistive plus inductive, and resistive plus capacitive. So 5 cases can be possible here. 5 cases can be possible here. 5 cases can be possible here. So if R is a load, so what is a complex power angle or impedance angle? Definitely 0 degree. Definitely 0 degree. Now if reactive, so if this is a plus means inductive, minus means capacitive. So if circuit is inductive, so generally what student will think phi S. Always you remember phi Z. So if you think complex power angle and impedance angle is same, so things will be easier to you. Sir, inductive load, purely inductive means impedance angle is plus 90 degree. So for this plus, for this minus, this is 90 degree. So for pure inductive load, complex power angle is plus 90 degree. For pure capacitive load, complex power angle is minus 90 degree. Minus 90 degree. Now if this is the load R plus Jx or R minus Jx, so impedance angle, so here impedance angle can be between 0 degree to 90 degree. In between 0 degree to 90 degree, and what will be the 0 degree to plus minus 90 degree. If this is a R plus Jx, so it can be any value between 0 to 90 degree, or if this is R minus Jx, it will be between 0 to minus 90 degree. Are you getting? So always you have to calculate impedance angle, and impedance angle is nothing but complex power angle. This will always help you. This will always help you. Then sir, what is P? So in this case, P you will get, yes sir, P we will get, and P is positive. So here P you will get, yes, and P will is always positive. P you will get, and P is always positive. If load is resistive, then Q, no, Q is absent, Q is 0. Q you are getting 0, neither positive nor negative, Q will be absent. What will be the power factor? Sir, unity power factor. In this case, power factor will be unity power factor. Now, in this case, what is the P? What is the P? Sir, here, if your angle is either plus 90 degree or minus 90 degree, you will get P 0. So, in this case, P is not present, P is 0. So, for pure reactive load, P is 0. This thing you should remember. And now, sir, will you get Q? Yes. So Q will be positive or not? Here Q you will get. And for inductive load, for plus 90 degree your q will be positive, and for negative this will be negative. So here answer can be positive or negative both. So for inductive your q will be positive, for capacitive q will be negative. You should remember this. Then sir, what will be the power factor? If pure reactive, it means cos phi. Phi is 90 degree, cos 90 degree is 0. So in this case power factor is 0. This is very important. So here power factor is 1 and here power factor is 0. This is not 0 degree. This is power factor value is 0. This is 0 power factor. So what I can say, this is 0 power factor. Now come to this point. Generally you will get question from this part. Generally you will get question from this part. So here will you get P? Yes sir, here P you will get. Sir, here you will get Q. Yes, here Q you will get. So P will be positive. Yes sir, P will be always positive. P will be always positive. Sir, what about Q? Q can be positive or Q can be negative both. So here Q can be positive or Q can be negative both. And Q will not be 0 and P will not be 0. Both will be present. Sir, what will be the power factor? So here power factor will be between 0 to 1. So power factor will be between 0 to 1. So I hope now you can relate this thing. I hope this you can relate. This will help you in GATE exams. So once you can write this table and once you can revise this table. Clear? Now I am going to start problems from this complex power. Okay. Now I am going to start a problem from this complex power. Clear this thing? Okay. Now. Okay. So one more example I am going to take. Okay. Now suppose for example, clear this point? So first example we have considered from when supply voltage and current is given. One more example I am going to consider when load is given. When load is given. So everybody just note down this thing, relate each and everything, at least some point you should remember. Okay. Now I am going to take next example. Okay, this you have to write, this table you have to write. Okay, this will help you. This will help you for your revision and in GATE exam. Okay, so now next problem I am going to take. Okay, so we will discuss 5-6 problem from this complex power and then we will finish our syllabus. So now I am going to first take one basic problem. Okay, so just note down. Suppose one load is given. Suppose in this case one load is given. Suppose one load is given ZL and ZL is a complex load. Now the value is phi at angle. The value is given 36.86 degree. This is 36.86 degree. Okay. Okay. Now, and here this is VRMS. And here current will be IRMS. Okay, VRMS and IRMS. Okay, now here VRMS is also given 10 at angle 0. This is 10 at angle 0 degree. 10 at angle 0 degree. Okay, this thing is given. You have to calculate all the value. So here ZL is given. So if you want to write this ZL, sir, ZL is a 5 at angle 36.86 degree. Can you write this ZL in real part and imaginary part? Just I am going to write this is a cos 36.86. So can I write this 5? This is cos 36.86 plus j sin 36.86. Okay, possible you can remember this value. This value is 0.8 and 0.6. This value is 5. This is 0.8 plus j 0.6. Okay, so what you are getting? What is ZL? So ZL we are getting 8 into 5. This is 4 plus j. This is 4 plus j3. So this is nothing but 4 plus j3. So ZL just I have written in terms of real and imaginary. So here I am going to write ZL is nothing but 4 plus j3. So here this is load resistance RL and this is XL. Can I say? So this is real part of load and this is a imaginary part of load. So how we can write directly here power? So here what is a PL? So what is P? P directly we can write if you know I square into RL. So if you can divide ZL into real part and imaginary part. Suppose if you can divide this ZL into real part and imaginary part. So you can find out this real part and this is the imaginary part. This is the imaginary part. And this is the imaginary part. Okay. Now So if I will ask you, sir, what is the angle here? Angle of Z. So what is sir phi S, or you can say what is sir phi Z? Already given 36.86 degree. This is 36.86 degree. 36.86 degree. So if you want to calculate here power factor, so if you will calculate here power factor, this is load power factor. This is load. So if I will ask you, sir, what is load power factor? What is load power factor? So load power factor you can write cos phi Z, angle of impedance, load impedance. Load impedance is nothing but this is cos 36.86, and cos 36.86 you know this is 0.8. This is load power factor. So just if I will ask you here, load power factor and supply power factor will be same or not? If in between load and supply none of the extra elements are connected, then load power factor and supply power factor will be same. Now if I will ask you, so this power factor is lagging or leading, so this is plus means inductive load, so you can write here this is lagging power factor. Many things you can calculate. So right now just we have described this load, now we have to calculate here first IRMS. So VRMS is already given. Sir, what is IRMS? So IRMS can I write? Sir, IRMS is nothing but VRMS divided by Z. So IRMS with angle can you write? Yes, we can also write. If you want to write VRMS with angle, sir, this is tan at angle 0 degree divided by what is Z? This is phi at angle 36.86 degree. So from here, what is IRMS? So IRMS you are reading 10 by 5, this is 2 at angle minus of 36.86 degree. This is your IRMS, and what is magnitude of IRMS is 2 ampere. Magnitude of IRMS is 2 ampere. Okay, so if you will draw this VRMS and IRMS, so this is VRMS. VRMS is 0 degree. Sir, this is tan at angle 0 degree. What is IRMS? So if IRMS is minus 36.86 degree, important point. So if I will ask you which is leading, so if voltage angle is 0 and current angle is minus 36.86 degree, current angle is minus 36. So always you have to concentrate on this VRMS. And sir, what is this IRMS? This is IRMS already given. This is 2 at angle minus of 36.86. So this angle is nothing but 36.86 degree. Clear? IRMS will be definitely behind because the circuit is inductive. Okay, so just we have written this. Now come to the point. Here we have to calculate active power, reactive power and total power. Here we have to calculate active power, reactive power and total power. So if somebody will ask you, sir, what is supply power factor? Suppose if examiner are interested in here, sir, what is supply power factor? Already I tell you, two power factor can be asked by the examiner. One is load power factor, one is supply power factor. So if examiner will ask you load power factor, so just you have to find out load angle. If examiner are interested in supply power factor, then you can find out angle between voltage and current. So you have to find out cos supply power factor. This is phi s. So this is nothing but cos phi s. This is cos phi s. And if in between load and supply there are no any another element, then both will be same. So what will be the supply power factor? You can say here voltage is current is behind. It means here phi s, or you can write here, sir, what is the angle of IRMS? Sorry, what is the angle of IRMS conjugate? IRMS conjugate is nothing but 2 at angle 36.86 degree. And this IRMS angle is theta I. IRMS, this conjugate angle, this is the theta I. So here this angle is 36.86 degree. This is 36.86 degree. Okay, so now cos phi s, what I can write? Cos power factor, this is a cos 36.86 degree. And what will be this value? 0.8. Now the important thing is lagging or leading. Already you have drawn VRMS and IRMS. So this is nothing but lagging. This is nothing but lagging. Clear this thing? Now, so sometime examiner can ask you load power factor. sometime examiner can ask you supply power factor. So if examiner will ask you supply power factor, you have to calculate impedance here. If examiner are interested in load power factor, you have to calculate impedance here, either impedance or voltage and current, Okay, so now the next point is here. Sir, what is here S, what is here P, what is here Q? So S can I write complex power? Complex power can I write, sir, VRMS into IRMS conjugate. Can I write? Yes. VRMS already given, that is 10 at angle 0. 10 at angle 0. Sir, what is IRMS conjugate? Here this is nothing but 2 at angle 36.86 degree. And from here you can also write, sir, this is 20 at angle 36.86 degree. 36.86 degree. 36.86 degree. So now if I will ask you, sir, what is here phi s? Plus 36.86 or minus 36, plus 36.86. This angle is. So if you will calculate IRMS, okay, so this is nothing but theta. So minus of theta I is 36.86. Okay, and here theta V is given 0 degree. So either you can add this two, otherwise IRMS you can find out. Okay, and here you can put, and this angle is your angle of your supply, or you can say this is the angle of complex power. So this is a positive angle. This is the important point. So here phi s you are getting positive 36.86. So if phi s is positive, means the power factor is lagging, circuit behavior is inductive. So here as you have find it out. So what is mod of s? Mod of s is nothing but, sir, 20 volt ampere. 20 volt ampere. Sir, what is angle of s? Angle of s is nothing but phi of s. This is nothing but 36.86. And what is the circuit behavior? Circuit behavior is inductive. Circuit behavior is inductive. Why circuit behavior is inductive? Because this angle is a positive. This angle is a positive. Now, if I will, we have to find out here power P and Q. Suppose if we have to find out here power P and Q. So how you can find out? So either you can divide this S into two parts. So just you can write what is the S is here. S is here 20 at angle 36.86. So what is S? 20 cos 36.86 plus J sin 36.86. So what is the rectangular form? This is cos 36.86 is 0.8. So this is 0.8. This is plus J 0.6. So from here you will get 20 into 8. This is 16 plus J. This is the 12. So what will be the P here? This is 16 watt. And what is the Q here? This is 12 volt ampere reactive. If you want to draw here power triangle, so this is P. P is equal to 16. Now the important thing is, sir, where we have to draw Q? Down or up. So this is the important point. So if you have find it out circuit is inductive, directly you can write, so this will be the Q, this will be the Q, and Q is here 12. So this will be your mod of S, and this is your angle, this is phi s, and here phi s is positive, phi s is positive, phi s is positive. This is a impedance angle. This is the first method. Okay, now I will tell you some easier method. How you can handle this category of question in GATE exam. Okay, so just this is your basic method. Now I am removing this part. Okay, Suppose for example, if impedance is given in GATE exam, then how you can calculate? So another method is how you can calculate. Sir, P is nothing but directly I can calculate VRMS into IRMS into cos phi s. Yes, VRMS already given, sir, this is 10. IRMS already you have calculated. IRMS is nothing but magnitude of IRMS. So 10 upon 5. 10 upon 5 is 2. So this is magnitude of IRMS, this is magnitude. So this magnitude is 10, magnitude is 2. What is cos phi s? Sir, cos 36.86. And this phi s is positive 36.86. So what you will get? Sir, 10 into 220 into 0.8. This is 16 watt. So directly you can get a answer. Now the second, sir, what is Q? Q is nothing but VRMS. This is magnitude into IRMS, magnitude into sin phi s. So directly you can write, sir, this is 10 into 2 into what is sine 36.86? 0.6, sir. So you will get 20 into 0.6, sir. This is 12 volt ampere reactive. Directly you can find. Then what is the S here? So S you can write, sir, root over P square plus Q square. So from here you will get 20 volt ampere. So if you want to write S complete, so this is 20 at angle phi S, and this phi S is angle 36.86. This is the answer. So within 1 minute you can handle any question in GATE exam. Now one more method I want to tell you here. Suppose for example, if you have calculated here IRMS. So if you have calculated rectangular form, if a rectangular form of Z is given, then sir what is P? So P I can write, sir, IRMS square, this is magnitude of IRMS square into real part of load. Real part of load, directly P. Sir, what is Q? Sir, IRMS ka square magnitude this into XL reactive power. So directly P and Q, this is the next formula. If you know, if you can separate the impedance in terms of real part and imaginary part, so directly you can put the value. So what is IRMS? IRMS magnitude is required. So this is 10 by 5, I is a 2. So the current magnitude is 2. So this is 2 square. And what is the RL? This is 4. So this is 4 into 4, 16 watt. Sir, what is this here? 2 square. And what is XL? XL is 3. So this is nothing but 4 into 3. This is 12 volt ampere reactive. Sir, what is the S here? Root over P square plus Q square. And this is nothing but 20 volt ampere. Sir, what is complex power? S is nothing but 20 at angle 36.86 degree. Because if Q is positive or negative, this is also important. So here Q will be positive. Because here you will get a, from here you can also say XL is positive or negative. So if Q is positive, it means the circuit behavior is inductive. So directly you can write. So within 1 minute you can handle this category of question. Okay, so don't go with S. Directly you can either write this, but I recommended you can go with this one. You can go with this one. Okay, so in 1 minute you can handle this category of question. Now next good question I am going to take. Okay, so now next question I am going to take. Just note down. Next question I am going to take. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Okay, so just confirm me. So just confirm me once. This thing is clear to all of you or not? Okay, so this formula you can apply. This formula you can apply. But for this impedance real part and imaginary part is required. So if impedance real part is given, imaginary part is given, you can go with this. If impedance is given in polar form and you don't want to go with rectangular form of this load, so what you can find out? Angle you can find out, and if you know the angle, so directly VRMS IRMS cos phi s, VRMS IRMS sin phi s, and if you can calculate P and Q, S you can write, S you can write. An angle of S is very important. Clear this? So this was a very basic problem. Now come to the point. Now the next problem. Okay, so generally what we target, directly we don't calculate. So what you have to do in GATE exam, don't target S directly. So don't target S directly, no. Always target to P, then always target to Q, then you will calculate S. This should be protocol. So first target P, target Q, and then calculate S. Don't target directly S. Okay, so most of the time your answer will be correct. Okay, just note down one problem. Just note down one problem. Okay, now, so now you have to give me the answer for each and every question. Suppose here the voltage across a circuit in the figure, one circuit is given, and this is electric circuit. This is electric circuit. This is electric circuit. So one electric circuit is given here. Okay, now voltage is given here, VT and IT. This voltage is VIT, and this is current. I can write IT. Just you can write this voltage VT and current IT. And VT and IT is given. VT is given here. VT is given and IT is given. So voltage and current is given across this circuit. Voltage is given 5 minus 10 cos. 5 minus 10 cos omega t plus 60 degree. Omega t plus 60 degree. And what is the IT? it is given here, that is 5 plus x cos omega t. Okay, so here DC plus AC signal, here DC plus AC you are getting. So you are getting DC plus AC voltage and you are getting DC plus AC current. Okay, now omega is given 100 pi radian per second. So here omega is given 100 pi radian per second. So this omega is given, and now they are saying if the average power delivered to the load is 0, and now they are saying average power P average across the load is 0. So average power delivered through the load is 0. Okay, then the value of x, then this unknown quantity x you have to calculate. X is equal to question. So this x you have to calculate here. This x you have to calculate here. Okay, so one important thing, if this AC supply is given and this is cos, this is cos, this is 60 degree, this is 0 degree, it means load cannot be resistive here. Load cannot be resistive here. Load cannot be resistive here. Sir, without you have thought in global for digital, 9 session is sufficient. Yeah, that session is sufficient. Okay, most of the topic I have covered. Most of the topic I have covered. Anybody can solve this question. Anybody can solve this question. Anybody can solve this question. Okay, this is very simple problem. This is very simple problem. This is very simple problem. Okay, how you can handle this category of question? How you can handle this category of question? So if you can see here, sir, if you can see here, how we can solve this problem? So P average, if you want to find out, already I tell you what is the formula for P average. First you can calculate PT. So this is nothing but 1 by T integration over one time period Vt into It into dt. Can we write this? So one derivation I am telling you, if examiner will ask you this category of question, so in GATE exam what you have to do? So first I am writing here one derivation and then final answer I will tell you, and you have to remember that final derivation. So if suppose if you will solve this, so Vt into It, if I will put here, so this is nothing but sir 1 by T integration over one time period. Here you can say 5 minus 10, this is cos omega t plus 60 degree. Okay, this is the first value, and now the second value is multiply. Sir, this is nothing but 5 plus x cos omega t. This is second value into dt. Can I write? Yes, we can write. So what is a P average here? What is the P average here? If you will multiply the bracket, 4 term you will get. So 4 term you will get. So this is 1 by T integration over one time period 5 into 5. So can I write 5 into 5 first term? Second term, can I write 5 into x cos omega t? This is second term. Third term, 5 into this, so minus 5 into 10 cos omega t plus 60 degree. This is third term, and last term is this two multiplication. So this is minus of 10 into x cos omega t into cos omega t plus 60 degree. You will get this term. So fourth term you are getting. Fourth term you are getting into dt. Okay, now we have to separate all the four terms. So now you can see here, sir, what is the P average? So first term 1 by T integration over one time. This is a DC value. So just I am writing 5 into 5 dt. So integration of this area is T, and if you will put limit 0 to T and T cancel out, you will get 25. Now the second value, sir, 1 by T integration over one time period. So this is 5x cos omega t. So area under the cos is 0. Yes, sir, 0. Now the third term, again I am writing plus 1 by T integration over one time period. This value is minus 5 into 10 cos omega t plus 60 degree, and this is dt. This is third term. Again this is cos, and cos area will be 0. Either cos shifted form. If you will shift the cos, area will be same. Yes. And now the last term, sir, plus 1 by T integration over one time period, and this value is minus of 10 into, this is cos omega t into cos omega t plus 60 degree, and this is dt. So fourth term you will get. Fourth term you are getting. Yes, sir. Here this term is 0. This area is 0. Yes, sir. This area is 0. So only two terms you are getting. Only two terms you are getting. Now again, we will derive the equation. I hope this thing is clear. I hope this thing is clear to all of you. I hope this thing is clear to all of you. Now I am going to remove this part. Now I am going to remove this part. Sir, what is the meaning of this term? Sir, here this term is nothing but this is 5 into 5. So P average. So P average we are getting from here. This is nothing but 5 into 5. This is nothing but 5 into 5. Okay. And area under this is T, and T will be cancelled out. Now, if you will solve this, you can apply 2 cos A cos B. You can apply 2 cos A cos B. Here can we apply 2 cos A cos B? So cos A plus B cos A minus B. So this term you will get sir plus 1 upon T integration over 1 time period. Okay. So here minus of 10. This is minus of 10 divided by 2, because 2 cos A cos B you have to apply, and you will get cos A plus B plus cos A minus B. Here cos A plus B. So this plus this. So 2 omega T. This is cos 2 omega T plus 60 degree. This is first term. And now the second term is plus cos. You can consider this A minus B, and cos minus theta is cos theta. Or if you consider A minus B, no worry. So A minus B, omega T minus omega T 0, minus 60 degree, cos minus 60 is cos plus degree. Second term is cos 60 degree. And this is nothing but dt. And if you will open both the parts, so from here what you will get? So sir, P average we are getting, this is 5 into 5 plus here two terms you are getting. So first term we are getting, this is sir plus 1 by T integration over 1 time period. This is minus of 5 into cos 2 omega T plus 60 degree. Okay. I think there are, okay, once just wait, here this x, here this was x. So 5 into 5 is 25. Sir, this 5 into x, yes sir, this 5 into 10. Here we did some mistakes. Sir, 10 into x cos into cos, 10 into x. So here we skip the x. So here this is nothing but minus of 10x. This is minus of 10x. Okay. So you have to correct here. Sir, here this is minus 10x. Okay. So here we are getting minus 5 into x, minus 5 into x, because this 2 multiplication is minus 10 into x. Okay. Now correct this. Now the second term is here. Sir, 1 upon T integration over 1 time period. This is minus of 5x, minus of 5 into x into cos 60 degree, and this is gt. Can I write? Now again you can see this is a cos, and area of this cos is again 0. Again 0. So what you are getting the answer here? Sir, P average we are getting, this is 5 into 5. This is 5 into 5. And here you are getting, sir, this is here you are getting cos 60 degree is constant and minus 5 is constant. And this 1 by T, this area will be cancelled out. 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 So what you are getting here? We are getting here, sir, this is plus. This is minus 5 into x. This minus 5 into x. Or you can write, can I write this is, sir, minus of 10. Minus of 10 into x divided by 2. Can I write in this way? Yes. Here this is divided by 2. This is divided. Can I write minus 10x by 2? Yes. Into cos 60 degree. Cos 60 degree. This is the answer. Okay. This is the answer. Not final value, but this is the derivation answer. This is the derivation answer. So now in GATE exam, directly you can write this. How you can write, I will tell you. I hope this thing is clear to you. Now, so now don't remember this process. In GATE exam, directly you can write. How you can write this in GATE exam? So you can see here, sir, here this frequency is 0, this is DC, this is DC. Sir, here this frequency is omega and this frequency is omega. And in between these two phase difference is 60 degree. Phase difference is 60. It can be minus 60 or plus 60, cot minus or cos plus will be same answer. So this answer directly you can write. So sir, what is a P average? So what is the P average? This DC value, this DC value. So DC value of voltage is V0. DC value of current is I0. Can I write? At omega 0, at omega 0. So V0 into I0. Now this is sinusoidal. This is sinusoidal. So you can write, sir, plus VRMS. We can write VRMS for this, and for this IRMS. For this IRMS into cos phi. This is the derivation. This is the derivation. Are you getting my point? So if you will get a DC DC AC AC with same frequency, so this DC V0 into I0 plus here V RMS I RMS and cos phi, cos phi. So V0 is here 5, I0 is 5. So you can see here, sir, P average is V0 is 5, I0 is 5, and this is plus. What is V RMS? Minus 10 by root 2. So this is minus of 10 divided by root 2 into, sir, what is here? X by root 2, x by root 2. And what is the angle? 60 degree. This is cos 60 degree. So root 2 will multiply 2. Here you will get to same answer you are getting. So what is the P average? So P average we are getting here, so 25 plus, sorry, this is minus 25 minus, this is 10 x by 2 cos 60 degree. Cos 60 degree. Cos 60 degree is 1 by 2. Cos 60 is 1 by 2. You can put, and P average is given 0, you will get an answer. So what is the answer? Sir, P average is 0. Sir, this is 25 minus 10 by 2, that is 5. So 5x and cos 60 is 1 by 2. So from here you will get, sir, 5x by 2 is equal to 25. So 25 into 2, 50 by 5. So x you are getting 10. X is nothing but 10. So x you are getting here 10. Okay, x we are getting 10. So if you want to save your time, you can remember this derivation. You can remember this derivation for this category of question. I hope this thing is clear. So if you will get in voltage DC plus AC, and if you will get in current DC plus AC, so what you have to do? This DC voltage, this DC current V0 I0, here this DC voltage VRMS, here this DC current IRMS, and angle between these two, angle between these two. But this answer will be valid only for this situation: 1 DC 1 AC, 1 DC 1 AC. Clear this problem? Any value can be 0. If this value is 0, so this value will be 0. If this value is 0, so this value will be 0. Clear this point? Now the next category of question. Now the next category of question. Now the next category of question. So please comment. Please everybody comment. This thing is clear or not? This thing is clear or not? Now I am going to take one good problem. Now I am going to take one good problem. Okay, now I am going to take one good problem. Can you handle this? Can you handle this category of problem? Okay, so you will, when you will comment me, then I will proceed. Just tell me. This derivation is clear to you. If you will stuck in GATE exam, just you can go with standard process. Okay, now the next problem. Now the next problem. Okay, just note down the next problem. In the next problem, the voltage and current across a load is given. Okay, now in the next problem, we have one load. We don't know what is the load. We have one load, and here voltage and current across this load is given. Here this voltage is Vt. Here this voltage is Vt, and here this current is It across this load. So Vt and It is given. So Vt is given here. Note down, Vt is given here 100 sin omega t. This is 100 sin omega t. And here It is also given. It is also given. This is a 10 sin omega t minus 60. 10 sin omega t minus of 60 degree. This is the first term. Here two more term is given, plus 2 sin, this is 3 omega t, plus 2 sin, this is 3 omega t, and plus 5 sin 5 omega t, plus 5 sin 5 omega t. Okay, so this kind of question generally examiner will ask you. So when one voltage, one frequency in voltage, but 3 frequency in current. So what do you mean by this? So you can expect, sir, current can be a square wave signal. Okay, so if this is a square wave, you will get infinite harmonics. And suppose some harmonics you have neglected, then you will get 3 harmonics. So exactly this is not a actually this is a one signal, but 3 harmonics you are getting. Here omega, here 3 omega, and here 5 omega. So practically this is harmonics, and here this is omega. So this kind of question sometime you will get. In voltage you will get one frequency, but in current you will get many number of frequencies. In previous question what you have considered, two source exactly we have applied, one DC and one AC. But in the question one frequency in voltage but three frequency in current. This kind of question sometime examiner can ask you. This kind of question sometime examiner can ask you. And now here the question is the average power consumed by the load is. So what we have to calculate here, P average across the load. P average across the load. Across the load is equal to question mark. In what? In what? Okay. So P average you have to calculate. So what is the P? So P easily we can write, yes sir, P anywhere VRMS IRMS into cos phi. Cos phi is nothing but power factor. Yes sir. What is VRMS? Yes, here VRMS easily we can write. What is VRMS? 100 by root 2. Okay. Sir, what is the IRMS? This is the important point. We have already studied how you can calculate if this all the frequency different. So IRMS formula we know very well. This is nothing but root over IRMS 1 square plus IRMS 2 square. This is IRMS second square plus IRMS third square. We know this formula. Yes, if all these three frequency are different. So from here IRMS we can calculate. So IRMS is nothing but root over, this is 10 square, sorry 10 by root 2 square plus what is the second value? 1. You remember if this is a shifted it will not be a factor. Only frequency should be different for all the term. This is the important point. So 10 by root 2 whole square, this is 2 by root 2 whole square, and now the third value is 5 by root 2 whole square. Clear this thing? So from here you can solve this. Directly I am going to write the answer. IRMS here we are getting root over 129 by 2. So root over 129 by 2. So you will get 64.5, root over 64.5, root over 64.5, root over 64.5. So VRMS and IRMS you have calculated. Now two parameter is unknown here. This is unknown and this is unknown. So now the important thing is here. If you will get this kind of question in GATE exam, then load and power factor. So two question I am asking. So generally what a student will do here, first they are trying to calculate cos phi. No, always in GATE exam VRMS easily you can calculate if a one number of voltage or many number of voltage is given. So VRMS can be calculated. Yes. How you can calculate IRMS? If one current or many number of harmonics is given, IRMS. So this VRMS and IRMS anywhere we can calculate. Now here you have to calculate power first. Now you have to calculate here power first. Then how we can calculate power here? So here what is the P? So how you can calculate power? So direct derivation formula I am going to write. Again here same you can apply. Sir, what is P? So P average, how you can calculate? Sir, 1 by T integration over one time period Vt into It dt. Can I write? Yes, you can write. Now if you will multiply this to this, this to this, this to this. So if you will multiply this to this, so here you will get sin omega t term. 2 sin A sin B formula you can apply. If this and this multiply, both omega is different. So you will get one time omega plus 3 omega and 3 omega minus omega. So in both the case when this multiply with this, 2 sine term you will get. And if you will get 2 sine term, area under the sine is 0. And when this is multiply with here, so this is omega, this is 5 omega. So one time omega, 5 omega minus omega, 5 omega plus omega. So one time you will get 4 omega, one time 6 omega, and area under the sine is 0. It means when these two are only multiplying here, you will get the sum term. In the remaining term, all the remaining term will be 0. I hope you are getting this thing. So this is multiply with this is multiply with this, area will be 0, average value will be 0. Now when these two are multiplied, here you will get 2 term. So 2 sin A sin B formula you can apply. So 2 sin A sin B formula you can apply. Sin A plus B minus sin A minus B. So when sin A plus B, so this omega t plus omega t, 2 omega t, area under the curve will be 0. and then sine A minus B. So this minus this, you will get here 60 degree. You will get difference is 60 degree. You will get here only this term. So what you are getting here, can I write directly? Yes. So if you will get this kind of situation, so only this first term you have to consider. This is nothing but V1 RMS. I can write V1 RMS or V RMS 1, and this you can write from here I1 RMS. So what will be the formula? Sir, V RMS for the first harmonics into I RMS for the first harmonics into cos phi, and this is nothing but cos phi 1. Phi 1 means angle between this and this. Now the important thing, if this is sine and this is cos, sometime if this is sine, this is cos, so you have to concentrate what is the angle difference. So if one signal given sine, second signal given cos, so always first both the signals should be either in sine or both the signals should be in cos. This is very important thing. So what is here V RMS 1? So V1 RMS or V RMS 1. So V RMS 1 is 100 by root 2. This is 100 by root 2. And what is I RMS 1? This is a 10 by root 2. So this is 10 by root 2. And what is this angle? Angle can be negative or positive. Cos phi will always give you positive value. So what is the difference between these two? This is 0 degree, this is 60 degree. So this is cos 60 degree. So what will be the answer? 100 into 10, this is 1000. 1000 by 2 into cos 60, this is 1 by 2. So you will get 1000 by 2, 500 by 2, this is 250 watt. This is the answer. So direct, if you know this derivation directly, so directly P you can find out. So you don't have to calculate this value. You don't have to calculate this value. You don't have to calculate this value. Direct answer you can write. But if examiner will ask you power factor, so always in GATE exam, what you have to do? First you have to calculate P average, and then you have to calculate VRMS of whole circuit, and then IRMS of whole circuit. These three values known, then you can calculate here cos phi. So what is the cos phi here? What is power factor? Power factor or cos phi is nothing but this is P average, or I can write P divided by VRMS, and this is magnitude divided by IRMS. Always you have to apply, and magnitude of VRMS is nothing but S. So this is nothing but P by S. So P you have calculated, S you can calculate, and P by S is the power factor. So power factor is nothing but cos phi is nothing but VRMS is 100 by root 2. 100 by root 2 into this you can also write, sir, root over 129 by root over 2. Can I write divide by S? Sorry, this is S, this is S. So P divided by this. So I can write here, sir, power factor is equal to cos phi is equal to P is nothing but 250. So this is 250 divided by this value. Okay, and you can find out the power factor. So power factor here we are getting 0.44. So this answer we are getting 0.44. This answer we are getting 0.44. Calculation you can check. Calculation you can check. Okay, so this kind of question examiner can ask you. This kind of question examiner can ask you. Okay, this kind of question examiner can ask you. So I hope this thing is clear to all of you. Okay, one more question I am going to take. One more question. Okay, one more question. So please first confirm me this problem is clear to you or not. So in GATE exam you have to save your time. So if examiner are interested in P average, directly you remember this concept. So which omega is same, frequency is same. So this V1 RMS or V RMS 1, I1 RMS 1, and you have to calculate, you have to find out here cos phi. Don't say this is a circuit power factor. No. What is the circuit power factor here, or supply power factor, or input power factor, or load power factor? Everything is same here. That is 0.44. That is 0.44. That is 0.44. Now the next problem. And this problem you have to give me the answer. Please everybody comment. Please everyone comment, and this answer you have to give me. Okay, and this answer you have to give me. Okay, note down the next problem. Note down the next problem. Okay, everyone ready for the next problem? Yes. So now here the input to a given any circuit is given. Okay, now V is given, so voltage is given. Okay, input voltage is given, so voltage is given for a circuit that is 100 root 2, 100 root 2, and this is sine. So here calculation will be easier because in IRMS or VRMS root 2 will be cancelled out, and frequency is 100 pi t, and this is volt. Single frequency voltage is given, and here the current is given, so here three component is given. First component is a 10 root 2, first component is a 10 root 2 sine 100 pi t, 100 pi t minus of, here angle is given pi by 3. This angle is very important. This is the first term. Now the second term is also given, second term is plus 5 root 2, 5 root 2 sine, here this is given 300 pi t, here this is given 300 pi t plus pi by 4, plus pi by 4. One more term is given, and that term is 2 root 2 sine, and here this is 500 pi t, 500 pi t, and angle is also given, yes, minus pi by 6, So same category of question, one voltage, one frequency in voltage, and three frequency in your current. The active power drawn by the converter is, so this is a voltage and current across a converter. So here this is a one converter, here this is a converter, and voltage across this converter is VI, and current across this converter is II. So now examiner are asking the active power drawn by the converter is active power. So now they are asking active power drawn by converter is. So no worry, you have to calculate power. P you have to calculate. Yes. Second, they have also asked the input power factor of the converter is input power factor of the converter is. Same question of the converter is. So here input power factor, you can write this is you can write here, or you can calculate angle, or directly you can calculate input power factor, or you can say supply power factor. So you can write supply power factor, you can write sir this is input power factor, or you can also write sir power factor. Okay, same question. So first you will calculate here sir VRMS. So VRMS is 100. Sir, what is IRMS? So IRMS is nothing but root over 10 by root 2 upon root 2 square, that is 10 square. Second value is 5 root 2 by root 2 whole square, that is the can I write directly, this is 100, this is 25, and third value is 2 square, that is 4. So root over 129, same value you are getting from the previous one, IRMS. Okay, now then VRMS, IRMS here calculate. Sir, what is a P? P either you can say P or you can say P average, both are same. So this is nothing but can I write sir VRMS for 1 into IRMS for 1 into cos phi 1. So this formula you remember, because here you can see here omega is 100 and here omega is 100. This you cannot use and this you cannot use. So here this is 100 root 2 by root 2. So what VRMS 1, this is 100. Sir, what is IRMS? 10 root 2 by root 2, this is 10 into what is cos phi? What is the angle difference between pi by 3? 180 by 3, this is 60 degrees, sir, this is cos 60 degrees. So what answer you are getting? 1000 into 1 by 2. 1000 into 1 by 2 is equal to 500 watt. The answer is P average, you are getting 500 watt. Okay, then what is a power factor of the circuit? So power factor of the circuit we know very well. P average or P is nothing but a VRMS IRMS. Complete circuit VRMS IRMS into cos phi, and cos phi is the power factor. So power factor, or you can say cos phi, is nothing but you can write P divided by VRMS into IRMS. VRMS into IRMS. Okay, so you have calculated P, that is 500. This value is nothing but 500. What is VRMS? VRMS is 100. So this is nothing but 5 into root over 129. Again, this answer is same. So same question is repeated In GATE exam 2 times same question is repeated, and now this answer is 0.44. This answer is 0.4. This answer is 0.44. So this kind of question sometime they can ask you in GATE exam. Okay, so this kind of question they can ask you in GATE exam. Okay, so I hope now you can handle the question. I hope now you can handle the question. Okay, just confirm me. Can you handle this question? Okay, now one more question I am going to consider. Okay, one more question. This is the last question. Okay, so I hope examiner can ask you two category of question. In first category, they can provide you voltage and current. So voltage can be one harmonics, current can be many harmonics. Voltage can be DC AC, current can be DC and AC. Voltage can be single harmonics, current can be single harmonics. So three category of question can be framed. Only you should remember here, don't calculate power factor first. This is the important point. First you have to calculate P average, and this formula you can directly apply, and VRMS, IRMS you can calculate, then you can calculate power factor. Only this protocol you have to remember here. Only this protocol you have to remember here. Okay, this is very, very important question, because this question is repeated two time in GATE 2011 and GATE 2016. Same category of question is repeated. So again, my prediction, in complex power, if examiner are interested, they will ask the question from VT and IT, because if impedance will be provided, that problem will be easier. So now one question I am going to consider for impedance. So this is the last question. So now this is the last question, and you have to try first. And this question you have to try first, and you have to give me the answer. Okay, so this is the last question from our this network session. Okay, so 5 session I have conducted, and each and every topic I have here considered. Okay, so this is a, you can say, one kind of advanced revision course. This is a advanced revision course. Sir, can we do IRMS 1 upon IRMS 1 upon IRMS into cos phi 1. For what? IRMS 1. So you are doing, sir, here IRMS 1, okay, divide by what you are doing, divide by IRMS, okay, into what you are doing, multiply cos phi 1, you are doing cos phi 1. Okay, yeah, in this question, because VRMS is same, so what we have did here, so here first we have calculated P is nothing but VRMS 1 into IRMS 1 into cos phi 1. Okay, this was your P. And what is your cos phi? Your cos phi is nothing but this cos phi is nothing but your P divided by S. S is nothing but VRMS into IRMS. Okay, and what is P here? P is nothing but VRMS 1 into IRMS 1 into cos phi 1. Okay, so for this question, VRMS 1 and VRMS are same, so this will be cancelled out. So now you will get here, sir, cos phi is equal to this IRMS, first of IRMS divided by IRMS into cos phi 1. Okay, and this you are saying, but this, if you can remember this, but this will be valid when VRMS 1 and VRMS is same, means only VRMS having one harmonics. If VRMS you will get two harmonics, then what will happen? So at least you have to think. So my recommendation, first you will calculate VRMS, then you will calculate IRMS, then you will calculate P average, and then you will calculate cos phi. This is very basic process, but if you can remember this formula, you can go with. But remember, when VRMS 1 and VRMS is same, then you can apply directly this, because this 2 will be cancelled out. Now my next question, if I will ask you here one question, okay, this is a concept based question. If suppose VT and suppose this IT is given, and here two harmonics is given. Suppose this I am saying V1 sine, and this is omega t, this is omega 1t, plus V2 sine, this is omega 2t. Suppose, for example, I am saying this, and here the in current I1 this is sine omega 1t, and here this is I2 sine omega 2t, and one more current I am considering, I3 sine omega 3t. So if this question is given, then how you can handle? So now you can see, sir, this two frequencies same and this two frequencies same, but you should first apply your basic, the only basic concept you have to apply. So first you will find out, sir, VRMS. Sir, what is VRMS? Root over, sir, V1 by root 2 whole square plus V2 by root 2 whole square. First you will calculate VRMS. Then you will calculate, sir, IRMS. Easily you will calculate this two value. This is root over I1 by root 2. Maybe this question can be asked this year. Maybe this question can be asked this year. Till now 1 voltage mini current is provided, or DC plus AC they have provided. Till now they have not asked in voltage 2 harmonics or 2 frequency, and in current 3 frequency or more than 2 frequencies. Okay, till now examiner have not asked. In this case this formula can be mismatched. Okay, so just I will prove you why you don't have to remember this formula. So here first you will calculate this, then can I write I2 by root 2 whole square, this is IRMS, and this is I3 by root 3 whole square. So VRMS and IRMS easily you will calculate. Now target first P average. So sir, if I will target P average, or you can say P, what is the formula? Integration over this is average value and this is Vt into It. So now first you have to think, if you will multiply this with this, this with this, this with this. So if this will multiply here, omega 1 and omega 2 are different, then what you will get? Omega 1 plus omega 2, omega 1 minus omega 2. So this multiply this, average value is 0. Sir, this multiply this, average value is 0. Yes. This multiply this, you will get some average value. Yes. For this multiply this, you will again 0. For this multiply this, you will get average value. For this multiply this, again average value is 0. So what will be the formula? Can I write directly here, sir, VRMS1 into IRMS1. So for this and this you will get, sir, VRMS into cos phi 1. This is the first term. Now the second term, can I write, sir, VRMS2 into, sir, this is 2, IRMS2 into cos phi 2. So if 2 voltage is given, so can I write directly this formula? Yes, we can write. From here we are going to find out if you will solve this. So this will multiply with this. So right now you don't remember, just you have to multiply this 3. So you will get 1p. You will get 1p. And this answer you will get. Now you can also apply the superposition theorem, and now you will consider the second voltage, and second voltage will be multiplied with this. So this multiply with same frequency omega 2 and you will get this. So here this is nothing but V2 sine, sir, omega 2t. So you are getting this p. So you will calculate IRMS first and VRMS first, then IRMS, then p. Now what will be the cos phi? So here power factor cos phi will be nothing but P divided by total circuit VRMS into total circuit IRMS. Now here what is P? VRMS1, IRMS1 cos phi 1 plus VRMS2, IRMS2 cos phi 2. Now here this VRMS1 and VRMS will not be cancelled out. VRMS2 by VRMS will not be cancelled out. So this formula will be wrong in this case. That's why go with basic process. This is very good concept. So according to me, this question can be asked in GATE exam, and many students will be trapped here. Okay, this is very basic thing. So I hope now you can handle this category of question. Now the last question. So once just confirm me, this is clear or not? Crystal clear. Okay, good. Okay, crystal clear, good. And now you are saying CDF into FDF. Okay, I will not tell you, you should remember. Why you are remembering this kind of complex term? Very basic. You calculate VRMS, calculate IRMS, calculate P average, and P is nothing but VRMS IRMS cos phi. Already we have studied power factor is nothing but P by S. So power factor is nothing but for any circuit, this is nothing but magnitude of P divided by magnitude of S. S is nothing but VRMS into IRMS. And VRMS, IRMS is calculated. You can put this value, and P already you have calculated, put the value. This is the power factor. So why you are getting here confusion? Okay, but if you can remember that formula, that is good. But this formula is not valid in this case. Okay. Okay, good, good, good. Okay, good. Now, okay, good. Now the last problem from our this session. Okay, and this you have to try. Now the last problem from this session. Now the last problem. Okay, and now just note down last problem from this session. Okay, here one circuit is given, okay, with some impedance. So here one supply voltage is given, here one impedance is given, and here one more impedance is given. Okay, so this is a question from impedance, and if you can handle this question, so in impedance question you can handle. So first Zs is 1 plus Z2. So this is given Zs, and Zs is supply, you can say impedance, this is 1 plus Z2, and this is Zl. Okay, and Zl is given here 7 plus Z4. This is 7 plus Z4. Okay, and this supply voltage is given here 20 at angle 0 degree. This is voltage plus minus 20 at angle 0 degree. This is volt. This is volt. Okay, this three things is given. This three things is given. Now the AC source are RMS voltage. So here RMS voltage is 20. So if examiner will not provide you, always what we will consider this is VRMS is equal to 20. Okay, already I tell you this thing. If polar form is given, always you have to consider RMS value. And now what examiner are asking? The reactive power consumed by the load is. So examiner are asking reactive power consumed by the load is. Okay, you have to solve. 4 options I am going to provide you. First option, 8 volt ampere reactive power unit will be 8 VAR. Yes. Now the second option is a 16 VAR. Third option is 28 VAR, and last option is 32 VAR. Okay, this is very basic question. If you can handle this easily, you can handle. When impedance will be provided, the question will be easier. Okay, but one thing you remember, don't target S, always target P, Q and then S. Then you will not get wrong in GATE exam. Okay, so what protocol we have to follow in resonance? What protocol we have to follow in this complex power? This is very, very important. So now I am waiting for your answer. I am waiting for your answer. How you can handle? So here two category of questions can be asked by the examiner. Here the important thing is, what important thing? Okay, can you try? Okay, I am going to solve because time is okay, we don't have much time now. So examiner are interested in load. This is the important thing, reactive power consumed by the load. So you have to find out QL. This is the important thing. What this is not supply reactive power, this is a load reactive power. So remember my word. So this is the load. If examiner are interested in total Q supply, or you can say Q of the whole circuit, that will be different. Are you getting my point? So here reactive power, real active power, reactive power. So I can write here, sir, PS and here plus JQS. Can I write? Can I write here? This is for sir here active power, reactive power. Sir here load active power and load reactive power, and this is total circuit. So you can also write, sir, here this is P plus CQ. Total active power and reactive power. Are you getting this thing? So what examiner are asking? Only this thing is very, very important. So if examiner will ask you from the impedance, what should be your target? Calculate current. If you will calculate current here, IRMS. So easily you can handle. Here current you can find out, here current you can find out, and already rectangular form is given. So first you will calculate IRMS. So what is IRMS? So IRMS is nothing but voltage is the VRMS is 20 divided by your impedance. I can write, sir, 1 plus 7, 8, 8 plus J6. So this is nothing but, sir, 8 plus J6. So what will be this value? So 20 upon root over 8 square 64 plus 6 square, that is 36, root over 100. Root over 100 is 10, and here angle tan inverse 3 by 4. Can I write? So what IRMS you are getting? Sir, IRMS we are getting 20 by 10. This is 2 at angle minus of tan inverse 3 by 4. And this is magnitude of IRMS is required. So magnitude of IRMS is 2 ampere. And already magnitude of VRMS whole circuit. This is whole circuit. This is given 20. Now the important thing is here. This current, you have to find out current across here. Here this current you have to find out. So this current and this current is same. Yes, same current. So here easily you can find out power across, active power across load. So if examiner will ask you, sir, what is PL? So PL is nothing but sir, IRMS square into a real part of the load. So this is nothing but 2 square. This is 2 square into real part of the load is 7. So this is 7 into 4. This is 28 watt. But examiner are not asking power. Sometimes that's why 28 is in the option. Now you have to find out here, sir, reactive power across the load. So this is nothing but IRMS square into this is XL. So here this is the 2 square, and what is XL? XL is here 4. So this is nothing but 4 into 4. This is 16 VAR. So now if I will ask you, sir, this Q will be positive or negative? Now my next question, sir, this reactive power is here positive or negative? You can say this is 7 plus J4. So here angle is positive. If angle is positive, means circuit is inductive. If circuit is inductive, then Q will be positive. So Q will be here positive. Generally examiner will not ask you Q is positive or negative, but just for your knowledge, here Q will be positive. Why Q will be positive? Because this is 7 plus J4, here angle is positive, means this is inductor. If circuit is inductor, so Q will be positive. Now here examiner can also ask you, I hope this thing is clear to all of you. Now examiner can also ask you here, I hope this thing is clear. Now, sir, what is here PS and what is here QS? So if examiner are interested in here, what is PS? So same current is flowing. So again IRMS square into RS. This is nothing but 4 into what is RS? That is 1. So this is nothing but 4 watt. This is nothing but 4 watt. Sir, what is QS? QS is nothing but mod of IRMS square into XS. Again this is what you are getting, sir. This is your 4 into 2. This is 8 VAR. So here P plus JQ you can write, here P plus JQ you can write. Now the important thing is here, sir, this Q is positive or negative? This is positive because this is positive. So can you write a total circuit P plus JQ? Now my question, can you write, sir, S is equal to P plus JQ both? So this Q you can write, sir, this is J8. Can you write J8? Yes. Okay. Otherwise already you have calculated, sir, this is positive. So this P plus can I write P plus JQS plus PL plus JQL. Now this is correct or wrong? This is correct or wrong? This is correct or wrong? Anybody can tell me? Anybody can tell me this is correct or wrong? This is correct or wrong? So now you can put the value. You can put the value, sir. PS is nothing but 4 plus this is J8 and this is PL is your, this is the 28 plus J16. Now here 28 plus 4, 32 plus this is J, this is 24. This is your S. So from here magnitude and angle you can find out. So what is S? S is root over 32 square plus 24 square. This is magnitude of S, and angle is tan inverse 24 by 32. This is the complex power. Like this you can handle. So what exactly examiner are asking? This is very important. So they are asking reactive power consumed by the load is, but we have calculated all the thing. Active power here, reactive power here, active power here, reactive power here, whole circuit active power, reactive power, whole circuit complex power. If examiner are asking, sir, what is the complex power here? What is the complex power across load? Sir, what is the complex power across S? So examiner can also ask you, sir, what is SL? Sir, what is SS? Complex power. So here this is nothing but this across the load is 28 plus J, sorry, this is 28 plus j 16. Sir, what is a complex power across here? What is complex power across here? Sir, this is 4 plus z8. Sir, this is 4 plus z8. 4 plus z8. Complex power. Okay, complex power you can find out in this way. Okay. So I hope like this you can handle the question. Okay, so what will be this answer? What will be this complete answer? 32 square plus 24 square. Okay, you can calculate this. You can calculate. Otherwise, complex power you can also calculate from here. VRMS is already know, and IRMS already you have calculated. So VRMS into IRMS from here you can also calculate. So 20 into 2, this is a 40. So magnitude of S, this we are getting 40 or not? This we are getting 40 or not? This we are getting 40 or not? Just tell me. Just tell me we are getting 40 or not? This we are getting 40 or not? 32 square plus. Tell me 32 square plus. 32 square is 1024. This is 1024. And what is 24 square? What is 24 square is 24 square is 24 square is 576. 576. So what is this? This is 6 plus 4, this is 10, and this is 7 plus 2 9 plus 1 10, and this is the, you can say 1600. So this is 1600. So root over 1600 you are getting here, this is 40. This is 40, and angle tan inverse, this is 24, means this is 8 into this is 4, not okay. This is 12 by 16, and then 6 by 8, then 6 by 8. You can also write 3 by 4, tan inverse 3 by 4, tan inverse 3 by 4. Okay, 8 into 3 and 8 into 4. Okay, so like this you can handle. So if you can calculate here real power, means active power, reactive power, active power, reactive power. So both the real power will be added and imaginary power or reactive power will be added. So this is very good problem. Here we have did lots of analysis. Now examiner can ask you what is the power factor. So power factor here you can say here impedance angle already tan inverse 2 by 1. What is here power factor, sir? Tan inverse 4 by 7. Sir, what is complete circuit power factor? Here this angle is 0, and early angle you have find it out tan inverse here 3 by 4. So power factor easily you can tell me here. This is angle is tan inverse 3 by 4. Suppose this angle is phi. So cos phi is the power factor. Cos phi is the power factor. Okay, so I hope I have did so many things here. Okay, so I have completed all the topics. I have completed all the topics here. I have completed all the topics here. Okay, so now from my side your this marathon session for, or you can say this revision session for network theory is over. Now in next 6 days I am going to planning 2 day for digital, 2 day for signal, and 2 day for communication. Okay, so tomorrow you will get the link. Already one link is already created for signal and system, but at least you can see it can be changed. Okay, so for next 6 day, okay, so for next 6 day, okay, we will conduct one session 2 day for digital, 2 day for communication, 2 day for signal. Okay, so I did each and every topic in well manner. Okay, and every topic I have covered in this session. So definitely I hope this will be beneficial to you, and definitely you will do good in your this network theory subject, in all subject also. Okay, and definitely I hope what we have studied here, direct question definitely you will get in GATE exam from here. Okay, so now I am going to here end the today session, and we will meet in next session with another subject. Okay, so everyone take care. Okay, good night, bye bye, and Jai Hind. If anybody have any doubt, you can post. If anybody have any doubt, you can post. Otherwise, I am going to end the session. Okay, otherwise I am going to end the session. Okay, if anybody have any doubt, just post. No doubt, everyone? Okay, last call. If anybody have any doubt, just you can ask me. If anybody have any doubt, just ask me. Okay, so we will meet in next session. Okay, thank you. Take care once again. Bye bye and Jai Hind and good night.